Hello and welcome to this complete course on C Sharp. In this course, we are going to learn C Sharp from very basics to advanced level. If you are a beginner and want to learn how to write programs in C Sharp, then this is the only video that you are going to need. So, without any delay, let's get started and first learn what exactly is C Sharp. C Sharp is a programming language. It was created by Microsoft in 2002. C Sharp is very simple to learn and it's very fast and it's getting very popular nowadays, and it has a very huge community that will help us if we stuck somewhere. In this part of the video we will understand the features of C Sharp. So first of all, C Sharp is an object-oriented programming. It means we will create classes and then we will create objects of those classes. If you don't know what are classes and what are objects, don't worry, we are going to study them in the future videos. Second feature is type safety. C# provides us type safety, which means if I declare anything of integer type, let's say integer a, I will be able to store only numbers in this variable. I can say a equal to 5, I can say equal to 0, I can say a equal to -1. I won't be able to say a equal to apple. If I try to do this, C# compiler will yell at me and it will throw me an error. Feature is versatile. It means C# is a very versatile language. It can be used in web apps, it can be used in mobile application, it can be used in developing web APIs, it can be used in game development, and even it can be used in VR headset development also. So now let's go ahead and write a simple hello world program in Visual Studio. So I have my Visual Studio opened up here. Here you can see one option here to create a new project. Let's select this and create our first project in C#. Once that is done, you will see a lot of options here that you can select. So these are basically the templates which are available in the Visual Studio. Let's first choose the console application and click on next. Once it is done, it will ask us to write the application name, and we have to first specify the project name and we have to specify the solution name. We can specify, if we take this mark, place solution and project in the same directory, it will create our solution and project with the same name. Let's go ahead and write some name for our project. Demo C#. Once that is done, you can just go ahead and click on next. On this window, you have to select which version of .NET you want to use in your application. Don't worry if you don't know what is .NET. We are going to cover everything about .NET in future videos. If you see here, we have a lot of version available. .NET 3.1, 5.0, 6.0, 8.0. Currently 3.1 and 5.0 are out of scope, so I will not recommend to use these versions. So if you're creating your brand new application, please consider choosing .NET 6. Once that is selected, you can click on the create button. So it will do its magic and create the project for you. We have the project name, that is demo C#. We have some dependencies which are added by the Visual Studio, and we have our program.cs file. We have the first line, that is console.writeLine. In that we are writing one message, hello.world, and there is one comment on the first line that we can just go ahead and remove it. So I will just remove this comment. And if you see above, there is one green button, demo C#. It means if I click on this button, this code is going to compile and run on the console app. Let's see this in action. You can see here hello world is getting printed. So we have created our first application in C#. Now let's understand the syntax which you have just written for our program. Here we have the console class, and we are using one method from console class, and this is our message which we want to write on the console. So don't worry if you don't know about what is end class and what is end method. We will understand everything in the future videos. When I'm writing the right line, I'm using these brackets because this is important. If we don't specify these brackets, the compiler will give us the error saying the syntax is not correct. After writing that bracket, I'm giving these double quotes, and within this double quotes, I'm writing my string which I want to print. And then I'm closing this method call with the closing bracket also, and at the end I'm using this semicolon. Semicolon is very important because at the every line of code we have to put semicolon. With this semicolon, compiler will know this line ends here. So if I remove this semicolon from the end and try to run this application, it is going to give me an error. If you see below, it is already yelling about it. It is saying semicolon is expected, but we have not given that. You can see the red line also coming here, which means we have one error here. If I put the semicolon here, it will go back to the normal state. The syntax is correct again. I can go ahead and click on my green play button again. Once that is done, it will compile the code and it will run the code again when we can see hello world. So that's it guys, that's all for the first video. In the next video we will learn how to install Visual Studio. Thank you for watching. Hello everyone, welcome to the second part of this video series. In this video we will see how we can install Visual Studio in our machine. In this video you will see how we can install Visual Studio Community Edition. After that, I will give you a walkthrough of Visual Studio. We will understand what are the features of Visual Studio, and we are going to see some basic keyboard shortcuts. First, you need to go on to the Google, and here you can search install Visual Studio, and you have to select the first link. You have to come to this URL. Once you are at this URL, you will see the three links here. For community, professional and enterprise editions, you have to select the community edition because this is free for us. You will just go ahead and click on free download. Once that is done, it will download the Visual Studio installer for you. Once the installer is downloaded, you can go ahead and double click on the installer. On this pop-up, you have to give continue. Once the Visual Studio installer is installed in your machine, you will be able to see two tabs there. You will see installed and available. So all the available software will be coming into this tab, and whatever software you have installed will be coming onto the install tab. Here you can see I have the Visual Studio Community 2022 preview that is available to me. I can go ahead and click on install button. Once you install this, you will have Visual Studio in your machine. One thing you have to make sure when you are installing the Visual Studio, you have to check this particular module which says ASP.NET and web development, because we are going to use .NET to develop our application in this video series. So I will recommend you to check this checkbox and then go ahead and click on install button. Once the installation is done, you can come back to your start menu and you will see your Visual Studio will be there. If it is not there, you can just search Visual Studio and you will see the option there. Just click on that. It will start up the Visual Studio. Once the Visual Studio is running, you will see the four options there: clone a repository, open a project from solution, open a local folder, or create a new project. So clone a repository means if you have your code on GitHub or Azure DevOps, you can use this option to get that code into Visual Studio and start editing that. If you have your project or solution in your local system, you can choose this option and this will open your solution files or project within the Visual Studio. And if you have any particular files which are not belonging to any project or solution, you can still go ahead and open those folder and edit those files. And if you want to create a new project, you will click on the create a new project button. That's what we are going to do in this video. After clicking on create a new project, you will see a lot of options there. You will particularly will be seeing the three drop downs. First drop down belongs to the languages, in which language you want to create your project. There you will see multiple options: C sharp, F sharp, C++, JavaScript, and lot more. In the second drop down, you can see which platform you want to use, like where you want to deploy your application. Once it is done, you will see Android, Azure, iOS, Linux, Mac OS, and Windows. And third drop down will tell you which type of project you want to create. Here we have multiple options like console, desktop, games, library, SQL, and many other objects. So for this demo, we will select C Sharp as a programming language. We will select Windows as our platform, and we will select the console as our project type. So let's select this template and click on next. Once you are at this window, you have to specify the project name. I am just going to give demo C Sharp. And second field, in this field we have to give the location where I want to create the project. I will keep it as a default, and I have to click on next. Once we are on this window, we have to specify the version which we should be using in this application. Currently I have 4 options here. If you have multiple .NET version installed, you will see multiple options there. But for now, I will select the .NET 6 version and click on create button. It will take some time to create the project for you. Once the project is created, you will see the program.cs file. This is where we will write the code, and you will see the green play button there. This is nothing but to start the application. So I will just go ahead and click on it. So it will build my project and it will run on the console window. You can see the hello world is getting printed here. So we have successfully installed and created our first project in Visual Studio. And guys, if you want a good resource to know how to install Visual Studio step by step, you can come to this URL. I will provide this link in the description, so you can just easily follow this tutorial. Here you will see all the steps which are required. So by the way, website name is javapine.com, so you can go ahead and browse this website and come to this URL. Here you will see all these steps. Like in the first step, you need to download the community edition of the Visual Studio using this button, and again you can see the website name here, visualstudio.microsoft.com/downloads. Once you are at this page, you will select the free download button. Once it is downloaded, your file will be there in your downloads folder, and you have to click on run button. Once the Visual Studio installer is installed, you will see there you will see multiple options from where you can choose your Visual Studio version, and you will go ahead and click on install. When you are installing the Visual Studio, you will get multiple options. As I said earlier, you have to select the .NET desktop development, and you have to select the .NET and web development also. So just select the first option and click on install. So the installation will get started, and once it is installed, you can click on the launch button, and similar way Visual Studio will start, and you can select your particular theme which you want to use. You have 4 themes by default: blue with extra contrast, dark, and light theme. Once the theme is selected, you can just go ahead and click on start Visual Studio, and after that you will see all the 4 options which we have just discussed earlier. You can just click on the create new project and your new project will be created. So this is the URL where you have to navigate and download the Visual Studio. This is visualstudio.microsoft.com/downloads. So let's see some of the keyboard shortcuts that are available in Visual Studio. First one is F5. So if you press F5, what will happen? Our project will be built, and once that is built, then the project will start in debugging mode. I will go ahead and put a breakpoint there, and I will click on the green button, or I will just press F5. So the application is starting in debugging mode. We can see the debug point is also getting hit here. So it means the application is running on debug mode, and because we are on the breakpoint, nothing will get print. If I give continue, then it will move from that debug point and the hello world will be get printed. In shortcut is Control F5. This will run our application without debugging mode. I will press Control and F5. It will run our application. You can say this time we didn't hit our debug point, and we already see the hello world is printed here. So it means the application didn't go to debug mode. Third option is Control Shift B. This is to build your project. So I will just go ahead and I will press Control Shift and B button. You can see the build was succeeded. What I will do, I will just go ahead and clean the build first because I have built the project earlier. So now you can see the build was removed, and now we have the clean code. Now I will go ahead and build the project again. This time you can see build 1 succeeded, and you can see at this time the build was completed, and it took only 0.8 seconds to complete the build. Next shortcut is Control plus scroll up and Control plus scroll down. This is basically to zoom in and zoom out in the window. If I press the Control button and scroll up, this will zoom in, and if I scroll down, it will zoom out. So these are some basic shortcuts that we can use in Visual Studio. So that's it for this video, guys. In the next video we will learn about the C# data types. Thank you for watching. Hello and welcome. In this video we are going to understand what are the C# data types. So let's get started. In this video you will see what are the basic data types available in C#, and we will also see some of the most popular data types like boolean, integer, floats, strings. So here I have created one demo project for this video. Let me delete everything. First of all, what are data types? Data types are something that we need to declare when we are declaring a variable. Let's say if I want to create a variable of integer type and want to store value something, let's say 10 in this. So whenever I am declaring the variable a, I have to specify the type of that variable. In this example, a is of integer type. Let's take an example where I want to store number of books that I have. So I want to keep track of number of books. I will declare a variable of integer type because the number of books will always be an integer. I will say number of books. And I can store the number whatever I want to store in this variable. So this is the purpose of data types. Whenever we are declaring a variable, we have to define the type of that variable. In this example, the type is integer. We have other types like if we want to store what is the temperature today. So for those you can use float types. Let's say temperature equal to 40.5. We have to end it with f because this is a float type. So we have to tell the compiler I am storing a float number. So we have to end it with f. So this is our float type. And the next type we have boolean type. Boolean is basically if you want to store something true or false, we will use boolean. Let's say I want to store if someone has passed the exam or not. I will create boolean type has passed the exam. What we can store here, store true, or I can store false in this. So if the person has passed the exam, we will store true in it. If the person has not passed the exam, we will store false in that. So this is how we can use the boolean data type. Let's move on to the next data type, that is of string type. Let's say string name Peter. So here we have declared a name variable of string type and we have stored Peter in that variable value. Let's see some of the other data types that are available in C Sharp here. These are the integer data types basically which are available. First one is the signed byte. In short, we call it S byte, which can store values from -128 to 127. Because the size of this bit is 8 integer and all 8 integer can store zeros and 1. And the first bit will be allocated to the sign, so we will be remaining with the 7 bits. So let's see this in action, how we have calculated -128 to -127 for this S byte. So we saw the type S byte there, which was storing values from -128 to +127, and it was of 8 bit. 8 bit means we have 8 bits here like that: 1 2 3 4 5 6 7 and 8. Each of these bits can store zeros and 1, and the first bit is allocated to the sign symbol. So 0 means negative and the 1 means positive. And for the other 7 bits we can either store zeros and ones also. So these 7 bits are used to define the number. What is the number we want to store? If I want to store zeros, so all these bits will be 0. So that's how the number will be stored in an 8-bit array. After that, we can see there are 7 bits which are available and all have two possibilities. Either we can store 0 or we can store 1. So the maximum number that we can store is 2 raised to the power 7, which is nothing but 128. Because we are starting from 0, so we have to calculate 0 also. So that's why we are able to store only till 127. And on the negative side, we can store till -128. So let's go back and see the other data types. Next, we have the unsigned byte. In the S byte, we were having one bit allocated for the sign symbol, but here we don't have anything like that. It will only store the positive numbers from 0 to 255. We have the short, which can store values from -32,768 to +32,767. We have the U short, which can store values from 0 to 65,535. Similarly, we have the most popular data type, integer, which is a 32-bit integer, which can store values from, you can see this is a very big number which we can store in this type of data type. We have the other data types also, which you can go through. I will put this link in the description so you can check it out and see what are the other data types we have. And you don't have to remember the range of these numbers. You can see this in Visual Studio. If you go to Visual Studio and declare one S type of variable, let me declare it as A, and I will store 4 in it. What I can do, I can check the maximum value which I can store in S byte using S byte keyword. So let me write console write line. I want to print the maximum value which the S byte can store. S byte, I will do dot here, and I can see we have the max value property. If I run this program, I can see 127 is getting printed here because the maximum value S byte can store is 127. Similarly, if I want to see the minimum value which this can store, I can use the min value property and run the program again. I can see the -28. So this is how you can find out the max and min value without remembering it. Let's see how we can use hexadecimal and binary numbers for the integers. Here I have the number 42 and I have converted it to the hexadecimal at line number 5, and still I'm storing it in integer type. At line number 6 I have converted the 42 number to the binary numbers, and again I'm storing it in the integer type. Let's see how the output will look like if we run this. As you can see, all three are giving me 42, which proves we can store the numbers in any format. We can use the hexadecimal format to store the numbers. Even we can use the binary format to store the numbers. One thing to notice here, we can use these underscore to separate the digits. Let's see one more example of it. Let's say if I want to store a number, let's say 20,000, I can store it like that, or even I can separate the digits using an underscore. That will also work. Let's see some of the floating point types which we have in C#. First one is the float type. Second one is the double. Third one is the decimal. Float type is the smallest one. It can store from 9 to 6 digits of precision. Double can store from 15 to 17 digits of precision. Decimal can store from 28 to 29 digits of precision. I have declared the float here, and you can see after declaring the value, I have to put F there to tell the compiler this is a float type. Similarly, for the double, I have to put D at the end to tell the compiler it is of double type. Similarly, for the decimal, I have to put M at the end to tell the compiler it is of decimal type. Let me click on the run button and let's see how these values are getting printed here. As you can see here, values are getting printed, whatever we have stored there. I want to show you the one last data type in this video, that is the char type. Char is basically if you want to store only one character, then we can use this char type that will take the value in the single quotes. Char can be used like if you want to store some grades in it, like if you want to store your grade, if it is A, B, C or D, you can use this for those kind of scenarios. So in this video, we have studied the Boolean, integral, numeric, float and double and decimal data types. And also we have seen the string data type and char. This is the URL which you can use and go ahead and see all the data types which are available in C#. In the next video, we will see the string data type in detail. Thank you for watching. Hello and welcome to my channel. In this video, we are going to learn about string type of C#. A string is basically used everywhere in day-to-day life. If you want to store your name, you will use a string. If you want to store your address, you will use a string. If you want to store your job title, you will use a string. So most of the things that we see in our real life are strings. Before moving on, let's see what you will learn in this video. We will see the C type in C#. We will see the escape sequence. We will see the verbatim literal, and we will also see the string interpolation. So let's get started. I have opened my Visual Studio here. If you don't know how to install Visual Studio, you can watch the second part of this video series where we have explained how to install Visual Studio. So let me create one console application. I will click on next. I will give a project name here, demo string, and I will just create on next here. I will choose the .NET version 6, and the project is created here. Let me delete everything. Let me zoom in a bit. Okay, so when we say string are usually defined in double quotes. Like if I want to store my name, I will enter Parvesh, and let me create a variable to store this Parvesh. I will create the variable with string keyword. I will give the variable a name, let's say name variable, and I will store the string in it. So that's how you will declare a string and you will set some value to it. If I print this variable, let's say name, as you can see, my name is getting printed here. So let's say the requirement is I want to print the double quotes also. Like I want to print something like Parvesh. Like this, I want to print the message. And for this, if I go ahead and put double quote here, if we see here, we are getting one error message here saying syntax is not correct. If I open the error window, I can see here syntax is not correct. And let's see how it was before. It was like this. There we were not getting any compilation error, but if I try to put a double quote there, it starts giving me an error. It says syntax is not correct. Because if you see here, every string in C sharp starts with a double quote and it ends with a double quote. But if I try to put a double quote in between, it will think the string is completed till here, and I don't know what about this, like, because this is not correct syntax here. That's why we are getting a compilation error. So in order to tell the compiler like I want to print the double quote also, this should not be treated as a special character. What I can do, I can use the escape sequence, that is backward slash in C sharp. So if I put a backward slash, you can clearly see here it has turned into purple color. It means it treat this double quote as a normal string, not as the special character that is used to start and end of the string. So if I want to put a double quote at the end also, I can put it like that, and I have to escape this character using the backward slash. So if I go ahead and print this name, you can see now my name is getting printed, but I also have the double quotes at the start and at the end. Let's say we have one more requirement. In that we want to print a string, something like that. In the first line, I want to print eat. In second line, I want to print code. And in third line, I want to print sleep. So let's say I have declared a variable, let's say message, and I want to print eat, new line, code, sleep. So to move it to the new line, if I go ahead and print this message, here you can see these are showing up in the new lines. The eat is coming at line number 5, code is coming at line number 6, sleep is coming at line number 7. But if I print this message, sorry, we didn't give the print command. If I print this message, you can see here all the three words are coming in this single line. This is happening because compiler don't know where we have the line breaks. We have to tell the compiler where we need to break the line, and we need to move the text to the next line. To tell the compiler where we have the line breaks, we can use the backward slash and we can use the n character. So we have this backward slash n, which is known as new line character. So if I put my breakpoints after each word, you can see if I print this message, this is coming at the new line as expected. So now let's say requirement is I want to print a string that has a lot of backward slashes in it. For example, let's say I want to print a folder path that look like this. If you see here, there are a lot of backward slashes. If I try to print it without any escape character, compiler will automatically add the escape sequences for us. Go ahead and run this once and see how it is looking. If you see here, our folder path is getting printed here without any issues. But if you see the string that we have at line number 3, it is having a lot of double backward slashes, which is not the case in the normal folder location. So it is not very readable. In order to remove these backward slashes, what we can do, we can use a verbatim literal. Let's see this in action. First, let me remove the backward slashes. If you see, compiler is again complaining about the backward slashes because we have to escape these backward slashes. We cannot have this in a normal string. So in order to escape all the backward slashes in with single character, for that we can use our @symbol. If I put that @symbol, compiler will know whatever is coming after it should be treated as a normal string. So if I go ahead and print this message again, we can see the normal folder path is getting printed. Let's see how we can work with multiple string. Let's say I have a string variable, first name. Let's say Peter. And let's say we have the last name variable. Let's say Parker. So now the requirement is I want to print the whole name on the console window. So the output should look like Peter Parker. There are multiple ways to achieve it. First one is we can concat the string using the plus operator. Let me declare a variable full name and I can say first name plus last name. And to separate the first name and last name, I can put a single space there. And let's go ahead and print this full name. If you see here, Peter Parker is getting printed here. The other way to do this is using the concat method. So let me use the concat method here. I will create the full name variable. Let me comment it out first. So I can use the string keyword and I can call concat method here. So this way also we can concat the two strings. So I can put a double quote to separate these first name and last name. And now if I go ahead and print it, we can see again the Peter Parker is getting printed here. So this is the another way that we can use. And the third way is to use the string interpolation. To use string interpolation means you can use a dollar symbol and start writing your string. In this, if you want to use a variable, you can use the variable using the curly brackets. I can put first name here, I will give a space and I will give the last name here. If I go ahead and print it, we can say again Peter Parker is getting printed here. But if you see here, this is the most readable format here. Here we are just using the string interpolator starting with the dollar sign, and within the double quotes we are creating our string. And the good thing about this is if you want to add any other string characters, we can easily add it like this. Let's say my name is, if we go ahead and print it, we can see my name is Peter Parker is getting printed. So this is how you will use the string interpolation. Let's see some of the common methods that we can use with strings, which are concat, which we just see how we can concat two strings. We can use two upper to create the string in uppercase. We can use two lower to make the string to lowercase. We can use index to find the index of particular character within a string, or we can use substring to trim or cut the string based on the requirement, and we can use the length property of string to find the length of the string. Let's see this in Visual Studio. Let me clear it up. Let's say now I want to change my name to the uppercase. So I can create a variable string upper case, and I can use first name dot to upper. So this will change my text to uppercase. Let me print it. You can see Peter is getting printed in uppercase. Similarly, you can use to lower. That will print the name in lowercase. Now let's say I want to find the index. I want to find the position where T is there in my string. If you see in Peter, we have the T at the third position, 1, 2, and 3. So in C sharp, the counting starts from the 0 position. So P is at 0th location, E is at the first location, and T is at second location. So let's see how to find the location of T using the string index of method. Let me declare a variable integer and call it index of T, and I can use the first name variable and I can call index of, and within this I can pass T because I want to find the index where T is available. Let me print the index of T now. If you see here, 2 is getting printed because T is available at the second location. Let's see the substring method once. Let's say now I want to divide this string and just want to print the pet instead of the complete Peter. I can use substring method for that. Let me use that string substring equal to first name dot. I can use substring, and if you see, Visual Studio will give you the options how you can use the substring. If I want to take the string from a particular location, let's say I want to start from second index location and take the complete string. Let's see what is getting printed in this case. You can see only the last part of the name is getting printed. That is starting from the T, because if you see here, I have given the 2 index here, and we know at the second location T was there. So it started from T and it has printed all the characters which were available from T. Let's use the substring method in another fashion. Let's say we have the string Peter Parker, and I want to start from T and I want to end it till R. So let's say how we can do it. I will start from the second location and I can give the length in this case, which is, if I count it from here, 3 characters from here, 3 characters from here, that makes it 6. And we have the 1 space character also. So we have to totally print the 7 characters. So I will put 7 here. Again, second is the index from where we want to start. 7 is the length which you want to take from that second location. So if I go ahead and print it, you can see as expected it is printing the TER from Peter and it is taking PAR from the Parker. So guys, this is how you can use the substring method. One more thing I want to show you, like if you want to find the length of the string, you can use the length property of the string. Let's say I want to find the length of first name. What is the length of first name? For that, I will declare a variable length of integer type, and I can just simply set it first name dot length. So this dot length property will give me the length. So if I go ahead and print it, we can see length 12 is getting printed here. That's it guys. In the next video we will see how we can get inputs from the user using the console window. Thank you for watching. Hello and welcome to the part 5 of this series. In this video, we will see how we can receive inputs from the user and how we can use those inputs in our program. In this section, we will see how we can receive input from console window, how we can use read line and read key methods, what is the difference between write line and write method, and we will see how C# is a case sensitive programming language. So let's go to the Visual Studio and see this in action. Here I open my Visual Studio with a brand new project. If you remember from the first video how we were writing the message to the console window, we were using the console method and we were using the write line method from that class, and we were writing our message, hello world. So the console is a class name and we were using write line method from that class and writing this message. If I run this program, I can see hello world is getting printed. So now the requirement is I want to take the name from the user and I want to print that particular name in the console window. Like if I enter Peter, so I should be printing hello Peter. So in order to achieve this, well, let me remove the first line. So in order to achieve this, first we need to use console dot read line method. What this method will do, when we say read line, it will be reading a line from the console. Whatever the user is entering, it will read that line and it will return that line. If you see this pop-up here, you can clearly see it will return me a string. So I can store whatever is coming from this method in a string variable. And we have already seen how we can create string variables. I will use the string keyword and I will give it some name. So whatever user is entering, we are storing it in the name variable. So let's go ahead and try to print this. Okay. If I run the program now, you can see cursor is blinking here because it is waiting for us to enter the input. So if I go ahead and write the name Peter and press enter, we can see Peter is getting printed here. So let's see how we can improve this program. So when asking the user's input, I want to show a message like please enter your name, something like that. Let me say please enter your name. After seeing this message, user will enter their name and we will pick that name, and I want to say hello and I will concatenate it with the user's input. So let's see this in action. Now you can see I am getting this message, please enter your name, and the cursor is blinking here, meaning it is waiting for us to provide the input. So let me write Peter again and press enter. This time you can see, as expected, it is printing hello Peter on the console window. So we have successfully received the input from the user and we have presented that input back to the user. Now let's see how we can improve the concatenation that is happening here. So this is the one way of concatenating string, like I'm concatenating hello with the name variable. I can achieve the same thing using the different syntax. I can use my curly brackets and I will provide the placeholder 0 and then I can provide the variable name. If you see here what is happening, it is taking this string format and it will look for these curly braces, and wherever it will find the curly braces, it will replace that curly braces with the variable value. Let's see what will happen when we run this program. Let me enter John this time. And you can see hello John is getting printed. This is one of the way to achieve concatenation. There is third way, It is the most preferred way nowadays. uh, that is string interpolation. If you remember the last video, in the last video we have discussed how we can do the string interpolation. To do the string interpolation, I have to start my string with the dollar symbol, and within the string I can give my message hello, and I can use curly braces, and I can provide the variable name. It's very simple. If I go ahead and run it and provide my name Peter, you can see again the same message is getting printed, hello Peter. With the string interpolation, it is very easy to concat multiple string. Let's say the requirement is we want to get first name and then the last name and then print the complete name of the user. So I will first ask user to input their first name, and I will wait for the input, and this time I will store the input in a first name variable, and I will again ask the user to enter the and I will again ask the user to enter the last name. Sorry, we have to use the right line here, and let me create a variable for last name and get it from the console. So once we have these two variables, I can show these two variables using string interpolation. I will first write the first name, and I will give one space, and I will write the last name. I am asking the user to provide the first name. I am storing that first name in the variable at line number 7. I am asking the user to enter their last name, and I am storing the last name in the last name variable. On the line number 13, I am printing the user's name using the string interpolation method. So let's see this in action. We can see it is asking me my first name. Let me enter Peter, and it is asking me to enter the last name. I will just enter Parker. If you see, as expected, it has printed the hello Peter Parker. Now let's see the purpose of console write method. If I run this program, you can see we have printed this message, but the cursor is blinking at the new line. So we have printed this message and it is coming to the next line and waiting for the input here. Ideally, it should wait for the input in the first line itself. So let's see how we can achieve it. If we don't want to cursor to go to next line, what we can do, we can use the write method instead of using write line. If I change it here and change that here also, let's keep write line here so we can see the difference. And let me run the program again. If you see this time, please enter first name message is coming on the first line and cursor is also blinking at the first line. So I will enter the name Peter, and again the cursor is blinking on the same line as expected, and you can see the name is getting printed. So this is how you can use console.write method when you don't want cursor to move to the next line. Let's see the console read key method in action. Suppose the requirement is whatever the key user is pressing that you want to capture using your program. Let's write console dot read key, and on that let's call the key char. So what is happening here? We are using read key method that will give us the key information which is clicked, and key char property will give me the key name which was pressed. So let me store this information in a char variable. Let me call it key, and let me print a message saying user has pressed this key. Let me start this message with the new line character so that we can see this message in better way. This time cursor is blinking. Let me press S key. Now you can see we have pressed S and that was captured, and we have printed the message saying user has pressed S key. So guys, this is how you can use read key, read line methods. Let's see how we can add the comments on our program. Let's say I want to comment the line number 9. For that, you can press the shortcut Ctrl K plus C. So if I press Ctrl K and then C button, you can see Visual Studio is commenting my line. If I uncomment this line again, I can press Ctrl K plus U. So you can use Ctrl K plus C to comment the line, or you can use Ctrl K plus U to uncomment the line. If you don't want to use the keyboard shortcuts, you can see we have the two icons here. First one is to comment the line and second one is to uncomment the line. If I press the first button, it will comment my line, and if I press the second button, it will uncomment my line. Okay, so one of the feature of C# is that it is case sensitive language. What we mean by that? Let's see this in demo. We have a variable string name and I have defined it as Peter. And now I will print this name. If you see here, I have used the same casing which is used in the variable in the message also. If I try to change the case of n here, what will happen? Compiler will start giving me error saying I don't know where we have this variable because I have defined the variable with capital N. Basically, C# is case sensitive language and we have to respect the casing of the variables. So if I have the N in caps here, I have to keep the same case here also. Now if you see, the error is gone and we can go ahead and print the name. Okay. So yeah, program is working as expected. That's it for this video, guys. In the next video, we will see how we can use the common operators of C#. Hello and welcome to the part 6 of this video series. In this video, we are going to see some of the C# operators. So let's get started. We have multiple type of operators in C#. First one is assignment operator. Second one is arithmetic operator. We have comparison operators. We have conditional operators. And we have ternary operators. Let's see one by one what are these, and we will see the demo of these operators. First one is the assignment operator. That is nothing but the equal to sign. Let's see this in Visual Studio. I have opened my Visual Studio. Here I have one empty project. So let's see how we use the arithmetic operator. Arithmetic operator we have already seen. If whenever we are declaring a variable, let's say let me declare a variable string name equal to Parvesh. If you see here, after string name, we are using equal to symbol. That is nothing but is our assignment operator. So using assignment operator, we can assign any value to a variable. Let's see another example. Int variable a, maybe value 15. So here we are assigning value 15 to a variable using assignment operator, that is equal to. Next operators are arithmetic operators, which are add, subtract, multiply, divide, and modulo. Let's see them in action. Let me create some variable integer a, let's say 20, integer b, value 30, and let's say I want to add up this number, so I can use my arithmetic operator add, that is plus sign, and I can declare variable result equal to a plus b, and I can print my result using console.writeLine. Result is whatever result is. Let's run this program. I can see result 50 is coming up here. Similarly, we can use subtract. Result is -10. We have multiply operator. That is asterisk symbol. Result is 600. Next two operators are special. That is the forward slash, the divide symbol, and the modulo operator, percentage symbol. So whenever we divide a number with some other number, we will get two results. We will get the quotient and we will get the remainder. Let's say we have number 20 and 30 here. Let me change b to 3. And if I go ahead and divide the a and b, so if we use the forward slash operator, that will divide that number and give us the quotient. We can see result 6 is coming. And if we want to see the remainder, what is the remainder result after division, we can use the modulo operator. If we run the program, we can see result is 2, because if we divide 20 by 3, we will get 2 as remainder. Next operator are comparison operator, that are used to compare one value with other value. We have equal to operator, we have not equal to, greater than, less than, greater than or equal to, and less than or equal to. Let's see them in Visual Studio. I have these two number and I want to see if a, basically I want to check if a is equal to b. So I can use the equal to operator. If a is equal to b, then write a message, a is equal to b. Let me go ahead and run this program. You can see this message is not getting printed because a is not equal to b. Currently a is 20 and b is 3. Let me change b to 20. This time a and b are equal, and if I run the program, I can see the message getting printed, a is equal to b. Similarly, we have the not equal to operator. Let me change b to 10. Now again a and b are not equal, and this time I'm using a not equal to operator. Let me change the message from a is equal to b to a is not equal to b. I can see message getting printed. Let's see the greater than operator. I will change it to greater than. I will change my message to is greater than. And we can see the result. Similarly, we have less than operator, and I want to show you the greater than and equal to operator, how it will work. So let's say we have a is 20 and b is 10 here, and I'm using a greater than or equal to operator, which means if a is greater than or equal to b, then this condition will become true and we will execute this piece of the code, which is available at line number 7. Let me run this program. We are getting the message a is greater than b. Let me change this message to hello. Now, currently a is greater than b. That's fine. Even if a is equal to b, that time also this condition will be true and we will go ahead and print this message. You can see message getting printed. Similarly, we have the less than equal to operator that will also work in same way. Next set of operators are conditional operators. Let's see how we can use these. AND operator can be used to club multiple conditions, and to make sure all the conditions are true, we can make use of AND operator. Let's see this how we can use it. I am writing a if block, and here I will say A is equal to 20 and B is equal to 20. Then go ahead and print the message hello. Let me change the value of B to 10. This time A is equal to 20, that condition is true. B is equal to 20. This condition is not true because B is only 10. If I go ahead and run this program, we can see we are not getting any output because when we are using the AND operator, both the condition should be true. But in our case, only the first condition is true. Let me change the value of B to 20 and value of A is to 10. This time my first condition is false, but my second condition is true. Again, if we run this program, we will not see the message because in case of AND operator, both the conditions should be true. We can see this. Again, there is no message. But if I change the value of A again to 20, now if we see A equal to 20, that is true. B equal to 20, that is also true. Let's run the program. You can see this time the hello message is getting printed. Next operator is OR operator. For that we use the pipeline symbols. To pipeline means it is an OR operator. In case of OR operator, it will just check the one condition. Even if only one condition is true, it will go ahead and run the program. Let's see this in action. If A is equal to 20, that is true. And if I change my B maybe to 5 or 4, now it is coming to this line of code, line number 11, and executing it and printing the message hello. Because A equal to 20 is getting true, so it is not considering B equal to 20. So in case of OR operator, at least one condition should be true. In case of AND operator, both the conditions should be true. Next operator that we have in C# is ternary operator. Let's see this in action. I will declare a bool variable that will store the result if A is greater than B or not. So I will declare my variable bool is A greater than B. So in this I will store my result if A is greater than B or not. So I will write my if condition. If A is greater than B, then set is A greater than B to true, else set A is greater than B to false. And at the end I will print my message result of A is greater than B is, let me use dollar symbol and put the result here, is A greater than B. Let's go ahead and run this program. You can see we are getting the result of A is greater than B is true because of course A is 20 and B is 4. But if you see here, for this simple program we have written a lot of line of codes. We can remove all this line of code using the ternary operator. Let's see this how we can achieve it. I will first tell my condition A is greater than B. Then I will put the question mark symbol. If A is greater than B, I will say true. Or I will say false. So let's see what is happening here. We are setting the variable is A greater than B. based on this condition. If this condition is true, we are going to this first part, we are setting the value to true. And if this condition is not true, we are setting it to the false. Let's run the program and see this. You can see again the same result is getting printed, but this time we are using only one line to implement our logic. So this is how you can use ternary operator in C#. That's it for this video, guys. In the next video, we will learn about nullable types in C#. Thank you for watching. Hello and welcome to the part 7 of this video series. In this video, we are going to learn about the null types of C#. Nullable types are a bit confusing because it means the absence of something. Normally, we have two types of variables that we can declare in C#. One is the value type, second one is the reference type. When we say value types are the variable which cannot store null values in it. Let's see this on Visual Studio. I have my Visual Studio opened here. Let me declare a variable of integer. I will call it a, and I can store value 10 in it. What if I try to store a null in this variable? Let me try to say a equal to null. As you can see here, a red line is coming, which means we have an error. If you can see the message here, it says cannot convert null to int because it is a non-nullable value type. Integer is a non-nullable type, so we want to be able to store 10 in it. If I show you the example of a string may be name, and I try to store some name like Parvesh, that will work fine. And if I try to store null in it, that will also work fine because string is a nullable type. So we will be able to store null in it. Let's understand the null type in detail. What is a null? Null means absence of something. Suppose you went to a restaurant and ordered your drink, and the waiter will come with your drink. Let's say you have ordered maybe coffee, and waiter will bring you a cup and that will have coffee in it. So here we have the cup as a placeholder and it has a value of coffee. So we can say a variable cup that is having coffee in it. Suppose waiter came to your table without any cup. In that case, you will say absence of something. It means there is nothing the waiter has. So it means we have a null here. Because waiter is missing the placeholder itself, it means it represents a null basically. Let's go back to Visual Studio and understand null with some example. If you see here, we were not able to store null in this integer type. Let me go ahead and change it to a nullable type. If I type int and put a question mark after that, it will change it to a nullable type. Now if I say a equal to null, this will not give me an error because now a is a nullable type and it can store null in it. Suppose we are building one application that is asking user their name and their maybe say email address, and they are also asking if they are 18 plus. And in our application, name is a mandatory field. Likewise, email is also a mandatory field. But the third question, if they are 18 plus, that is an optional question. So it can have three value. Maybe true if they are 18 plus, false if they are not 18 plus, and null if they choose not to answer this question. So to handle this kind of scenario, we need nullable types. Let's see how we can declare a variable to store this value. I will create a variable bool. I will name it are you 18 plus, and I can store null. You see, I'm getting an error because I did not declare bool as a nullable. To declare bool as a nullable, I have to put my question mark there. Now it will make my variable a nullable and I will be able to store null in it. So this is how you can create nullable variables in C#. Let's understand nullable types with a practical example. Suppose I have a variable tickets on sale. Currently I have null in it. So when the tickets are not on sale, I will store null in it. And if the tickets are on sale, I will store how many tickets are available to be purchased. So I have my another variable of integer, that is available tickets. First I will check if tickets on sale is equal to null. Then so I will set my available tickets variable to 0. Else I can set my available tickets variable to tickets dot on sale dot value. If you see the value property here, you can see here it is returning an int type. So the value will give me an integer type that we can easily store in the available tickets. What will happen if I don't use the value type? You can see here red line is coming. It means we have an error. You can read the message here, cannot implicitly convert type nullable int to int. We are going to see how we can convert one type to another type in future videos. But here you can see we are not able to convert nullable type to a non-nullable type. To do this, we can either use value property of nullable type that will give us the integer, or we can use provide int here that will convert our nullable integer type to non-nullable integer type. If I go ahead and print this message, so currently as I have my tickets on sale is null, so I will be getting available tickets as 0. We can see on the console window available tickets equal to 0. And if we have some value, let's say 100, this time we are getting the available tickets equal to 100. So again, to explain this program, we have this variable tickets on sale that is nullable type. We can check tickets on sale equal to null, and if it is true, we are storing 0 in the available tickets variable. And if tickets on sale is not null, it means it will have some value. It might have 0, it might have -1, it might have 100. So that particular value we will be storing in available tickets variable. So now let's understand the null coalescing operator. So we have just created this program where we were checking tickets on available. If it is equal to null, we were storing 0 in it. And if it is not equal to null, we were storing whatever the value of it inside it. So instead of doing this, we can use null coalesce operator to reduce our line of codes. I will remove all this code. And I can simply set my available tickets variable to tickets on sale. I will use my null coalesce operator and I'm set to 0. So what is happening here? Let me write my message again. Available tickets equal to available tickets. So at line number 5, you can see I am using the null coalesce operator, which is nothing but the double question marks here. If the tickets on sale is null, what is going to happen? It is going to set it automatically to 0. This operator will check if the value is null or not. If the value is null, it will set the value which is defined after the null callback operator. If the value is not null, it will simply put that value in the variable. So currently the value is null. If I run this program, you can see available tickets is coming as 0. Let's say tickets on sale equal to 10. Then I can see available tickets equal to 10. So this is how you can use the null callback operator. That's it for this video, guys. In the next video, we will learn about the data type conversion in C#. Hello and welcome to the part 8 of this video series. In this video, we are going to learn about data type conversion. Data type conversion is required whenever you want to convert one type to another type. Let's say you have one user that is sending you data in string format, and you have to convert that data into integer format so that you can perform some arithmetic operation. Maybe you want to perform some addition, subtraction. So in that case, you have to convert the data first into the integer format, and then only you can perform the arithmetic operation. So in this video, you will learn about data conversion. You will see how we can convert data. You will also see some of the important points we have to consider when converting data. In C#, data conversion can be performed using implicit conversion, and it can be performed using explicit conversion. When we say implicit conversion, it is the type of conversion that will be automatically done by the C# compiler. Let's see this in Visual Studio. I have opened up my Visual Studio and created a basic program. So let's see how the implicit conversion is done by C# compiler. Implicit conversion. So let's say I have a variable of integer. Let's say it has value 100, and I have a float. Let's say b. Now, if I try to convert a to the float number, let me say float b equal to a. What will happen? The conversion will happen automatically. C# compiler will convert integer a to the float type b. Basically, when we convert integer to float, there will not be any data loss. If you recall from the third part of this video, we have seen the integer. Integer has range from this number to this number, which is a quite big number. But if you see the range of a floating number, that is even bigger than the integer. That's why we are able to store an integer into the float type, because float can easily accumulate integers and there will not be any data loss. Let me try to do it in reverse. Let's say I have a float number, let's say temperature, and let's say 30.54. So this is the temperature, and if I try to convert this temperature to an integer, let's say I have a number, and if I try to convert temperature to integer, you can see clearly the error message is coming again, and if I hover here, I can read the message cannot implicitly convert type float to int. So C# compiler is not able to automatically convert 13.53 to a number, because if we try to convert this, we are going to lose the decimal part of this number, because we cannot store decimals in integer type. For that, we have to do an explicit conversion. Let's see how we can do an explicit conversion. We have to specify the type to which we are converting. If I mention int here, so C# compiler will know we are explicitly converting the float type to an integer type. Let me go ahead and print this number. As you can see here, we are getting 30 as the output, and we have lost 0.53 while doing the conversion. There is another way to convert one data type to another data type, that is using the convert class. If I use the convert class and press dot here, see there are multiple types that we can use to convert this data. I can convert it to int16 type, I can convert it to int32 type, or 64, or maybe I can convert it to the unassigned integers also. So let me use the int32, that is more suitable for integer types, and I will pass my temperature here. If you see here, there is no error message again, and we are able to convert this number. Again, you can see here it has rounded off our number to 31. So it will give us slightly more accurate numbers. This is how you can use the convert method to convert your one type to another type. So whenever we are using convert method or we are using the int keyword in front of the data type, we are doing an explicit conversion. So let's see how we can convert from string types to some number types. Let's say we have a string of input that is maybe 100, and I have an int number, and I can use integer dot parse method from it. And if you read this message, you can clearly see here parse is taking a string input and it will give me an integer output. You can read the message here also. It converts the string representation of a number to a 32-bit signed integer equivalent. We can see 100 is getting printed and we are able to convert this number. But let's say we have some condition here. Let's say we have an invalid string and there are some character also. Let's say XYZ. Now this is not a valid number. We will not be able to convert it to an integer type. Let's see what will happen if I run this program as it is. We can see we are getting an error message here. Input string was not in a correct format because we have this XYZ at the end. That is not making it a correct number. So let's see how we can deal with this kind of situations. So to tackle this, we can use the different version of parse that is called try parse. I can use the int keyword and I can use try parse method. In the try parse, first we have to provide the input that we want to convert. And we have to provide a variable in which we will store this value after the conversion is done. Let's say I have this number here. Let's see what is happening here. We are using try parse method that is taking input because we want to parse this string and we want to pass it to the integer type. And if the conversion is completed, we want to store that value in the number variable. Let me initialize the number to 0. So what will happen here, if we are not able to parse it, it will not throw us an error and it will just keep the number as it is. It will not make any changes. So I can see 0 is getting printed because we are not able to convert this number from 100 XYZ to an integer. Let's say we have a valid integer. Let's say we have 423. This is a valid number. We should be able to parse it. In this case, I can see my 423 is getting printed. So if you don't want to crash your program accidentally, you can make use of try parse. One more thing you will notice here, the return type of try parse is Boolean type. It means if the conversion is successful, it will give us true. If the conversion is not successful, that will return us false. Let's see this how we can utilize this return type. Let me create a variable bool. If conversion was successful. So the value of if conversion was successful will be true if the conversion was done properly. I can use this variable. I can use if conversion was successful. I can go ahead and print that number. Else, if the conversion was not successful, I can go ahead and print number was not valid. So let me give an invalid number. Let's start with ABC 423. You can see we are clearly getting this message number was not valid. So now our application is a bit more user friendly and we are properly handling the exceptional cases also. And again, if the number was valid, let's say 321, it will give us that output as it is. We have seen the implicit type conversion that is automatically done by C#. We have seen the explicit type conversion that we have to do either by using the typecasting operator or by using the convert method. And we can even use the parse method also to do it. And we have also seen the difference between parse and try parse. When we use parse, it will throw us the error if the input is not in correct format. And if we use the try parse, it will not give us the error either, but it will let us know if the conversion was successful or not, and we were able to handle it in the if else block. That's it for this video, guys. In the next video we are going to learn about arrays in C#. Hello and welcome to the part 9 of this video series. In this video we are going to see C# arrays. We will see what is an array. We will also see some of the advantages and disadvantages of array, and we will see how we can declare, define and access elements of an array. So let's get started. Okay, here I have opened my Visual Studio. In the previous videos, we were declaring some variables and storing some value in it. So we were doing something like int number equal to 5. Let's say the requirement is I want to store a set of odd numbers. I want to store first 5 odd numbers in my program. For that, I need something that can store a collection of numbers. That's where arrays will come into the picture. Arrays can store multiple values in it. To declare an array, I have to specify the type, which type of array I want to create, and then I need to put square brackets to tell the compiler it is an array. I will give it a name, odd numbers, and then I need to use a new keyword because I'm creating a new array, and I need to specify type again. And within the square brackets, I need to specify the size of this array, meaning how many elements we want to store. For this example, we will store 5 elements in this array. So I want to store 5 odd numbers in it. Here the array is created and the size of the array is 5 here. Now to store the numbers in it, what we can do, we can use the array, we can access the array using the index numbers. Like if I want to store 1 at the first place, it means because in C# counting starts from 0, so at the 0th place we will have the 1 element. At the second place we will have 3 because we are storing odd numbers. At the 4th place we will have 7, and finally at the 5th place we will have 9. So this is how we can store values in an array. Let me repeat. At the line number 3, I have declared an array of integer type and I have specified the size of the array, that will be 5. And from line number 5 to line number 9, I am inserting elements in my array. So I am accessing the position, like I want to put my element at 0th position, then I want to put my element on the first position, then on second, and similarly I have added 5 elements in that array. Elements are nothing but these integers which I have stored. Now to access the elements from that array, we can again use the square brackets and use the indexing. Let me show it. I will give console.writeLine. Suppose I want to print the second element of this array. I can use odd number, and in the square brackets I can give 1. To one index we have the second object, that is number 3. Let me go ahead and run this. You can see number 3 is getting printed here because we have number 3 at the second position. Let's understand the concept of array in bit detail. So in our previous example, we have declared an array of size 5. When we say size 5, it means we have 5 placeholders. Let me create it. We have 1, 2, 3, 4 and 5. So we were storing the odd numbers here. Let me put the indexing also, like we have the 0th index, first index, second index, third index, fourth index. On the 0th position, we have stored 1. On the first position, we have stored 3. On the second position, we were storing 5. Similarly, 7 and 9. And we have given the name of the array as odd numbers. So when I was giving the square brackets and mentioning the index number, means I was mentioning 0 to 4. So if I say index number 2, what will happen? It will go to the second index, which is this one, 5. It will pick the 5 and give me that element. So I will get the 5. If I say the index number 4, what will happen? It will go to the fourth index and give me that element, that is nothing but 9. So this is how we can access the elements of an array. Now let's understand the advantages and disadvantages of array. The one advantage that array has, that is type safety. Type safety means if I have declared my array of integer type, I won't be able to store any other different type of element in that. Means if I try to store any string in my array, it will not work. Let me show you how. So here I have declared my variable odd number, that is an array of size 5 and it is of integer type. Let me try to store string in it. So I will say 0th position, I want to store maybe apple. You can clearly see we are getting an error message here. It says cannot implicitly convert type string to int because the array is of integer type. Hence, we are not able to store any other data type in it. Now let's see the disadvantages of array. The arrays are fixed size. Like if I have declared the size of an array is 5, I won't be able to change it in my program. If you see the example here, the size of the array is 5 and if I try to access anything maybe of index 5, because there is no index 5 till fourth index we have the data, it will give me an error. Similarly, if I try to store a number maybe at 6th position or maybe at -1 position, it will again give me an error because there is no such position. Let's create a different type of array this time. Let me create a string array. I'll call it fruits and I will keep the size 3 for the simplicity. And let me go ahead and put some fruits in my array. Let's say at the 0th position we have apple. At the first position we have orange, and at the second position, the last position, we have banana. Now let's say requirement is I want to store one more fruit in my array. Fruits 3, maybe grape. Let me go ahead and run this program. You can see we are getting an error. Index out of range exception, because index 3 doesn't exist. The size of the array is 3 and we have already used up all the spaces. So when I'm trying to add one more element in my array, I'm getting this error. To overcome this disadvantages of array, like we are not able to store more elements once it is declared, C# has introduced generics or collection classes like list and hash tables that we will see in the future video. For now, just remember arrays are fixed size, and once the array is declared, we won't be able to change the size of it. Second disadvantage of array is we have to use indexing to access the elements. So when we were accessing the elements, we have to put the index, which element we want to access. I have to specify like 0 if we want to access the first element. If I run the program, I can see apple is getting printed. Suppose by mistake I change the value from 0 to 4 and run the program again. Again I will get the error because there is no index 4 in the array. Because this is the only way to access the elements, this is very error prone. And to tackle this program, C# has introduced generics. We will see those data types future in this video series. So we have seen the type safety of array, we have seen the fixed size problem of array, and we have also seen why it is not easy to access elements in an array. Let's now see some of the different syntaxes that we can use to declare array. First one we already saw, we can use int keyword and we can specify square brackets to declare it as an array, and then we can give a name to an array, maybe numbers, and we can specify the size, let's say 10. This is one way to declare the array. Let me show you a second way. We can declare the array and we can initialize it here itself while declaring it. Let's say I have the array of size 3 and I can initialize it with some number, maybe 4, 19 and 21. This is the another way to declare an array. And there is a third way that we can use to declare array in C#. We can just simply declare our array and just directly initialize it with whatever size you want, maybe 12. Now the size of this array is 4, and here we no need to use new keyword and no need to declare the size again. C# will automatically understand it has 4 elements, so I need to create an array of size 4. So these are the 3 ways which we can use to declare an array. That's it guys. In the next video we will learn about comments in C#. Thank you for watching. Hello and welcome to the part 10 of this video series. In this video we are going to see comments. We will see how we can use single line comments, how we can use multi-line comments, and what are the XML documentation comments. So let's go to Visual Studio and see these. I have opened up my Visual Studio here. So comments are basically that we use to describe our code. Suppose you have written some complex logic and you want to explain that logic in normal language. For that you can use comments. Let's see example of a comment. Console line hello world. This is a very basic line of code, but let's say I want to explain it what is happening here. What I can do, I can use single line comment. I can put 2 forward slashes and then I can write my comment. Here we are printing hello world. So this is how you can describe your piece of code. Just like a single line comment, you can use multi-line comments also. For that you can put forward slash and followed by a asterisk. Now the multiple line comment has started. Now you can enter your comment. This is line 1. This is line 2. This is line 3. And you can end it with a forward slash. So this is how you can create a multiple line comment also. Here we have a single line comment. Here we have multi-line comment. Let's see the keyboard shortcut to comment and to uncomment. Let's say I have a line of code here. and I want to comment this line. What I can do, I can use the keyboard shortcut Control K plus C. Let me type it here, Control K and then C. I will put my cursor anywhere in the line and I will press Control K C. It will comment my line. And if I want to uncomment this line, I can press Control K and U. This will uncomment my line. Control K and U. You can see comment is removed now. And other ways you can use the two buttons which are available here. You can use this button that says comment out the selected line. This will comment my line. If I press the second button, that is for the on comment, my comment is removed. If I want to comment multiple lines, let's comment these two lines. I can select these two lines and press this button. This will comment my line. And I can press the second button. This will uncomment my line. Comments are very important and it's a very good practice to use comments. Whenever you are writing a complex logic, you have to describe that logic using comments so that if someone else is working on that piece of code, they can understand what is going on in the code easily. Now let's understand the XML documentation comments. To understand that, if I hover my cursor on console, you can see some message is coming here, represents the standard input, output and error streams for console application. If I want to have this similar message for my classes also, I can use the XML documentation comments. Let's say I have a class, click class, maybe I will name it my class. And I will try to use my class in my code. If I hover on my class, you can see there is no messages coming. There is no description that is attached to my class. That's why I'm not able to see that. If I show you again on console, I was able to see my message. It represents a standard input, output and error streams. Wherever on my class, I'm not getting any such description. If I need to add a description to my class, what I can do, I can use XML documentation comments. To put an XML documentation comment, what you can do, you can start your comment with a triple slash 1, 2, and 3. You can see Visual Studio has converted it into a summary tag, and here you can write the summary of your class. Let me say this is my class for demo. If I hover again on my class, I can see the same message is coming here. So this is how you can add XML documentation comments for your own classes. Let's go back to the slides now. So we have seen the purpose of comments. We have seen how we can use single line comment and multi-line comments. We have also seen what are the keyboard shortcuts that we can use to comment or uncomment the piece of code. And we have seen how XML documentation can be used to add description to our own classes. That's it for this video, guys. In the next video, we will learn about if statements in C#. Thank you for watching. Hello and welcome to the part 11 of this video series. In this video, we are going to see if statements. If statement is a conditional statement, meaning if statements checks the condition and then execute the part of code. It can be useful if we have a scenario where we want to execute some piece of code based on some conditions. So first we will validate the condition. If the result of that validation comes true, then only we will execute that piece of code. Let's quickly see what we will learn in this video section. We will see the if statements. We will also see if else and else blocks. We will also see what is the difference between double ampersand and single ampersand. We'll also see what is the difference between the OR operator, that is our double pipeline, and what is the meaning of single pipeline operator. Let's go to Visual Studio and understand this with help of an example. I have opened up my Visual Studio here. So let's see how we can use if statements. Let's say I have declared a variable number equal to 10 console dot write line, and I am printing the number is 10. If I run this program, I can see I'm getting the message the number is 10. But what if I change my number to 11? And if I run this program again, I can see still it is giving me the message the number is 10, which is not correct because our number is 11 now. To make sure the line number 3 executes only when the number is 10, we can make use of if statements. I can use the if keyword, and within the brackets I can provide my condition. So what is the condition here? Condition that I want to check is number should be equal to 10. Now we have to specify curly braces and put our piece of code within this. See what is happening here. At line number 3, we are checking if number is equal to 10. If the result of this condition is true, then we are going to in this block which starts from line number 4 and ends line number 6, and we are executing whatever is available within that block. If I have multiple lines, let's say we are printing it 5 times, all this code will be executed because it is part of this if block. Let me go ahead and run this program, but before that let me change my number again to 10, and let's remove all the duplicate lines here. I can see my message is coming up, the number is 10. And now if my number is not 10, let's say it is 12, what will happen in this case? We will not get the message because the number is not 10. Let's say you want to give a different message when the number is not 10. Maybe you want to say something like the number was not 10, or maybe something else. So for that we can use an else block. I can just use the else keyword and again put my curly braces. I can put my message in the else block now when the number is not 10. I can say number was not 10. Let me go ahead and run this program. This time you can see we are getting the message the number was not 10, because this time this condition number equal to 10 was not true. Hence it went to the else block and it has printed the number was not 10. One thing to notice here, when we are in the else block, it will not check for any condition. If we are hitting the else block, it means it will definitely go inside the code block and execute whatever is there between the line number 8 and 10. So this is how you can use if and else blocks. Now let's say we have a condition. If the number is 10 or if number is maybe 15, you want to give user a message. Let me say if number equal to 10, I will say number is 10. And what I can do, I can check my number here. If number equal to 15, I will say console dot write line number is 15. What will happen in this case? If my number is 15, it will check this condition and it will print this line, the number is 15. But again, at the line number 8, we are again checking the number if number is equal to 10. But logically, if the number was already 15, it will never be 10. So we should not be executing this piece of code again. To avoid this kind of situations, we can use else if block. Let me show you how. We have the if block here, and just after the end of if, we can put else if number equal to 15, print the message the number is 15. And in the else block, what I can do, I can put the number was not 10 and was not 15 also. We will start our execution from line number 4. It will check if the number is 10. If number is not 10, then it will check if the number is 15. If the number is 15, then it will go ahead and print the message. If the number is not 15, then it will come to the else block and print this particular message. So this is how the execution will work for the if else and else blocks. One thing to notice here, currently we are using one else if block with our if statement, but there can be multiple else if block for one if statement. Let me show you how. We can use else if the number equal to 100, and I can print my message the number is 100. If I go ahead and run my program, let me change it to the 100. And you can see number is 100 is coming up. In this case, first we'll check the number is 10. It is not true. Number is 15. It is also not true. Number is 100. This is true. So we will go ahead and print this message and we will come out of this block. Now let's see how we can combine the conditions within the if block. We are using only one condition, number equal to 10 in if statement. But we can check multiple conditions also. Let me show you how. Let's say I have, let me clear it. I have number 1 that is equal to 100, and let's say I have a number 2 that is 200. So what I can do, I can check the condition if number equal to 100 and I am using the AND operator because I want to check both the condition number equal to 200, then print number 1 is 100 and number 2 is 200. Let's see what is happening here. We have defined two numbers, number 1 and number 2, and we are checking the condition if number 1 equal to 100 and number 2 is equal to 200. If both of these conditions are true, then only we are coming to line number 6. Basically, we are coming to this if block which starts from line number 5 and ends at line number 7. So we are executing this code block and printing this message. Let me run this. We can see message coming here because both of these conditions are true. Let me change the number 2 to maybe 205. Now number 1 equal to 100, this condition is true, but the second condition, number 2 equal to 200, that is not true. In this case, we will not execute this line of code. You can see there is no message because when you're using the AND operator, that is double ampersand, it means both the conditions which is there on the left side of this operator and right side of this operator must be true, and only then it will execute the code which is available in the code block. And the opposite of it is the OR operator that is represented by double pipeline symbol. You can see the message coming even though our number 2 is 205 and not 200. To summarize this, in case of AND operator, both the condition needs to be true, but in case of OR operator, only one condition needs to be true. Even if only one condition is true, it will go ahead and execute the program. So when we are using the OR operator, you can see we have used the double pipeline operator here. It means if the one condition is true, it will not bother to check the other condition. It will directly execute the line of code which is available at line number 6. Okay, but if we use the single pipeline operator, it means even if the first condition is true, it will still check the second condition and then only it will execute the line of code. Similarly, if we use the AND operator, it will check both the condition if both the conditions are true or not. If both the conditions are true, it will execute this line of code. But suppose one condition is false here. Let me change it to 105. When we are using the double AND operator and first condition is not true, it will not check the second condition, because in AND both the conditions should be true. When we are using the double ampersand, if the first condition is not true, it will not bother to check the second condition and it will directly skip this line. But when I'm using a single ampersand, it will go ahead and check the second condition also, even if the first condition is false. So we have seen the difference between double ampersand and single ampersand. We have also seen the difference between double pipeline and single pipeline. Now to understand the concept of if-else blocks, let's create a small program. Let's create a program that will find the smallest number. So the idea is we will ask the user to enter three numbers and we will check which one is the smallest and let the user know. So let me print a message. Please enter first number. That is there. I will capture the user's input using read line method, and whatever is coming there I will store it in number one, or let me store it in a variable. And because the read only method is giving me string, I have to cast this string to an integer. For that I can use int dot parse. So whatever number is entered by the user, we will convert that number to an integer and store it in the a variable. Let me do it for the other two numbers also. Please enter second number. Let me store it in B. Then let me ask the third number. Let me store it in C. Okay, so now we have three numbers and we have to find the smallest one. So what we can do, we can write if A is less than B. Okay, and A is less than C also, that time print smallest number is A. Okay, so we are checking the condition if A is less than B and A is less than C also. So I am using an AND operator. Both of these conditions should be true. Then only we will execute this line of code. Else, if B is less than A, B is less than C also. So I am checking if B is less than A and B is less than C. Then I can print. Smallest number is B. Else, I can say, because there is only one possibility left. If A is not smallest, if B is also not smallest, then for sure C is the smallest one. So we can directly put that code in the else block. So let's see what is happening here. We are asking the user to enter three numbers, A, B, and C. Then we are checking the condition if A is less than B and A is less than C. We are printing A is smallest. We are checking if B is less than A and B is less than C. Then we are printing smallest number is B. Else we are printing smallest number is C. Let me run the program. It is asking me to enter a number. Let me enter 10. It is asking me to enter number 2. I will enter 5. It is asking me to enter number 3. I will enter 20. So we can see second number is the lowest, that is 5. If I press enter, it will give me the output. I can see smallest number is 5, which is expected because first number is 10. So it will check if A is less than B, A is 5, B is, sorry, A is 10 and B is 5, A is not less than B. It will come to the else block. It will not bother to check the second condition because we are using the double ampersands. It will come to the else block. It will say B is less than A, B is 5, A is 10. This is true. Okay. So it will check the second condition also. B is less than C, B is 5 and C is 20. This condition will be true and we will execute this line of code. That's it for this video, guys. In the next video, we will learn about switch statements in C#. Thank you for watching. Hello and welcome to the part 12 of this video series. In this video, we are going to learn about switch statements in C#. So let's see what we will see as part of this video. We are going to look at switch statements. We will see case, break, default and goto keywords. And we will also see how we can merge two case blocks, and we will also see why goto is not a very good practice to use in our code. So let's get started. I have opened up my Visual Studio here and I want to create a simple program that will ask the user which day is it, and based on that input it will display some output. So let's say we will ask user what day is it today. Okay, so now we will wait for users input using readLine method, and we will capture this input in our variable of string type day equal to. Okay, so now we are asking the user for an input and we are storing that input in day variable. Now we can check which day is it using if statements, which we have seen in the last video. I can use if day is equal to Monday, then print start of the week. Else if day is equal to Friday, I will print yeah, today is Friday. Else if day is equal to Saturday or day is equal to Sunday, we will print happy weekend. Else we will print it is an ordinary day. Okay, so this is our simple program. Let me go ahead and run this. It has asked me the question what day is it today, and it is waiting for my reply. Let me add Monday, and I can see start of the week is coming. So yes, our program is working as expected. If you see here, there are a lot of if statements that I used. Here we've used if, then else if, then else if, then else, and there are a lot of curly braces. So let's see how we can reduce this line of code using a switch statement. Okay, to start a switch statement, first we have to use the switch keyword, and we need to give the variable on which we need to put the condition. So this time we need to check the day variable. So I will give the day variable here, and I will start my switch case using the two curly braces. So now to compare the variable, we have to use the case keyword. Then I can specify my condition. I want to compare if day is Monday. Then I have to put a colon, and then I can write the piece of code which I want to execute when the day is Monday. So I will say start of the week. Okay, and after that I will break my case here, and that's it. We have our first switch and case block. Let's add case Friday, then print yeah, today is Friday, and I will use the break keyword. Any other ordinary. So this is how basically we can convert our if statement to a switch statement. Let's understand how this is working. We have declared a variable day and we are capturing the user input in that variable. Then we have started our switch case here and it is checking for the day variable. If the day is Monday, it will go ahead and print the message start of the week, and then it will break this block, meaning it will come out of this switch statement. It will not check any other case, right? Similarly, if the day is Friday, first it will check if it is Monday. No, then it will go to the next case. It will check for the Friday. Yes, we have entered Friday there. Then it will print, yeah, today is Friday. And similarly, just like in if statements, we were having the else block. When none of the conditions are matching, we have the default block in switch case that we can use if user is entering something that is not matched by any other condition before. Let's see this in action. It is asking me which day is it, and I will enter Friday. As expected, it is giving me message, yeah, today is Friday. I'm running it again, and let me give some different day this time, maybe Wednesday. And this time we are getting a message any other ordinary day. So this is how switch statement works in C#. If you remember, this is how we were using the if else statements, and we were checking if the day is Saturday or day is Sunday, we were printing happy weekend. So let's see how we can implement the same in the switch case also. Okay, so I need to add more condition. I have to check for the Saturday and Sunday. So I will use case Saturday and I will print happy weekend, and I will break my case here and case Sunday. I can again print happy weekend. And break my block here. Let me go ahead and run this program now. I will enter Saturday and we can see happy weekend is coming. Okay, if we see the code here for the Saturday and Sunday, we have the same message, exactly same message we are printing, but we are using two different case blocks for these two. What we can do in C#, we can merge this case block into one so that we don't have to repeat our code again and again. So let me show you how. I can just go ahead and delete these line of codes. If you see here, there is no error message by the compiler because so basically we have combined the two case blocks into one. We are using the condition if Saturday and Sunday. We are executing the same code, happy weekend. Let me go ahead and run it. If I enter Sunday, you can see I'm getting the message happy weekend. So guys, this is how you can club your case statements into one. So let's change this code a bit. Maybe when the day is not Monday, Friday, Saturday and Sunday, I want to print a message invalid day, please retry. So When the day is not matching any of the case above, we are coming to the default block and we are telling the user invalid day, please retry. So we have to give the opportunity to the user to give the day value again. So what we can do here in this, we can use go to keyword. To use go to keyword, first we need to define labels. Labels are nothing but markers in the code. Let me create a label here and show you. I will create a label start here. Okay, so the label is created here, start here. And if I want to go to that line of block, what I can do, I can use go to keyword and I can say start here. So once we have used the go to keyword, we can remove our break keyword, because if you read the message here, it says unreachable code detected, because once we hit this line of code, it will start executing code from this line number 3. So this line of code will never be executed, so we can safely remove this code. Okay, so let's try the program now. So I will add an invalid day here, ABC. You can see it has printed the message invalid day, and it is again asking me the question what day is it today, because we have used the go to keyword at line number 21 and it has moved our execution to the start here label, and start here label is nothing but line number 3. So we have started our execution from line number 3 again. If I give a valid input here, let's say Monday, then it will print the message start of the week and it will come out of the program. So guys, this is how you can use the labels and go to keyword in C#. Just want to add one thing here guys. The go to keyword is not a very good practice to use, because when we use the go to keyword, the execution will jump from one line to another line, and it is very hard to debug those kind of programs which are using go to keywords. So that's why in current applications, we don't use go to keyword, and it is not considered as very good practice to use go to keywords. So let's go ahead and create a simple application and use all these keywords so that we can understand it in much more better way. Let's create a simple application. Maybe we will create a simple burger shop where we will ask the user what they want to order, and based on their choice, we will generate the bill for them. So let's see how we can implement this. So this is a burger shop. And we will have 3 choices: a small burger, medium sized burger, and third is king size burger. So go ahead and ask the user which burger they want to order. Which burger you would like to eat today? Okay. And after this, let me provide the choices to the user. Okay. And now we will wait for user to enter their choices, and we will capture their choice in choice table. I will use console dot read key, and of course this will give me a string. I have to cast my string to an integer, int dot parse. Okay, read line. Okay, so I am asking the user which kind of burger they want to order, and based on their choices, we will generate the bill for them. And let's consider the prices of each burger. Let's say the small burger costs us $10, medium is for $15, and king size is for $20 maybe. Okay, so now we have the prices and the user choice, we can create a variable that will store the bill amount. Int bill amount. We will start with 0, and based on the user's input, we will add up the amount. Video switch choice case is 1. It means they have ordered a small burger, and then what we can do, we can use bill amount equal to bill amount plus $10, and then we can break this case block. Okay, similarly I will do it for the case 2, that is nothing but our medium size burger, and we have case 3, that is nothing but a king size burger. So when it is medium size, the price is $15, and when it is king size, the price is $20. Once it is done, what I need to do, I need to print the message, thank you for your order. Your bill amount is, I will use string interpolation, bill amount. So let's run this program. So here it is asking me which burger I want to order. I have 3 options: small, medium, and king size. Let me order a medium size burger, and I can see it is giving me the message, thank you for your order, and your bill amount is 15, because as per our condition, the medium burger is of $15. If you see here how we are adding up the prices, we are using the bill amount variable and adding the $10 in the bill amount variable itself. In C#, we can use a different syntax for this. So what is happening here, instead of using the normal assignment operator, we are using the plus equal to operator. What this will do, this will take the bill amount and add 10 to it, and again assign it back to the bill amount variable. So instead of using this bigger syntax, we can reduce it to this shorter one. I can use plus equal to 20. Now let's add a default case also. Maybe user has not entered the proper input, and we need to give the message invalid input. Please retry. Okay, let me run this program again. Now if I enter invalid choice, let's say 54, and you can see invalid input, please retry, but again I'm getting the same message, thank you for your order, your bill amount is 0, which is not correct. Ideally, when we are telling the user the input is invalid and we are asking the user to retry, we should pop up the same message again so that the user can make the choice again. So let's use a goto keyword and fix this problem. Maybe I will write this label, choose type. So I've created this label here, choose burger type. And if the user's input is invalid, I will give this message, please retry, and I will go to choose burger type. And again, I can remove my break statement because it is not required. And if I run my program again, Let me order burger size 40, which is not a valid input. It will give me the message, and let's see what will happen. Okay, so it has given me the message invalid input, please retry, and as expected, now we are getting the message again. So let me order 3 this time, king size burger, and now it is giving me thank you for your order, your bill amount is 20. So this is a very basic application, guys, that we have created using the switch statement. That's it for this video, guys. In the next video we are going to see while loops in C Sharp. Hello and welcome to the part 13 of this video series. In this video we are going to see while loops. So in programming, actually we might have to do some repetitive task based on some condition. For those kind of tasks we can use loops. To understand while loop, let's take an example. I have my message that is hello world. And the requirement is I want to print this message 10 times. What I can do, I can copy paste my code. So now I have copy pasted my code 10 times, and if I run the program now, we can see hello world is getting printed 10 times. But if you see the issue here, we are repeating our code. We are printing exactly same message 10 times. For this, we can use a while loop. Let me show you how. Let's first declare a variable, like how many times we want to print. Let's say max print equal to 10. Because we want to print the hello world message 10 times. Okay, and let's say we have a variable print count, that is 0. We will start with 0, and when we are printing the messages we will be keep on increasing it. Let's start with the while loop now. I will use the while keyword, and within the while I need to specify a condition. While print count is less than max print, and then I have to put my curly braces. Now we are inside the while loop, and inside the while loop we need to print hello world. Okay, so let's understand what is happening here. I have declared two variables. One is max print, one is print count. Max print will define like how many times we want to print the message, and print count means how many times we have printed the message already. So we have started with 0, and when we are printing this message, after printing is done, we can increase the print count. I can say print count plus plus. This will increase the value of print count by 1. Let me go ahead and run this program. You can see hello world is getting printed 10 times as expected. Let's understand this program now. So we have created two variables. One is the max print and one is print count. And we have used the while statement here. And within the while, we are checking the condition if print count is less than max print. So the first time when we hit the line number 5, the print count value will be 0 and the max print will be the 10. And we are using less than operator. So we will check if 0 is less than 10. So this will be true, and we will go ahead and execute this program. We will print the message hello world. But at line number 8, we are incrementing the print count value. So now once we have printed this value one time, the print count variable will become 1. And then we will go back to line number 5 and check the condition again if 1 is less than 10 or not. So this will be true again, and we will be printing the hello world message one more time. This will be keep on going until we have the value of print to 10. Once the print count value is 10, we will check if 10 is less than 10. This condition will be false and we will come out of this loop. So this is basically how the while loop will work. One thing to notice here, the print count plus plus which I have added here at the line number 8, this is very important. If we don't add this condition, our code will go into the infinite loop and it will be in the never ending situation. Let me remove this line of code for now and let me run the program now. If you can see, hello world is getting printed again and again and again. So this is the infinite loop problem that we might face while using the loops. So it is very important and very critical to update the condition which we are using in the while. So whatever condition is there in the while, print count is less than max print, we have to update somehow this condition so that we will not stuck in while loop. I will increase the print count again. And now we can see our message getting printed 10 times. So guys, in this video we have understood the while loop and we have seen one demo with while loop, and we have also seen how we can stuck in an infinite loop if we are not using our conditions properly. Thank you for watching this video guys. In the next video we will learn about do while loop. Hello and welcome to part 14 of this video series. In this video we are going to learn about do while loop. If you remember from the last video, we have written this program. We were printing hello world message 10 times using this while loop. So let's see how we can achieve this using do while loop. To create a do while loop, I need to use do keyword and then I need to put my curly braces, and here I need to put the code which I want to repeat. Dot write line hello world, and I will increase my print count variable by 1 using plus plus operator. And again, this is very important because if we don't add this condition, we might get stuck in an infinite loop. So once my do block is completed, I will insert my while condition at the end. While print count is less than max print. So what is happening here? I have created a do while loop and it will start with a do keyword, and whatever we want to execute in a loop, that will go inside those two curly braces. And after the execution is done, we will check the condition. If print count is less than max print, meaning if print count is still less than 10, we are going to execute the loop again and print the hello world message. Let's see this in action. I am running my application and we can see hello world is getting printed 10 times. Okay, to understand the do while loop in more clear way, let's create one more program. And in this program, I want to print even numbers and I want to ask the user if they want to print the next even number or not. If they want to print a next even number, I will go ahead and print that number. If not, I will come out of the loop. Let's see how we can do it. First of all, I will create a variable int number. I will initialize it to 0. Then I will create a string variable. I will call it choice. And for now, I will keep it as null. Okay. Now I will start my do while loop. I will use the do keyword again. And within the do block, I will print console.writeLine and the number. And once number is printed, I will increment the number by 2 using the plus equal to operator. Number plus equal to 2. So I am adding 2 in the number to get the next even number. Once the number is incremented by 2, I will go ahead and ask the user if they want to print the next even number or not. So let me print the message console write line, and I will ask the user, do you want to print the next even number? And let me use the console write method because I don't want to put a break line after printing this. Once I have asked the question, I will use readLine method and capture the user's input in the choice variable. And once I have the choice variable, I can go ahead and use that variable in my while condition. I will say while choice is equal to no. I will be keep doing it. Meaning if user enters the no, we will come out of the loop, else we will be keep executing the do while loop. Let's see this in action. It has printed 0 and it is now asking me the question, do you want to print the next even number? Let me say yes. It has printed the next even number, that is 2. And it is again asking me the same question. If you want to print the next even number, let me say yes again, yes again, yes again, yes again. If you notice here, it is keep on asking me if I want to print the next number or not. And it is printing the next even number. If we see here 0, 2, 4, 6, 8, 10. If I say yes again, it will again print the next even number, that is 12. And but if I say no here, let me put no. That's it. The execution will come out of the loop and program will end here. So guys, it is very important to notice when we are using the do while loop, the loop will execute at least one time. And once the execution is done, then we are going to check the while condition. Okay. In the while loop, we were checking the condition first and then only we were executing the piece of code. In do while, we are first executing the code. If you see from line 6 to 15, whatever is present in the do block is getting executed. After then only we are checking the condition in the while. If the condition is true, we will execute the loop again. And if the condition is not true, then we will come out of the loop. Now let's understand the difference between the while and do while loop. Okay, so the first difference is while loop checks the condition first. As we have seen already, while loop was checking the condition first and then only it was going ahead and executing the piece of code. Whereas in case of do while loop, it will first execute the code and at the end only, at the end of the loop, it will check the condition. That's why do while is guaranteed to execute at least one time. But in case of while, it will first check the condition. If the condition is true, then only it will execute the loop. Okay. And the process will be repeated as long as the condition evaluates to true. Okay guys, that's it for this video. In the next video, we will learn about for loop in C#. Hello and welcome to the part 15 of this video series. In this video, we are going to learn about for loops. I have opened up my Visual Studio here. And to understand for loop, let's see an example. I have an array. Say this is of string type array. And if you don't know about array, you can go through this playlist and watch the video about arrays. Let me create an array of, let me name it fruits. And the size of the array is 3. So I can store 3 elements in my array. Let me store fruit at the first position. I mean at 0th index, I will store apple. Okay, I have created my array and I have initialized the array with 3 elements. Let's say I want to print the elements which are available in my array. I can use a while loop. Let me declare a while loop here. Before creating a while loop, let's create a variable int index. Let's initialize it with 0. And let's use the while loop now. While index is less than fruits dot length, and we want to print fruits dot index. So whatever fruit is available at that index, that we want to print, and once it is printed, we will increment the index by 1 using the plus plus operator. Okay, let's run this program and see what is happening. we can see apple, grapes, orange are getting printed. So all three elements we have printed using a while loop. But if you see here, at line number 7, we have initialized a variable, and at line number 9, we are checking the condition based on that variable. And at line number 13, we are incrementing that variable. So the first step is called declaration. And this is condition check. And this is increment. So for this, we need to perform 3 steps at 3 different locations. When using while loop, we have to follow 3 simple steps. First one is the declaration. We will declare a variable and initialize it with some value. Second one is the condition check. We will check the condition based on the variable which was declared before. And third step is the increment. We will increment or change that variable so that we don't stuck in an infinite loop. When we use the for loop, we can do all these 3 steps in a single line. Let me show you how. To create a for loop, I need to use the keyword for, and within it, I have to initialize a variable. Basically, I have to declare the variable index. Let me initialize it with 0, and I will put a semicolon, and then I will check the condition index is less than fruits dot length. I will put the semicolon again, and I will increment the index plus plus. I will put my curly braces now. So whatever will be present in the curly braces, that will be executed by the for loop. So let me print the message console.writeLine fruits, and I want to print whatever is present at the index. So let's see what is happening here. Index will be 0 first time, and the fruits length will be 3 because we have declared the array of size 3. So it will check if 0 is less than 3, that will be true, and then it will execute this piece of code. Let's go ahead and run this program. We can see again all the elements are getting printed, but this time we have used the for loop. So now let's understand what is happening here. First time when we declared the variable, that will be 0. So the index equal to 0, and the length of the fruits array, that is 3. So the first time when we are coming here, it will check if 0 is less than 3. That will be true, and it will go ahead and print the first element, that is nothing but apple. So index is 0, and it will take fruits 0 element and print apple. Next time, because we have incremented the index by 1, the index will be now 1. Now it will check if 1 is less than 3. That is also true. It will go ahead and print fruits of index 1. Fruit of index 1 is nothing but grapes. So it will print the grapes. Okay, after printing the grapes, the index will be incremented to 2. So it will check if 2 is less than 3. That is again true. And this time it will go ahead and print the orange. And it will increment the index again. Now the index is 3. And we will check if 3 is less than 3. That is not true. That is false. Okay. This will evaluate to false. That's why we will finish the execution there and come out of the loop. Okay, so we have seen the for loop demo, and we have seen the advantage of using for loop over while loop, because in while loop we have to first declare the variable, and then we have to check the condition, and then we have to increment the value. So these 3 steps were performed at different position, but in case of for loop, we can do all these 3 steps at one position. We can declare a for loop, and we can declare the variable here. We can initialize it also, and we can check the condition. Here I am putting the condition I is less than 5, and I can increment the variable within it. So in the one line, we have done all three steps. So this is the benefit of using for loop. That's it for this video, guys. In the next video, we will learn about for each loop in C Sharp. Hello and welcome to the part 16 of this video series. In this video, we are going to learn about for each loop. If you recall from the last lecture, we have seen a for loop where we were printing the elements of an array using a for loop. The size of the array was 3 and we were using the index variable to loop through the array and print the elements which are available in the array. The issue here is when we are writing the condition index is less than fruits.length. Let's say by mistake I typed here less than or equal to fruits.length. What will happen here, instead of going from 0 to 2, our loops will be running from 0 to 3, right? Because when the index is 3 and we say less than or equal to fruits.length, that is also 3. 3 is less than equal to 3, that will evaluates to true, and we will go inside the loop and we will try to print fruits of index 3, which is not currently available. Let's see what will happen when I run the program. As expected, I am getting an exception here. Index was outside the bounds of the array because we have tried to access index 3 that was not available in the array. If I hover over here, I can say index equal to 3 and I can say fruits length was also 3. That's why when we try to access fruits of index 3, because there is no index 3, we only have 0, 1 and 2, it has given me an exception. So what we conclude here, when we are iterating an array using the index, it is very error prone, because when we access the array using index, the chances are we might go beyond the size of the array. In that case, it will throw the index out of range exception. Let's see how we can tackle this problem and iterate the array without using the index. If I want to iterate an array or maybe any other collection, array is also a collection. Here in this example, the string is a collection of fruits because we are capturing fruits name in this array. We will see the collection in the later part of this series, but we can use for each loop to iterate through collections in C Sharp. Let me show you how. I will use the for each keyword and I will say string fruit in fruits and print fruit. What is happening here? I am telling the compiler, take the fruits collection and for each fruit available in my collection, take it out, pull it out of the collection and print it using the console.writeLine method. Let's see what will happen when I run this program. We can see as expected, it has printed apple, grapes and orange. So this is how we can use the for each loop. We will see more of for each loop when we go through the C# collections like list, hash map, dictionaries. But for now, we can understand for each loop allow us to iterate through an array without using an index. So in this video, we have seen a demo of for each loop and we have also seen why it is a good practice to use for each loop instead of using for loop when we are iterating through collections. I want to explain two important keywords that we can use in loops. One of them is break and the second one is continue. If you remember the switch case video, there we were using the break keyword to come out of a case block. Similarly, we can use break in loop also. We can use a break keyword in any loop. It can be while loop, do while loop, for loop or for each loop. Let's see this how we can use break keyword and then we will have a look at continue keyword also. So let me create a program where we will print first 20 odd numbers. Okay, I will start with the number 1 and I will use a while loop now. Number is less than or equal to 20. I want to print if number modulo 2 is equal to 0, then print number. When we say number modulo equal to 0, it means it is an even number. For this program, let's go ahead and write the odd numbers only. So I will change the condition from equal to 0 to not equal to 0. So now it will print the numbers from 1 to 20. Whatever odd number is present between this range, that will be printed. And make sure we are updating our number when we have printed it. So I will say number plus plus. So it will increment the number by 1, and it will make sure we are not getting stuck in an infinite loop. I have executed my program and I can see it has printed 1, 3, 5, 7, and till 19 it has printed all the odd numbers. Now let's say requirement is I want to come out of the loop once we have hit number 15. So for that, what we can do, we can check if number equal to 15, then simply go ahead and break. So what will happen, the loop will be continue running from number 1 to 15. Once it reaches the number 15, it will check if number equal to 15, that time this condition will evaluates to true, and we will hit the break line, that is line number 8, and it will come out of the while loop. Now you can see it has printed the number till 13, because when we try to print 15, it will check the condition at line number 7. If number equal to 15, that will be true for that case, and it will break the loop there, and it will not go ahead and print the number at line number 12. So this is how you can use break keyword, guys. Let's see how we can use the break keyword in for loop also. So I have written a for loop here. Here again we are checking if the number is odd, then only we are printing the number, and again we are going from number 1 to 20. Let's see what will happen when I run this. Again it has printed the numbers from 1 to 19. So let's say I want to break my loop once I have reached the number 10. If I is equal to 10, then break. So now when my I is equal to 10, that time it will break the loop and it will come out of it. I'm running my application. Now you can see it has printed from 1 to 9 only, because when I reaches 10, that time the condition will be true. The condition at line number 6 will be true, and it will execute the break statement and come out of the loop. So guys, we have seen the break keyword, and let's now see how we can use the continue keyword in loop. Let's say for some reason we don't want to print number 3 and number 9. So for that we can use the continue keyword. Let's see how we can use that. If I equal to 3 or I equal to 9, I will use the continue keyword. So what will happen whenever we hit the number 3 or number 9, it will execute the line number 8 which says continue. It means it will not do anything what comes after this line, and it will start with the next number. So I have run the program. I can see it has printed 1, and then it has skipped 3. Because when I is equal to 3, it will execute the continue statement, and we will not do anything after executing the continue statement. So once continue is executed, it will go ahead and pick the next number and start executing from there. Once we reach 3, it will hit the continue, and then it will start from number 4. So because number 4 is not an odd number, we didn't print the number 4, and we then pick the number 5, and then we check the condition. If 5 equal to 3, no. If 5 equal to 9, no. Then we checked if 5 modulo 2 is not equal to 0, that will be true, because when we divide 5 by 2, the remainder will be 1. And that's why we will execute the line number 14 and print the number 5 that we can see here. Same thing happened when we reach the number 9. It will skip that iteration and it will not print the number 9, even though it is an odd number. So guys, this is how you can use the break and continue keyword. When we use the break keyword, it will break the loop and come out of the loop, and it will not execute any iteration after that. In case of continue, it will skip that particular iteration and it will be keep executing the loop till we reach the end condition. That's it for this video, guys. In the next video, we will learn about methods. Hello and welcome to the part 17 of this video series. In this video, we are going to learn about methods. I have opened up my Visual Studio. To create a method, first I have to create a class. I will right click on my project. I will select add, and from there I can select the class option. It will give me a lot of options. I will select the first one that says class. I will give it a name. Let me say demo, and it will create the demo class for us. For now, I can remove the using statements. I will change the internal to public. Don't worry, we will learn about what is public and what is internal, and we will learn all other access modifiers in the future videos. We will also see what is a namespace. To create a method, basically first we need to specify a access modifier, and then we need to provide a return type, and we need to provide a method name, and methods will take some parameters. After that, we need to put our curly braces, and within those two curly braces, we need to put our method body. So let's see this in action, how we can create it in Visual Studio. So I have to specify an access modifier. Let me say public, because we want this method to be accessible everywhere. After declaring the public, I need to specify the return type of the method. Return type basically mean what type of data this method will return. It can be integer, string, or any other type also. But for now, let's create a method that will not return anything. For that, we can use the keyword void. Void means nothing. This method will not return anything. Then we have to specify the method name. Let me say method 1. Within these two brackets, we need to specify the parameters. Parameters are optional. Method can take some parameters or they may not take any parameter. So for now, let's create a method without any parameters. I will put my curly braces. Once it is done, the method is ready. Method body is also optional. We may or may not provide the method body, but practically speaking, we have to provide a method body to make it functional. So let's go ahead and add some line of code in our method body. I will write console write line. Hello world from a new method. Okay, so our method is ready now. We have created this method in demo class. So let's see how we can run this method. I am back to my program.cs class. In this class, if I want to access a method which is available in demo class, I need to create an object of that class, or we can say we have to create an instance of that class. To create an instance of a class, I have to specify the class name. For this example, the class name will be demo. If you notice here, when I entered the class name demo here, it has automatically injected a namespace which is demo underscore string. If you notice here, the namespace which we have mentioned here, that is also demo underscore string. So this class is present inside the namespace demo underscore string. So that's why if we have to access this class, we have to make use of that namespace. Don't worry if you don't know about namespaces. In the future video, we will learn about namespaces also. So I'm using the namespace demo underscore string, and now I can access demo class. I will create the instance. I will name the instance demo, or let's say D. I will use a new keyword and I will specify the class name again. So what is happening here? We are creating an object of demo class and the instance name is D. So now we can use D instance to call our method. I can say D dot method 1. Okay, so this is how we can invoke our method. We have declared our method in demo class, and in program.cs class we have created an object of demo class and accessing that method using d.method name. Let me run this program and see what will happen. Now you can see we are getting the message hello world from a new method, because We have invoked the method 1, and method 1 is doing nothing, but it is writing a line on the console, hello from a new method. Now let's create a method that will print the even numbers on console. I will name the method as print even numbers. And now let me declare a variable int max equal to 50, and I will use a for loop here for int I equal to 0, I is less than max, I plus plus. So I am iterating the loop from 0 to 50, and we will be printing the even numbers. So inside the method I can check if I modulo 2 equal to 0, then go ahead and print that number. So we are checking if the number is even, then we will print the message. Let me go ahead and invoke this method in my program class. I will again create an object of my class, demo d equal to new demo, and I can use d dot print even numbers. Okay, let me run this program now. So you can see here it has printed all the even numbers from 0 to 50. Now let's say the requirement is we want to print the even numbers till 100 or maybe till 1000. How we can manage that? We can make use of parameters. Let me show you how. I can, instead of declaring the variable at line number 7 and setting it to 50 here, what I can do, I can pass this as a parameter. I can say int max, and I can remove the code from here. And now I can pass that variable int max when I'm invoking that method. So I can pass the number at line number 6 because here I'm invoking this method. If you see here, we are getting an error here because currently we are not passing the parameter which is expected at the method. Let's read this error message. What it says: there is no argument given that corresponds to the required parameter max of demo.print even numbers. It says the parameter max is expected, but we have not passed that. So let's go ahead and pass that parameter. Let me pass that parameter as 100. Now you can see the error is gone. And if I go ahead and run the program, now it will print the even numbers till 100. So it makes our code more flexible. If I want to print the even numbers till 73, I can pass that also. Now it will print the even numbers till 73, 0 to 72. Okay, so this is how you can make use of method parameters. Now let's discuss the static and instance method. If you see here, when we are invoking the print even numbers, we have to create a object of that class, and then only we are able to invoke that method. Let's say what will happen if I remove this d dot. It will say name print even method does not exist in the current context because it is not aware where we have the even number method. That's why we have to use the object and then call this method. These type of methods are known as instance method because we have to create the instance and then only we can invoke the method. The second type of methods are called static methods, for which we can use a static keyword, public static. To invoke these methods, we can use directly the class name demo.print even numbers, and then I can pass my parameter 100. Because the method is static, we don't have to create the instance of the class. We can directly use the class name, and using the dot operator, we can call the print even number method. If I go ahead and run the program, it will print the even numbers from 0 to 100. So guys, that's the difference between a static and an instance method. Instance methods, we have to invoke by using the instance or the object of the class. And to invoke these static methods, we can directly use the class name and call the method. One more thing I want to explain here is whatever we are writing in program.cs class, that is actually the part of the main method. In C#, we have a main method that is basically the entry point of the execution. So whenever the application will run, it will search for the main method and then it will execute that main method and all the execution will start from there. To prove that program.cs is nothing but the main method, we can use the reflection and see which method we are calling. To check which method we are currently running, we can use system dot reflection dot method base dot get current method dot name. So this basically will give us the method name which we are currently executing. I can store it in a variable string space name equal to, and I can go ahead and print this. If I run this program, you can see we are getting the main here because whatever we are writing in the program.cs class belongs to the main method. That's it for this video, guys. In the next video, we will learn more about method parameters. Hello and welcome to the part 18 of this video series. In this video, we are going to learn about method parameters. In this video, you will learn what are method parameters. We will see what are the type of parameters that we can use in C#, and we will also see what is difference between an argument and a parameter, and we will see what are named parameter. So this is a list of parameter types that are available in C#. Let's see each of them in Visual Studio. I have opened up my Visual Studio, and for this demo, I have created a demo class, and I am calling a start method of my demo class. Because the start method is static method, so I am using the class name and calling the start method directly. So the first parameter type that we have is value type. So let's say we have one method, public static void, and let me call it change value. Okay. This will take a parameter int a, and it will do nothing, but it will just change the value a to 10. Okay. So let's say we have a variable int b that is currently to 5, and I am calling my method change value, and I am passing the parameter b there. Let me print the value of b. So what we are doing here, we are passing the parameter b to change value method, and inside that method we are changing the parameter value a to 10. So let's see what will happen when we run this program. If you see here, 5 is getting printed because value of b is 5. So what is happening here, we have a b variable that is storing the value 5, and currently b value is pointing to the location where we have stored 5 in the memory. And then we pass the b variable to the change value method, and we are passing it to the a variable. So a variable will be created, and we will create a copy of the value which is 5, and then it will be passed. So whatever changes are happening on the a variable are happening at this location, but b is pointing to the some different location. So that's why whatever is happening with the a variable will not impact the value of b, because we have created a copy of b variable and passed that copy to that method. This is called value type parameters. Second type of parameter that we have, that is reference type. Let me do a small change. In front of int, I will put ref keyword, and now we can see we are getting one error message here. It says argument 1 must be passed with the ref keyword. So because we have the ref keyword here, it means reference. We have to pass the variable here with ref keyword again. Okay, so what is happening here? We are passing the variable b as a reference. We are not passing the value of b, we are passing the reference of b variable. Let's see what will happen when I run the program. This time we can see 10 is getting printed. So this time what happened, we have this variable 5 and b was pointing to it, When we passed this p variable to the change value method, it created a variable a that is pointing to the same memory location, that is 5, because we have passed the reference of the b. So whatever memory location b was having, same was copied to a. That's why it is pointing to the same memory location, and we have 5 there. And when we changed variable a to 10, it means it will change the value at this location. The value will get changed to 10. That's why when we printed the value at line number 14, b value was 10. So if you remember, in the value type, b value was not impacted and it remained 5. In reference type, it changed to 10 because we have passed the reference of the variable. Third type of variable are out type variable. Let's suppose we have a method. I will call it calculate. It will take two parameters, int a, int b, and let's say instead of returning void, I will return the sum of these two variables. So I will change my return type to integer, and what I can do, I can use the return keyword and I can return a plus b. It will add up two numbers, it will add up a and b and return that number. So let me call this method in my start method. I will call it using calculator. Pass the parameter. Let me call 10 and 20. So I have passed these two arguments for the parameters a and b, and I will capture the result in int. Let me call it sum, and I will print the sum variable. If I run this program, we are getting the 30 because we are adding up 10 and 20 and returning that. So program is working as expected. So let's say the requirement is we want to return the product of these two number also. Using the return type, we can return only one value. But if we use out parameters, we can return multiple values from a method. Let's see how. Let me add two out parameters, out int addition and out integer product. Okay, and I will remove my return statement. What I can do now, if you see here, we are getting an error message. Let's read the error message, what it says. It says the out parameter addition must be assigned to before control leaves the current method. Similarly, the same error message is coming for the product parameter also. Basically, it means we have to assign this parameter to some value. So let's set the parameters addition equal to a plus b and product equal to a multiply b. So we have assigned the parameter to the correct output. So let's see how we can invoke this method. And one more thing, we can now remove the return type because we don't need this anymore. We can change it back to void. Okay, let's see how we can invoke this method and get the output from it. I will declare variable addition result and product result. Fine. And then I can call my calculator method. I will pass 10 and 20. I will pass my addition result parameter and I will pass my product result parameter. Because these are out parameter, I have to specify the out keyword, out, and here also. Let's print these two variables, console.writeLine addition. I will use the addition result parameter, and for the product I will use the product variable. Okay, so we have a method that uses 4 parameters. 2 are value type parameters and 2 are out parameters, and we are setting up our out parameters at line number 23 and line number 25. And we are calling that method and printing out the result. Let's see what will happen when we run it. As you can see, we are getting addition at 30 and product as 200. So this is how we can make use of out parameters. The difference between the ref keyword and the out keyword is that in case of ref keyword, we don't have to mandatorily assign the variable to some value. But in case of out keyword, it is mandatory to assign the values. If we don't assign the value, compiler will give us the error. If I comment out this line, you can see again we are getting that error. The parameter out, the out parameter addition must be assigned to before control leaves the control method. So guys, this is the basic difference between the ref and out keyword. Next type of parameter is in parameter, that is also known as read only parameter. Let me show how I can use it. Let's say I have a method that is a static method that will not return anything, so I will use void, and I have the method name change me, and let's say I have string name, and I will call it as in parameter. Okay, so let me call this method change me, and I will pass some name, maybe hello. Okay. So let me try to change the name variable in this pair method. Name equal to Peter. If you see here, we're getting the error message already. If I hover over here, I can see the message. Cannot assign to variable name or use it as the right hand side of a ref assignment because it is a read-only variable. So guys, if we are declaring a parameter as in parameter, it means it will be a read-only parameter and we won't be able to change that parameter. So this is the benefit of using the in parameter. If we don't want our method to manipulate the parameter that it is getting, we can declare the parameters as in type. But because this is a read-only parameter, we can still access this variable and perform some read operation. So let me go ahead and print this name as it is. We can see hello is getting printed because we are able to access the parameter name. Next parameter that we have, that is optional parameter, or that is also known as default parameter. As the name suggests, if we want some parameter of a method to be optional, that we can do by using the optional parameter. Suppose I want to make name parameter as optional. What I can do, I can put the equal to operator and pass some default value to it. Let's say Peter. Okay. If I don't pass the argument for the name parameter, it will take the Peter as default value. So let me remove the value here and now run this program. We can see Peter is getting printed even though we didn't pass any parameter to it. And if I pass some parameter, let me say Roger, this time the parameter which was passed while invoking it, that will take the priority and we will ignore the default parameter. That's why we can see Roger is getting printed. So guys, this is how we can use the optional or default parameters. Next one is dynamic parameters. Okay, let's create a method. Let me go ahead and call this method sum. Let's call 5 and 7. So if I call this method, we can see we are getting 12 as the output, which is expected. So now let's say a requirement is I want to pass, instead of 5, I want to pass 5.1 and 7.5. What will happen in this case? You can see the error is coming, cannot convert from double to int, because I'm trying to pass the double parameter, but the method is expecting an integer type variable. For such cases, we can make use of dynamic parameters. Let me change it to dynamic, and this also to dynamic. Okay, so you can see after adding the dynamic keyword, the error is gone, and now the compiler is not checking the type of the variable. Basically, when we run this application, so at the runtime, it will pick the parameters and set the type at that time. So if I run this program, we can see it is correctly adding up the two numbers, adding up the two double numbers 5.1 and 7.5 and giving us the result, that is 12.6. So this is how you can use the dynamic parameters. But guys, there is a disadvantage of using the dynamic keyword, because now our methods are not type safe. Let's say if I try to pass some invalid data here, let's say ABC, we are not getting any compilation error. If I try to build this application, you can see we are getting the message build one succeeded. But if I run this program, let's see what will happen. We will get some weird result. We are getting ABC 7.5. Next type of parameter is the array parameter. Okay, I'm creating an add method that will take two parameters for now, int a, int b, and it will print the result of this addition. And I can call this add method 10, 90, and if I run this program, we will get 100. We are getting 100 here. So the program is working. But let's say now the requirement is I want to add up, let's say 5 numbers, 50, 30, and 60. So if you see here, we're getting the error message here. No overload of for method add takes 5 argument. If you don't know what is overload, don't worry, we will understand overload and override in the future videos. But if you see the error here, it says there is no method that takes 5 arguments, because our method can take only 2 arguments, right? So in order to handle these kind of situations, what we can do, we can make use of array parameters. To create an array parameter, I have to use params keyword. Then I need to specify which type of parameters I will be getting. So in this case, I will be getting the integer type, and I can say numbers. So I'm collecting all the numbers in my numbers array, and I'm iterating through all the numbers, adding those numbers in the sum variable to get the final output. So let me go ahead and run this program. We can see we are getting the 240. The addition of these 5 numbers is 240. So guys, this is how you can use the array type parameters in C#. One thing to notice here, the parameters array that we have in a method, that should be the last parameter of a method. If I try to add a parameter in front of my parameter array, that will not give an issue. That is fine. We can add a parameter in front of our parameters array. But if I try to add my parameter after the parameter array, it will give me a compilation error. We can see the error message here. A params parameter must be the last parameter in a parameter list. One more thing, we can only have one parameter array in a method. If we try to add one more parameter array, we will get the compilation error. We can see a parameters must be the last parameter in the parameter list. Okay guys, now let's understand the difference between an argument and a parameter. If you notice here, I have a method with the name volume, and I am passing 3 parameters to it: length, width, and height. And I'm calling my method at line number 15, and I'm passing the arguments 10, 20, and 30. So guys, The 10, 20 and 30 are the arguments, are known as arguments, and the int length, width and height are known as the parameters. So these are the parameters, and for these parameters we are passing these arguments. So guys, this is the basic difference between an argument and parameter. Okay guys, let's now understand the named parameter, how we can pass the parameter by name. Okay, let's create a method, public static int area, that will take int length, int width, right, and it will return the length into width. Okay, so this is how we can calculate the area. Okay, let's call this method, let me call area 100 into 300. Okay, let's capture this in a variable. Okay, now we can see we are getting the 30,000 as the output. But now let's say when we are calling this method area, we want to specify 100 belongs to length and 300 belongs to width. So to specify that, we can make use of named parameter. We can do length, and then we can use a colon, and we can specify the length parameter 20, and then we can specify the width also using the name of the parameter. So guys, this is how you can pass the parameter using the name of the parameter. These are called named parameters. The benefit of using named parameter is that we can even change the sequence of these parameters. So if I pass the width first and then the length, then also it will work. Basically now we are passing the parameter using the name of it. If I run the program, let me change the length to 20. We are getting 600 as expected. One thing to notice here guys, once we have used one named parameter, we have to use the second parameter is also as a named. If we try to pass that second parameter without the name, it will start giving us the error. If you read here, named argument width is used out of the position but is followed by an unnamed argument. Also, if you're using the one named parameter, we have to use the other one also as a named parameter, or we have to maintain the sequence. Let's say I will pass the length as 40, and then I can pass my width parameter by name, maybe 30. So that we can do, but if we are changing the sequence of the parameter, then in that case, all the parameters should be named parameter. Okay guys, we have seen the value type parameters, we have seen the ref type parameters, we have also seen the out type parameters, we have also seen the read only parameters that we can use using in keyword. We have also seen the optional or also known as default parameters. We have also seen how we can use dynamic keyword and create dynamic parameters. And the last parameter type that we saw was the parameter arrays. That's it for this video guys. In the next video, we will learn about namespace. Hello and welcome to part 19 of this video series. In this video, we are going to learn about namespaces. In this video, we will see what are namespaces and how we can use namespace and what are the benefits of using namespace. So namespace is basically, we can say, a placeholder in which we can organize our code. Let's say we have a huge project and there we will be creating hundreds of classes. To organize those classes, we can use namespaces. One more benefit of using namespaces is if you want to create two classes with same name, for that we can use namespaces and can have different namespace name, and within those different namespace we can have classes with the same name. I have opened up my Visual Studio and I have created one demo class, and I have called the start method of my demo class inside my program.cs. Let's suppose we have one organization with name ABC, and within this organization we have departments HR, and IT. So what I want to do, I want to organize my code so that I can put my file in different HR and IT departments. And when I look at those files, I can easily tell this belongs to HR department or the IT department. Namespaces can help us to achieve this. Let's see how. I will create a namespace. I will call it ABC because this is our organization name. I will use my curly braces. So this is how you will create a namespace. Within the namespace, you can add one more namespace. Basically, you can do nesting of namespaces. I will create namespace. This time I will call it HR because I'm creating it for HR department. And within this, I can create my class public class employee. Okay. And let me create a method also. So what I have done here, I have created a namespace ABC. Within that namespace, I have created one more namespace with the name HR. And within that, I have created one class employee. Okay, now let's create a namespace for IT department also. Now let's say how we can access this namespace and call our print method. One way of doing it is we can use the fully qualified name. I can say ABC dot. You can see Visual Studio is suggesting us the option which we can use. I can use either HR or IT. Let me first invoke HR. Then I can call my class employee and then I can use the print method. One more thing, we have to change our text here. I will change my text to IT. Okay. Now let's call the print method from the IT department also. Let me copy this and paste it again. And I will change HR to IT. You can see there are no errors. So if I run this program, we can see from HR print method and from IT print method is getting printed. So this is how you can create a namespace. You can access those namespace with this syntax. But let's say we have sub departments also. In that case, calling the classes using the fully qualified name will become very long. To avoid this, what we can use the using statement. I can say using abc dot hr, right? Now I can safely remove abc.hr from line number 12. And if I run my program, I will again get the method from HR print method. So this is how you can make use of using statement and avoid using fully qualified name. But let's say I want to invoke my print method that is available in IT department also. So let's use the IT department namespace also using abc.it. If you see, we are getting one error message here. Let's read the error message. It says employee is an ambiguous reference between abc.hr.employee and abc.it.employee because employee class present in both the namespaces and compiler is getting confused from which namespace I should be calling the employee class. To avoid this, what we can do, we can use aliases. Let's say I will call my alias HR department equal to IT department equal to. So I have created aliases for my namespaces. Now I can use my alias here HR department dot employee dot print. If you see here, now the error is gone and we can still use and invoke our print method from HR department. Let's go ahead and call it from the IT department also. I will change it to IT. So this is how you can use alias for a namespace and avoid using fully qualified name. And guys, Microsoft also uses namespaces. Let me show you. When we are using this console class, right click on it and click on go to implementation. You can see console class is under system namespace. If you see, there are a lot of namespaces used by the Microsoft, and Microsoft has organized their code within the namespaces. If you see, we have the system.text namespace. So all the classes which are related to text operation, related to text, are basically available in system.text namespace. Okay. Now, if you notice here at line number 21 and line number 35, we have created namespace with the same name. So guys, it is possible to have namespaces with similar name, with same name in same file, or maybe they can present in different files also. Even they can present in different project also. So for this demo, let me go ahead and create a new class file and try to create a namespace with the same name. I will right click on my project. I will select add option and I will select the class. I will give it a name demo2. Let's try to use the namespace ABC in different file also. If you see, there are no compilation errors and we are still able to use the namespace name ABC. Okay, so the point here is the same namespace can be present in different files, different folder, or maybe in different projects also. That's it for this video, guys. In the next video, we will learn about classes. Hello and welcome to the part 20 of this video series. In this video, we are going to try and understand classes. I have opened up my Visual Studio. Till now, we have seen the data types like integer. I was able to create integer, let's say number equal to 10. I was able to create string types, string name equal to hello world, and I was able to create boolean. These are called as simple types because we are storing simple values in it, number, string, boolean. But in real world, we will see the data in complex form. Like take an example of customer. Customer will have their name, their age, their customer ID, their date of birth, their salary. So these kind of things will be associated with a customer type. So to create these complex types in C Sharp, we can make use of classes. Let me show you how. Let me go ahead and create a class, public class. Let me call it customer. Okay, now we can define properties in the class, or we can define the class fields in the class. In the future videos, we will see what is difference between a class field and a property. But for now, let's create class fields in this customer class. I will create public string, maybe first name. Okay, similarly, I can create public string last name. Let's create one more class field, public integer age. Okay, so we have declared three class fields in our class. Now if you see, we have declared the class fields, but we have not initialized that to some data. To initialize the class fields or any class data, we can make use of constructor. So what is a constructor? Constructor is basically used to initialize or to set up the data when the object of a class is created. So let me create a constructor, then we can go ahead and use the constructor. I will say public customer. So guys, this is a very basic constructor. In this, we are not passing any parameters, and you will notice here the name of the constructor will always match with the name of the class. One more thing to notice here, constructor will not return anything. If you see any normal method, they will either return some type of value, and if they are not returning any value, we will specify the void type for that. If you see here, I have defined void here because my method is not returning anything. But in case of constructor, we will never have a return type. And also the name of the constructor will always match with the name of the class. So currently my constructor is not doing anything. Let me go ahead and add some parameter to my constructor. String first name, string last name, and int age. So now my constructor is taking three parameters. Now I can use this parameter to initialize my class field. So my first field is first name. I can say first name equal to first name. What we are doing, we are initializing class field first name with whatever parameter is coming inside the constructor. Typically, when we are referring to the class fields available in the class, we generally use this keyword. So for the better readability, I can, instead of directly calling the first name, I will call it using this keyword. So I can specify my class field name with this keyword. This keyword basically means the instance of this class, the object of this class. Okay, so we can say this dot first name equal to first name. Similarly, I can use this dot last name equal to last name. This dot is equal to age. So guys, just to make our code more readable, we can use this keyword and assign the parameters which are coming to the constructor. But let's suppose the parameter name inside the constructor is age. Okay, now we shall see here what is the name of parameter we have, age. What is the class field name? That is underscore age. I will change it to, I will remove the underscore. Now what will happen if I try to do age equal to age? This will start giving me an error. This is not an error, but basically this is a warning. Let's read the warning. Assignment made to the same variable. Did you mean to assign something else? Because now compiler don't know what is the age class field, because now compiler will give priority to the constructor parameter, that is age. To avoid this confusion, we can use this keyword. Now you can see that warning message is gone, and now we are able to assign the class field age. So basically this is the benefit, or we can say the advantage of using this keyword. I can easily differentiate between my class field and the parameters of the constructor. Okay, now this is done. Let me go ahead and create an object of this class. I will delete all this. To create an object, we have to first specify the class of which we are creating the object. I will say customer. Let me call it C1 equal to, I will use the new keyword and I will use the customer constructor. So if I put a bracket here, you can see it is suggesting us the parameters which the constructor is expecting. I have to specify the first name, last name, and the age. So let's go ahead and provide this data. Let me say John Walker, age 30. Okay. So now we have created a class, we have created a constructor, and we have created an instance, or also known as an object of the class. C1 is our object. Now my object is initialized with the data passed in the constructor. Basically, class can have a state and can have behavior. Currently, our class only have a state. State means nothing but some data. So we have passed some data, but we are not using anything. Basically, we don't have any behavior assigned with our class. Behavior is nothing but methods that we can declare in a class. So let me go ahead and declare some behavior for my class. I will add a method public void print full name. Okay. So what this print full name will do, this will do nothing but print the full name of the customer. I will say console.writeLine. I will use the string interpolation. Full name equal to, I can use the class field this dot first name space this dot last name. So now our class have some behavior also. Let me go ahead and invoke this method. I can say C1 dot print full name. So what we have done here, we have created an object of our customer class, and then we have invoked print full name method using the object which we have created. Okay, let's run this program and see what will happen. We can see full name John Walker is getting printed. So guys, this is how we can create a class, create a constructor, and create an object of that class using the constructor and invoke the methods from the class. In real life scenario, when you're using classes, sometimes you might be working with some resources like connecting to a database, using a file from a folder, or invoking any API. So within the class, we can access these kind of resources. And to clean up these kind of resources, once we are done with them, we can use deconstructor and clean up those resources. So to declare a deconstructor, what we can do, I will use the same name as my class name, customer, and then I will give parentheses, and then I will put my curly braces. Okay. And to create a deconstructor, we have to specify it with the tilde sign. I will put that sign. You can see here this symbol. If we put here and if we use the class name after that, this will create a deconstructor for us. And we can write our logic here to clean up the resources. So these type of tasks we can perform within the deconstructor. And guys, we cannot call our deconstructor explicitly. It is the job of garbage collector will run and run the deconstructor of the class, and it will clean up the resources for us. We have no way to call it explicitly. We will learn about garbage collector in future videos. Okay. Now you might be thinking, is it possible to create an object of a class without having any constructor? Yes, that is also possible. Let me show you how. I will delete this constructor, or maybe I will just comment it out. Okay, I have removed my constructor, and if you see here, I can see error is coming up. Customer does not contain a constructor that takes 3 arguments. But if I remove these arguments, see what will happen. The error is gone, and we are able to use this constructor which is not taking any parameters. What is happening here, when we create a class, the .NET framework will automatically inject a constructor for us that is called as default parameterless constructor. So we can make use of this constructor, and still we can create objects and call any method that is available in that class. So again, I can print full name using the object C1. If I run this program, you will see full name equal to blank is getting printed because we have not initialized our class fields first name, last name, or age. So we saw here .NET framework has provided one constructor for us, and we are able to use it to create objects of the class. But let's see what will happen if I uncomment my constructor here. If you see here, we are again getting that error saying we have not passed the first name, last name, and age parameters to the constructor. So guys, once we have declared any constructor in a class, then .NET Framework will take back that free constructor that was given to us before, forces us to use the constructor which is defined by us. So now the compiler is forcing us to use this constructor and pass the parameters. Suppose we want to give our users the flexibility to don't pass any parameters when creating the object of the class. In that case, what we can do, we can create a default constructor, and from that default constructor, we can pass some default values and initialize the class fields. Let me show you how. Currently, if you see, we are getting the error because we are not passing the argument. So let me go ahead and create one more constructor. This time it will not take any parameter, and now I have created this construct which is not taking any parameter. If you see, the error is gone, but still we are not initializing our class fields to any default data. If I run my program again, I will still see the blank full name. So let's initialize the data with some default values. To do that, what I can do, I can use a colon and I can use this keyword. This means nothing but the object of this class, means the current instance of the class which is currently invoked. I can use this keyword and I can put a bracket here. If you notice here, it starts giving us the options to invoke the parameterized constructor. So I can go ahead and provide some default value here. So what we are doing here, whenever the parameterless constructor is called, we are going ahead and invoking this constructor, and internally this constructor will call the parameterized constructor and pass these fields to it. If I run the program now, I can see the default first name and default last name is getting printed. But if I create a new object of my class customer C2 equal to new customer, and this time instead of calling the parameterless constructor, I can pass my data here, Peter Parker and 20. Okay, and now I can call my C2 dot print full name method. We have called the constructor here without any parameter, so it will take the default values. At line number 11 we have called the constructor that is taking the parameters, and we have passed Peter Parker age is 20. Let me run the program. If you see, for the first one we are still getting the default values, but for the second one we are getting the expected name, that is Peter Parker. And this concept of using the same name for different constructor is called constructor overloading. That's it for this video, guys. In the next video we will learn about what are static classes and what are instance classes. Hello and welcome to the part 21 of this video series. In this video we will learn about static and instance members. In this video we will learn about static and instance class fields. We will see static and instance class methods. We will see how we can create static in constructor and how it will be different from a normal constructor. And we will see how we can declare a static class. So let's open up the Visual Studio and start the demo. Okay, I have opened up my Visual Studio, and here you can see, if you remember the past video, I have created a demo class and I have created a static main method in it, and I am invoking my main method in my program.cs class using the demo.main method name. Okay, let's start with the demo and create a class. Public class employee. Okay, an employee will have their employee ID, public integer ID. They will have their name, and let's say they have their age also, integer age. By default, if you don't specify a static keyword, it means the fields or the members of the class are instance members. They are not static. What we mean by instance member? It means to access these members, I have to use an object of the class. Okay, so if I have to access, let's say employee, and I want to access the ID, if I put dot here, I don't see the fields ID, name, age. Even though I have declared those as public, still they are not visible to me, because to access these fields, I have to use the object of the class. So let me create an object employee E1 equal to new employee. Once I have the object created, I can do E1 dot. If you see now, I have the access to all the class fields here. I can access ID, age, name. So I can access any of the field and I can manipulate the data if I want. I can set the age to 10. I can set E1 dot name to maybe some test name. So like that I can access my class fields. But let's say I will create my some class fields as static. Let's say we have a property that is called company name. Okay, so let's set the company name e1 dot company name equal to ABC organization. So the employee E1 is working with the ABC organization. Let's say we have another employee. I will copy paste it. And let me call it E2. And again, I can change my E1 to E2 here. Okay. And let's say this employee is of age 30. And let's say the name is test2. And company will be ABC organization, because this project we are creating for the ABC organization. So every employee of this company will have the same company name. But let's suppose we are creating 1,000 employees. So in that case, the company name field will be duplicated in all those 1,000 employees. But that field is basically the common for all the object. For these kind of fields, we can use the static keyword. So let me declare the company name class field as static. So what will happen after declaring my class field as static? I won't be able to access it using the object name. So what I have to do, I have to remove this. And to access the static fields, what I need to do, I have to use the class name, that is employee. Then I can use the dot operator. And now if you see, I have the access to company name variable. Basically the company class field is now accessible to me. I can set the company name here, ABC organization. Now this company name will be shared with E1 and E2 also. So now we are not duplicating data and we are saving our memory. Okay, let's create a method also in our class. Let me say public print description. Okay, I want to print employee name so that I can access using this keyword, this dot name works in. I will use the company name. To access the company name, I can directly say company name, or I can use the class name dot company name. So what we are doing here, we are printing the employee name works in, and then we are printing the company name. Okay, so let me call this method print description for both E1 and E2. If I say E1 dot print description and E2 dot print description, let's run this program and see what will happen. You can see here test works in ABC organization and test2 works in ABC organization. So guys, when we have some data that will be common, or we can say static for all the objects, at that time we can create that class fields as static, and those fields can be used by all the objects like we did in this print description method. The company name field was common, so we have declared that as static, and we were able to use that field for E1 and E2 objects. Okay guys, so what is happening here when we are not using the static keyword? When we are creating the object E1, what will happen in the memory? In the memory, we are having the age variable, that is 10. We are having the name variable, that was test, and we had the company name, that was test organization. And similarly, we declared the E2 variable that also had some age, name, and company name. And suppose we have 1000 employee objects, so all those 1000 employee objects will have the age, name, and company name. So this company name field is declared or saved in the memory 1000 times, but for all those objects we are storing the test organization. So this field is basically common for all the employees. So we can identify these fields and declare them as static to save the memory. Let me show you how what will happen when we declare the field as static. Okay. So when we declare the field as static, we will declare the employee even variable. And in this variable, or we can say object, we will have the age, we will have the name, and that's it. We will have only these two fields. And for the static variable, what we will do, we will declare that variable, we will declare that field outside of this object because it will be shared with all other objects. So we will keep it outside the object. So the company name will be stored somewhere outside that will have value as test organization. And similarly, when we declare and or when we create the E2 object, that will also have only the age and name fields. So whenever E2 wants to access the company name, it will go to this memory location and fetch that company name information. Similarly, even object will also go to this memory location and get the company name information. So that's why even if we have 1000 employee objects, all 1000 employee objects can refer to that one memory location to get the company name information. So in that way, our program is more memory efficient and we are saving the memory by creating the common fields as static. Okay, so we have created this class where we have these two class fields, name and age, and we have declared the company name as the static field. Let's say we have a method that don't return anything, so I will use the void keyword that will simply print the company name. Print the company name in uppercase. So this is a very basic functionality that I want to add. I want to print my company name in uppercase. I can use console.writeLine or I can type CW and press tab. And I can access the static variable. I can access those directly. And I can use the two upper So I have created this method here, print the company name in uppercase, and it is doing the same thing. It will take the company name, change it to the uppercase and print it on the console. But if you notice here, I have not declared my method as static. So if I have to access this method, I have to use my object name even dot print the company name in uppercase. So again, this method is common and the implementation or the behavior of this method will not change for different objects. It is common for all the objects. So instead of declaring it as instance method, I can declare this as a static method. So I can use the static keyword public static. And now instead of calling it using the object, I can directly call my static method using the employee class employee dot print the company name in uppercase. That's it. So this method is shared across the class. We don't need any objects to invoke this. If I go ahead and run the program, as expected, we can see the company name in capital letters, ABC organization. So that's how you can make use of static methods. And now let's understand the static constructors. If you remember from previous videos, we were declaring the constructor using the public keyword, and we were using the class name, and this is how we were creating the constructors for our classes. Okay, to create a static constructor, all we have to do, we have to just put static keyword there. And if you see, we will get one error message. Let's go ahead and read the error message. It will say employee constructor access modifiers are not allowed on static constructors. Okay, so whenever we are creating a static constructor, we have to remove the public keyword. In C Sharp, if we don't provide any access modifier, don't worry if you don't know about access modifier. We will learn about access modifier in future videos. But this public keyword that we have used here is nothing but an access modifier. If we don't specify an access modifier, the C# compiler will consider those methods as private. So let me show you an example. Let me create a method. Let me first declare it as public static demo method. Okay, let me specify the return type as void. Okay, now if I use my class name dot, if you see, I am able to access the demo method because demo method is public, so I can access it in my demo class. All right, if you see, demo method is in employee class, and I am able to access it in demo class also because the access modifier that we used here is public. What will happen if I remove my access modifier public from here? It will become private. Okay, if you see here, we are already getting the error message. Let's read the error message. It says employee.demo method is inaccessible due to its protection level. Now we have protected our method, and that's why we're not able to use that method in our demo class. Now let's come back to our static constructor. So we have declared a static constructor here, and by default we cannot give any access modifier to a static constructor. They will always be private because static constructor will always be invoked by the .NET framework. We cannot go ahead and call our static constructors explicitly. Okay, that's why we are not allowed to put any access modifiers on a constructor that is static. Okay. One more thing, static constructor will be invoked automatically whenever we refer the class in our code. Let me show you an example. I will use console.writeLine static constructor invoked. Okay, and I will do nothing. I will just create an object of my class. Okay, I'm not doing anything. I'm just creating an object of my employee class. Let's see what will happen. If you see, static constructor invoked is getting printed. We didn't do anything with our even object, but still the static constructor was invoked and this message was printed on the console. This is because whenever we refer the class employee in our code, that time .NET framework will automatically invoke the static constructor, and whatever code is available, that will be executed. The purpose of using static constructor in real world scenario is it can be used to initialize the static fields. Let me show you how. Let's say instead of setting up the company name outside this class, I can set the company name within this class only. For that, what I can do, I can say company name equal to ABC organization. Okay, so now I don't have to initialize the company name field for all the objects. It will be initialized automatically whenever I will refer my class inside my code. To prove that the company name is initialized, what I can do, I can call the employee dot print company name in uppercase method, and I can even remove this line because no need to create object of the class also. If you see, ABC organization is getting printed. So guys, the purpose of having the static constructor is mainly to initialize the static fields of the class. Okay guys, now let's understand the static and instance constructors. So we have the static employee constructor here. Let's create one non-static constructor for the class. I will use the public keyword and employee. Okay, now this is my non-static constructor, and I will print a console message here. Non-static constructor called, and within my static constructor I will put the print message static constructor called. Okay, now let's do one thing. We will create two objects for our class, employee and employee 2. So we have employee 1 and employee 2 objects that are created. Okay, so when we created these two objects, what will happen? Whenever we will create one object, it will call the non-static constructor, and whenever we create the next object, it will again call the non-static constructor. But at the same time, static constructor will be called only once. As I said before, static constructor can be invoked only once, and it will be invoked whenever we will refer the class in our code. Right? Now to prove that, let me just comment out everything. Okay, now I'm not doing anything. I'm not even referring the employee code in my main method. And if I run the program now, I can see there is no message and the static constructor is not invoked. Okay. Okay, now I'm creating two objects, and let's see what will happen when I run the program. You can see static constructor code is getting printed, and non-static constructor code is getting printed 2 times because we have created two objects. So this proves that whenever we will create an object, that will actually call the non-static method, and static constructor will only be called once in our program. Let's go back to slides now. Okay guys, static and instance class member we have learned in this video. When a class member includes a static modifier, the member is called a static member. So by default, if we don't provide the static modifier, that class field or class member will be considered as non-static. To make any class member static, we have to use the static keyword. Okay, second thing, when no static modifier is present, the member is called as non-static member or the instance member. That we have already seen in the demo. Static members are invoked using class name, whereas instance members are invoked using instances or objects of the classes that we have seen in the video. An instance member belongs to specific instance, or we can say object of a class. Okay, if we create 3 objects of a class, that will have three set of instance member in the memory, whereas there will ever be only one copy of a static member, no matter how many instances of the classes are created. So that we have seen, if we have a static field, that will be created only once in the memory. In that way, we can save the memory in our program. Okay, when we say class member, that can be fields, methods, properties, events, indexers, and constructors. So all these members can be static or non-static. Now let's discuss the static constructor. Static constructors are used to initialize static fields in a class. That we have seen in the employee class, we were initializing company name with the static constructor. Okay, you declare a static constructor by using the keyword static in front of the constructor name that we have seen. Static constructor is called only once, no matter how many instances you create. That we have seen, we have created two employee objects, but the static constructor was called only once. Static constructors are called before instance constructor. That we have seen, static constructors are getting invoked whenever the class name is used in the code. That time only the static constructor will be called, and that cannot be called again in the code. Okay guys, now let's understand the concept of static class. So guys, to create a class static, we have to use the static keyword as we have seen already. Public static class. Let me call it test. Okay, so this is how you can create a static class. The difference here is, in a static class, we want to be able to create any instance field. If I try to create an instance field, public int id, you will see we will already getting a red line here. It means we have an error. Cannot declare instance member in a static class because the class itself is static. So we want to be able to create any instance member in the static class. We can only have static fields. I can create a static field like public static integer id. I can create static methods in my class, public Okay, so this is how I can create static members in my static class, and it is not possible to have any instance member in my class. Similarly, I want to be able to create object also of that class. That makes sense because it is a static class and we don't have any instance field. So it makes no sense to create instances of that class. If I try to create any object of my class, test equal to new test, you can see we are getting the error message here. Cannot create an instance of the static class test. All right. And to access the members, as we have seen already, I have to use the class name, and I can put dot and I can set my static fields. Let's say id equal to 100, and I can also invoke my static methods using test class name method. And if I run my program, I can see hello world 100 is getting printed because we have initialized our static field to 100. So guys, this is how you can create a static class and use that in your program. In real world, we will create the static class whenever we have some functionality that will be used in multiple classes. For example, let's say we have one logging class and the logging methods will be used all over the project, and we don't want to create unnecessary objects for that class. In that case, we can declare that class as static, and I can access the methods of that class using the class name only without creating the object. And if you see the console class that we were using in our demo, to print any message on the console. If you go to implementation of this class, you can see this is a static class. Because console class is a static class, that's why we are able to invoke the writeLine method of that class without creating any objects of it. We are directly using the class name and we are invoking the writeLine method in it. So this kind of functionality can be easily implemented in a static class and can be used in other classes. Okay guys, that's it for this video. In the next video, we will learn about inheritance. Hello and welcome to the part 22 of this video series. In this video, we are going to learn about inheritance. In this video, we will see what is inheritance, we will see what are the benefits of inheritance, and we will try to understand some of the important concepts around inheritance. In object-oriented programming, we have four pillars that are known as inheritance, encapsulation, abstraction, and polymorphism. In this video, we will learn about first pillar of OOPS concept, that is inheritance. So let's get started. Inheritance is a fundamental concept in object-oriented programming that allows us to define a new class based on an existing class. The new class inherits the properties and methods of the existing class, and it can also add new properties and methods of its own. Inheritance promotes code reuse, simplifies the code maintenance, and improves the code organization. Let's open up the Visual Studio and understand this with an example. I have opened up my Visual Studio here, and let's create one class, public class. I will name it full-time employee. Okay, so a full-time employee will have their name, first name, they have their last name, they have their age, and a full-time employee will also have their salary, string monthly salary, or let's call it yearly salary. Let's suppose we have one more type of employee that is known as part-time employee. So I will copy paste the same class again. Okay, I will change it to the part-time employee. Part-time employee will also have their first name, their last name, and their age, but they will not have their yearly salary. Instead of this, they will have their hourly rate. One more thing, let's change the salary to of integer type, and it will be of integer type, and part-time employee will have hourly rate. Okay, so if you look at these two classes, we have four fields in each class and three of them are common in each. So what we can do with inheritance, we can move all the common code in a parent class, and then we can inherit that parent class to reuse that code in our child classes. Let me show you how. So I will create one class, public class base employee. Okay, and what I can do, I can remove the common fields from here. Now what is happening here, we have three classes. One is the base class. In that we have three fields which are common for full-time employee and part-time employee, and in part-time employee and full-time employee we only have the specific fields that are required by these classes. This way we have moved all our common code or reusable code in a base class. Now if you see, if I create an object of full-time employee, fte equal to new full-time employee, and try to access first name, you will see I don't have access to the first name because we have created the base class but we are not inheriting the base class. To inherit the class in C#, we have to use a colon and then we need to specify the base class name. So in this case, it will be base employee. Okay. Now, if I go ahead and try to access first name, you will see I have access to all the properties like first name, last name, age, and yearly salary. And if you notice, we still don't have access to the hourly rate because that is specific to the part-time employee. That's why for the object of full-time employee, that will not be accessible. So what I can do, I can go ahead and set the first name equal to Peter, full-time employee dot last name equal to Parker, age 30, and we can also set the yearly salary for the employee. Okay, so this is how we can access all four fields from our full-time employee class. Similarly, I can create an object for my part-time employee also. I will copy paste the same thing. Let me call it part-time. If you again see, we are again not having the access to the first name because the part-time employee is not inheriting the base class. So I will just inherit the base employee class, and now again I have the access to first name, last name, age, and we will not have access to year salary because yearly salary is specific to the full-time employee. In case of part-time employee, I have to use the hourly rate. So I can use hourly rate equal to maybe 500. If you see this code, we have moved all our common code in a base class. So this will make our code more clean, more maintainable, and more readable also. So we have discussed the first point, code reusability. We are reusing the code from the base employee class in our full-time and part-time employee classes. Code maintenance. Suppose we have to change the class field first name. That time we have to make change in only the base class employee, and we don't have to make any other changes. That way our code will become more maintainable. Code organization. Because we have moved all our common code in a base class, that will make our code more organized. And a note here, you will specify all the common fields, properties, methods in the base class, which allows reusability. In the derived class, you will only have fields, properties, and methods that are specific to them. Okay, now let's see how we can reuse methods from a base class. Let's say I will create a method print void print full name. Because the implementation to print the full name of full-time employee and part-time employee will be same, we can keep that code in a base class and that can be reused by both the objects. And if I want to print the full name of full-time employee, I can use fte dot print full name, and similarly I can use part-time employee dot print full name. So print full name method is available to both the objects. Let me change the name of the part-time employee. If I go ahead and run the program, you can see we are printing the full name of our full-time employee, and we are also printing the full name of our part-time employee using the same method print full name. So this is how you can reuse methods from a base class. Okay, now let's understand the type of inheritance that are available in C#. First one is the single inheritance. This is when subclass inherit the features of a superclass. So we have one class A, and that is inherited by class B. That is called single inheritance. No other classes are inherited by class B. That's why we call it single inheritance. Okay, second one is the multi-level inheritance. It means a derived class will be inheriting a base class, as well as the derived class also act as the base class to other class. So what is happening in this case, we have a class A that is inherited by class B, and B class is again inherited by class C. If we have this kind of hierarchy, This is called as multi-level inheritance. Third one is hierarchical inheritance. When one class serves as superclass for more than one subclass, that is known as hierarchical inheritance. In this case, what will happen? We have a class A that is inherited by class B and that is also inherited by class C. So what we have done in our earlier example, we have created a base employee class that was inherited by full-time employee class and that was also inherited by our part-time employee class. So that was the example of hierarchical inheritance. Okay, fourth one is multiple inheritance. In multiple inheritance, one class can have more than one superclass and inherit features from all parent class. Please note, C Sharp does not support multiple inheritance with classes. In C Sharp, we can achieve multiple inheritance only through interfaces. What is happening here? We have a class A and class B, and we have a class C that is inheriting from class A as well as class C. To note here, this is not possible in C Sharp. In C Sharp, we can achieve multiple inheritance only via interfaces. Let me show you how on Visual Studio. So let's create an interface, public interface I1, and let's create a second interface I2. And now I can create a class, public class, my class, and that can inherit I1 as well as I2. This is how we can implement multiple inheritance in C Sharp. The last type of inheritance is hybrid inheritance. So what will happen in hybrid inheritance is we will have a class A that can be inherited by class B and that will be inherited by class C also, and we can have a class D that will inherit class B as well as class C. Again, this inheritance is not possible through classes in C Sharp. This can only be achieved using interfaces. And guys, don't worry if you don't know about interfaces. We will learn about interfaces in very detail in future videos. Okay, now let's understand the concept of base class and derived class constructors. The first point is the base classes are automatically initiated before the derived class. This makes sense because to reuse the members from the base class, we have to first initialize our base class and then only we will initialize the derived class. Let's see this in Visual Studio. So let me create a class public. So whenever we will create the child class object, that will automatically initialize the parent class fields. Okay. Second point is base class constructor executes before child class constructor. So let's say I have a constructor in my parent class, ctor tab, it will create the constructor for us. Okay. So let's go ahead and create a constructor in child class also. Okay, so I have constructor in my child class and in my parent class, and they are doing nothing but printing a message on a console. So if I go ahead and create an object of my child class, child C equal to new child. So what will happen when we do this? Before calling the child class constructor, the parent class constructor will be invoked, and then only the child class constructor will be invoked. Let's see when we run the program what will happen. You can see here parent class constructor was invoked before and then only child class constructor was invoked. Okay, let's suppose we have one more constructor in my class and this is a parameterized constructor. So this will take one parameter. The requirement is I want to invoke my parameterized constructor instead of the parameterless constructor. By default, .NET Framework will invoke the parent class constructor which is not taking any parameter. To prove that again, let me run this program. You can see the parameter less constructor is getting invoked and .NET framework is not invoking the parameterized constructor that is taking the string variable. You can use the base keyword. I will call base, and if I put my bracket there, parenthesis there, it will give me two options. Either I can call my parent class constructor that is not taking any parameter, and the second option, I can call my parent class constructor that is taking message as the parameter. So this time I will use this constructor and I can pass the parameter hello world. So what is happening here? When we will create the child class constructor, instead of calling the parameter less constructor from parent class, it will invoke the parameterized constructor. Let's go ahead and run this program. This time you can see your message is hello world was printed. So guys, this is the use of base keyword. A base keyword can be used by the child class to invoke the particular constructor from the parent class. That's it for this video guys. In the next video, we will learn about method hiding. Hello and welcome to the part 23 of this video series. In this video, we will learn about method hiding. As part of this video, we will see what is method hiding. We will see an example of method hiding with a demo, and we will understand the use of new keyword in context of method hiding. Method hiding is also known as method shadowing. In this concept, if we have a method in the base class, then we can hide that method in our derived class using the new keyword. Let's open up Visual Studio and understand this with an example. I have opened up my Visual Studio and let me create a parent class. Okay, and let's create a class with name child. Now let's make our child class to inherit the parent class. If you remember from the last video, we can use the colon and then we can specify the class that we want to inherit. In this case, that will be parent class. Now our child class is inheriting parent class. Now let's say we have a method in our parent class. Okay, so we have added a print method in parent class, and because we are inheriting the parent class in our child class, we can use that print method in our child class also. So if I create an object of my child class, and if I say c1.print, and if I run this program, you can see we are printing I am in parent class. Now let's suppose parent class has given the definition, but the child class wants to give their own implementation of the print method. In that case, what they can do, they can use the concept of method hiding. We can hide the method which is present in our parent class. To do that, what I can do, I can just simply declare the same method with the same signature. I can create this print method in my child class and I can provide my own implementation. If I run this program, you will see I am getting the message I am in child class. So we have successfully hidden the method that was available in parent class. This concept is called as method hiding and also known as method shadowing. Now if you notice here, you will see a green line is coming up on our print method. A green line means it is a warning message. So let's go ahead and read this warning message. It says child.print hides inherited member. Parent.print use the new keyword if hiding was intended. Because we have print method in the parent class also, and we are hiding that method, so it means compiler is telling us the method present in parent class is now hidden. Do you really want to hide that method? If yes, then you can tell the compiler with the new keyword. To tell the compiler the method hiding was intentional, we can use the new keyword public new, If you notice here, once we have added the new keyword, the warning message is now gone. So this is how you can use the new keyword to tell the compiler the method hiding was intentional. Now let's say we have hidden the method from our parent class, but still we want to invoke the method from our parent class. Is that possible? Yes. To do that, what we can do, there are two ways. First one is to use the parent class reference. So instead of creating the object of child class, I can use parent class reference here, and I can call it C1 equal to new child. Because child is inheriting the parent class, so we can assign child class object to a parent class variable, and it is possible because of inheritance. And now if I try to invoke c1 dot print method, you will notice the print method from the parent class will get invoked. I am in parent class was printed. So this is how you can access the hidden methods. There is one more way, that is to do the typecasting. So if I have the child class object, what I can do, I can cast this object to a parent class reference using parent like that, and I can specify C1 here, and the whole thing I can put in brackets, and then I can call print method. So if you see what is happening on line number 12, we are typecasting the C1 object to a parent class type, and then we are invoking the print method. If we run the program now, you will see I am in parent class method is getting invoked. So guys, it is still possible to invoke the methods from the parent class even if they are hidden by the child class. That's it for this video guys. In the next video, we will learn about polymorphism. Hello and welcome to the part 24 of this video series. In this video, we will learn polymorphism. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. I have opened up my Visual Studio and I have created four classes: employee, permanent employee, part-time employee, and temporary employee. All three child classes are inheriting the base class, that is employee. Now to understand the polymorphism, let's see an example. I will create an object of employee type. I will call it E1 equal to new employee. Okay. Now let's say I will create second object of employee type E2, and this time instead of assigning a employee object to it, I will assign a permanent employee object. So what I'm doing here, what I'm doing at line number 11, I'm creating an object permanent employee and I am assigning it to a variable of type employee. Because permanent employee is inheriting employee type, we are able to do this. So this is possible because of polymorphism. Because permanent employee is also an employee, we can say employee E2 equal to new permanent employee. Let's create two more objects. See, we are still not getting any error. And if I try to build this application, we can see build is succeeded. And now let's understand how the methods will behave when we are having the polymorphism applied. Let's create method here, public. Okay, so I have added a method print full name that is printing first name and last name. Okay, I have initialized my variables with first name and last name. Now what I can do, I can invoke my print full name method on all my objects. E1 dot print full name. Okay, so I am invoking print full name method using all these objects E1, E2, E3, and E4. If I run this program, As expected, we are getting full first name, last name, fn and ln for all four objects. Now let's suppose what we want to do for all the employees. We want to mention their type also, fn, ln. Then we want to print their type also, like if they are permanent employee. So what I want to do, I want to print like this. I want to print first name, last name, and then the dash, and then the type of the employee, permanent employee, temporary employee, or part-time employee. So let's see how we can achieve it. To achieve it, we can create methods in our class. So I can add the permanent employee here. Okay, so now I have added the print full name method in our all four classes, and each class has their own implementation. Now if I try to run the program again, you will notice there is no change. We are still getting fn ln. This is because we have created the objects with the reference of employee type. So every time we are invoking the even dot print full name or e2 dot print full name, it will always go to parent class and invoke this method. So if we want to invoke the methods from the child class, what we can do, we can create our parent class method as virtual. So if I use the virtual keyword here, this will make our method as virtual, and now child classes can override this method. Let me show you how. And now let me say, let's type override keyword and put a space after it. If you notice here, Visual Studio is giving us the options which methods we can override, and you can see we are having this option print full name that is available to override. If I double click, it will create the method for us, and we can provide our implementation that is specific to the child class within it. So I will copy this line and paste it here. Similarly, I can do the same thing for my other child classes also. Now child classes are overriding the method definition present in our parent class. Now if I try to run the program, you will notice we are getting the output as expected. For employee class object, we are getting first name, last name, and for the other objects, we are getting the respective, we are invoking the respective print full name method, and we are also printing the type of employee, that is permanent, part-time, and temporary. So this is how we can create virtual methods in parent class and override those virtual methods in our child classes. And the benefit of using the virtual method is that suppose we don't want to give any implementation to our temporary employee class, and we just want to use the implementation provided by the parent class. What we can do, we can simply remove this method from here. And if you notice, we are still not getting any error, because when we are invoking print full name method for our temporary class object, it will invoke the method from employee class. If I hover over here, you can see it is pointing to employee class dot print full name method. If I run the program, you will see for the permanent employee and part-time employee, they are having their own implementation, but because we don't have any implementation in our temporary class, that time it will go ahead and print the method that is available in the parent class. Let's go back to slides now. So we have seen polymorphism is one of the primary pillar of the object-oriented programming. In the previous videos, we have seen inheritance. That is also one of the important pillars in OOPS concept. And this is the second pillar that is called as polymorphism. Polymorphism allows you to invoke derived class method through a base class reference during runtime. You have seen we have used the employee class reference, and we were storing object of different child classes in that, and we were able to invoke methods from the derived or parent class. In the base class, the method is declared virtual, and in the derived class, we override the same method. We have seen that we have declared the method print full name as virtual in our parent class, and child classes were able to override that method. The virtual keyword indicates the method can be overridden in derived class. If you don't use the virtual keyword, in that case, that will hide the method. That's it for this video, guys. In the next video, we will try to learn the difference between method overriding and method hiding. Hello and welcome to the part 25 of this video series. In this video, we will learn the difference between method hiding and method overriding. So let's open up the Visual Studio and understand this with the help of an example. I have opened up my Visual Studio. So let's create a class. Public class, I will name it base class. Okay, let's create a derived class also. Public class, derived class, and this class will inherit the base class. Let's say we have a method in our base class, public void print, and this will write this is from base class. Okay, I will add the same method in my derived class also, and I will change the text. This is from derived class. Okay, now let's go ahead and make the print method in parent class as virtual, public virtual. So we can use the virtual keyword to make our method virtual. Now what we can do, we can override this method. As we seen in the last video, if a method is declared as virtual in parent class, then the derived classes or the child classes can go ahead and use the override keyword and provide their own implementation. So if I want to provide my own implementation to the derived class, I can override the method present in the base class. But let's suppose I don't override the method now. I will just go ahead and write it like this. And let's create an object of the derived class D equal to new derived class. Okay, what is happening here? We have created a variable D that is a reference type variable, and type of this D is derived class, and this D variable is pointing to derived class object. But because derived class is inheriting base class, what we can do, we can change this reference with the base class. So guys, again, this is possible because of polymorphism. If the derived class is inheriting the base class, then a base class reference variable can point to a derived class object. And if I try to invoke print method now, you will see it is invoking the method from the parent class. This is from base class. And this is happening because we are not overriding the method present in the base class. So if child has given their own implementation, and if we want to invoke that particular implementation, we have to create the method of parent class as virtual, and in the derived class we need to use the override keyword to override that method. If I run the program without making any other changes, we are getting the text this is from derived class, because now we are overriding the method present in the base class. So instead of calling the method that is present here at line number 20, it will go and search for the method in the child class and invoke this particular method. So basically guys, this is what method overriding is. Now let's see what is method hiding. We have already seen the method hiding. In case of method hiding, we will not override the method. Instead, we will use the new keyword. So let's do that. So I will remove the virtual keyword and I will remove the override keyword, and instead of using the override keyword, I will use the new keyword. We have seen this in the past video. If we use the new keyword, it means we are trying to hide the method available in the parent class. And if I invoke or if I run this program as it is, you will notice we are invoking the method from the base class. So guys, this is the basic difference between method overriding and method hiding. In case of method hiding, we are printing the message or we are calling the method that is available in the parent class. And in case of overriding, we are calling the method that is available in the child class. So let's go back to slides now. Okay, so we have seen the difference between the method overriding and method hiding. And we have also seen a demo to understand these concepts. And to summarize, in method overriding, a base class reference variable pointing to a child class object will invoke the overridden method in the child class. Second thing is, in method hiding, a base class reference variable pointing to a child class object will invoke the hidden method in the base class. That also we have seen when we were using the concept of method hiding. In that case, when the class reference variable was pointing to the child class, the method that is available in the base class was getting invoked. That's it for this video, guys. In the next video, we will learn the one of the most important concept in C#, that is method overloading. Hello and welcome to the part 26 of this video series. In this video, we will learn about method overloading. As part of this video, we will learn what is method overloading and we will try to understand it with the demo. And we will also understand the most important question that you will be asked if you are going to a C# interview, that is what is difference between overloading and overriding. We will cover this question in detail. Method overloading allows programmers to use multiple methods with the same name. The methods are differentiated by their number and type of the method arguments. Method overloading is an example of polymorphism feature of object-oriented programming. So let's open up the Visual Studio and understand this with the help of an example. I have opened up my Visual Studio. Let's create a class. Okay, I have created a method with the name add that is accepting two parameters, integer a and integer b, and the return type of the method is void. And currently I am adding up the numbers a and b and printing that sum using the console.writeLine. Now let's see what will happen if I try to add one more method with the same name and same parameters. If you notice here, we are getting a red line here. Red line means an error. So let's go ahead and read the error message. It says, type method overloading already defines a member called add with the same parameter types. What it means? It means in the method overloading class, we already have a add method with the same parameters. So we cannot add the same method again in our class. If you want to add the method with the same name again in our class, we need to differentiate it by changing the number of parameters in a method, or by changing the order of parameters in a method, or using different type of data types in the parameters. So now let's understand how we can achieve method overloading here. What I can do, I can add one more parameter, int c. And if you notice here, we are not getting the error anymore and we are able to create same method, method with the same name twice. So we have two add method name here, and if I try to invoke the add method, first I have to create an object of my class. So method overloading m equal to new method overloading. And now if I try to invoke my method add, If you notice here, C sharp is telling us we have two methods of it. One is accepting two parameters, and if I click the down arrow here, this will give me the second option. That method is taking three parameters. So this is how we can overload the methods by giving different number of parameters. In the first method, we have two parameters, int a, int b, and in the second method, we have three parameters, a, b, and c. And I can go ahead and invoke the method like this. So this will invoke this particular method, which is available at line number 20. And if I pass three parameters, 1, 3, and 4, this will invoke this particular method. Let's run this program. We can see we are getting the sum as expected, 4 and 8. So this is one way to overload the method by changing the number of parameters. Second way is by changing the type of the parameters. So let's say I have one more method, public void add, and this time I will take two float types. So what I'm doing in this method, I am accepting two arguments, float a and float b. And if you notice here, we are still not getting any error because the method is overloaded by using different type of parameter. Let's complete this method. Okay, so I am adding up a and b and printing this sum. And if I try to invoke the add method again, and this time you will notice we are getting three options here. One that takes float, second one takes integers, and third one takes three integers. So let me invoke my float one. So I can pass 5.1 float value, 6.4 float value, 5.1 and 6.4. And if we run the program, we are getting the sum as expected. So this is second way to overload the method. We can create the method with same name by changing the type of arguments or parameters that we are passing to the method. Third way of doing the method overloading is by changing the sequence. Let's say we have a method here that says print string name and integer age. Inside this method, I'm not doing anything. I am just printing. Now let's create one more method. Let's overload this method. Print string. So this time, instead of giving the name parameter at the first position, I will give age parameter at the first. First, I will give age parameter, int age, string name. And I can print the same thing again. If you notice here, we are not receiving any error and we are able to overload the method by changing the sequence of parameters. So basically we have changed the sequence of parameters. First we are passing the string and then integer. In the second method, we are passing integer first and then the string. So let's try to run these methods also. If I type mo.print, Visual Studio is giving us two options. One that takes integer age first and second one that takes string name first. So let's go ahead and execute both the methods. So first I will give name here, Peter, age 30. And second time we can give our age first, let's say 40, and John Walker. So let's go ahead and run this program now. As you can see, we are getting the name and the age as expected. So this is how we can overload the method by changing the sequence of parameters. And guys, please note here, we cannot overload the method by changing the return type. If you see here, we have an add method here is having the return type void,
And if I try to add one more method by changing the return type from void to integer this time and try to create the method with the same parameters. If you notice here, we have the same parameters, but we have changed the return type. And this time we are not able to overload the method. We are already getting one error message here. It says method overloading class already defines a member class with the same parameter types. So guys, to overload the method, we have to somehow change the method parameters. That is the only way to overload the method. So this will not work. We cannot overload the method by changing the return type. And now let's go back to slides. Okay guys, so we have seen what is method overloading, and we have also seen a demo where we have created add method and print methods, and we have overloaded those methods by changing the number of parameters, sequence of parameter, or type of parameter. Now let's understand the difference between method overloading and method overriding. Okay, on this slide, we have the difference between method overloading and overriding. Let's understand this step by step. First point is creating more than one method or function having same name but different signatures or the parameters in the same class is called method overloading. Let's go back to Visual Studio and see what is a signature. If you notice here, the method name and the parameters that are passed to the method, that is the signature of the method. A signature don't include the return type, that's why we are not able to overload the method by just changing the return type. Okay, whereas in method overloading, creating a method in derived class with the same signature as a method in the base class is called as method overriding. If you remember the last video, we were having this method with the same signature, I mean the same name and the same parameters, but they were present in the different classes. Method overloading is called the compile time polymorphism. So at the compile time, we will decide which method we will be invoking, and method overriding is known as runtime polymorphism. At the runtime, it will be decided which method will be invoked. In method overloading, it has the same method name but the different signature or the parameters. In method overriding, it must have the same method name as well as the signature or the parameters. Method overloading does not need inheritance. In this video, you have seen we didn't inherit any class, we just went ahead and overloaded the method. Method overriding needs inheritance. If you remember last video, we were having some child classes and parent classes, and using those classes, we were implementing the method overriding. Method overloading is possible in single class only. That we have seen in this video, we have created method overloading class. In that class, we were overloading the methods. Method overriding needs hierarchical level of classes. That is one parent class and other child class. In method overloading, we can use any access modifier, but in case of method overriding, we have to use the public access modifier. Method overloading is also called as early binding because at the compile time only we will decide which method will be invoked. Method overriding is also called as late binding because at the runtime we will decide which method will be invoked. That's why we call method overloading as compile time polymorphism and method overriding as runtime polymorphism. That's it for this video guys. In the next video, we will learn about properties.
Hello and welcome to the part 27 of this video series. In this video, we will learn about properties. In this video, we will understand why we should use properties, and we will also understand getters and setters that were used before properties were introduced. So let's open up the Visual Studio and understand this with the help of an example. I have opened up my Visual Studio. Let's create a new class. I will right click on a project and select the add option from here, and then I will select class. This will open up all the templates that are available for me. I will select the class template and I will give my class name as student, and I will click on add. This will create a class for me with name student. I will change this internal modifier to public. Okay, now let's add some class field to our class. Okay, so we have added 3 class field in our class. Let's go to our demo class now. So this is our demo class, and let's open up the student class also side by side. I will right click on student.cs tab, and from here I can select the option new vertical document group. This will open the files side by side. I will remove this unnecessary using statements. And now let's try to access our class. To access our class, let me create an object of my class, student s equal to new student. Okay, now let's try to assign some values to our class fields using the s object. I will say s dot student id equal to -99, s dot name equal to null, s dot passing marks equal to s dot passing marks equal to, let's say, 10. If you notice here, I am able to provide some invalid data for my class. I am able to assign student ID -99. That should not be a valid one in a real scenario. I have assigned name null, but every student will have a name. So that is also invalid value for my class field. And I am able to change my passing marks to 10. Ideally, we should not allow these kind of modification or assignments in our classes. To solve this problem, what we can do, we can use properties. But before we see the properties, let's see what we were using before properties were introduced. Before properties were introduced, we were using getters and setters method. Let's see how we can create getters and setters. Getters or setters are nothing but methods that we can expose. Instead of exposing the class fields directly, we can expose the functions that will allow us to have some control to what data we are assigning. Let's say for the student ID, I will create an getter method that will say public integer get student ID. And what this function will do, this will just return the student ID. Return this dot student ID. That's it. And similarly, let's create a setter for this. I will move this document to the previous view group by clicking this option, move to previous document group. Okay. Now let's create a setter for my student ID field. Now we have created a get method and set method. These are called as getter and setter method. After doing this, what I can do, I can change my class field from public to private. Okay. Now if we go back to our demo class, you will notice we are getting the errors. Now we cannot access these fields directly. To access these fields, I have to go through via getter and setter methods. Let's say if I want to set the student ID as dot student ID, I have the method set student ID, and here I can pass my ID. Let's try to pass 99, and if you notice here, we are not getting any error and we are still able to set the student ID as 99. But now what we can do, we can add some validation within our method. So inside the get student ID method, what I can say, if ID is less than 0, throw new exception id cannot be 0. Id cannot be less than 0. Okay. Now if I try to run this program, you will notice we are not able to run our program, and while running it is giving us the exception system.exception id cannot be less than 0. So this way we can provide some validation to our class, and the consumer of our class means the demo class is now not allowed to pass any invalid values for our class field. Let's create the getters and setters for the other class fields also. Okay, so I have created getter for my name and a setter for my name, and I have created a getter method for my passing marks field. If you notice, I have not provided definition for the set passing marks because we don't want anyone from outside to access the passing marks field and change the value of it, because passing marks are defined as 40 in this class. So someone from outside should not be able to modify this. Let's say if someone tries to set the name as null, if I pass set name as null here, what I can do, I can add some validation within my set name method. If name is equal to null, I can set name equal to no name provided. Okay, I will set my name to no name provided string, and then that string I will assign to my name field. Okay, and I can get the passing marks also if I want. So let's declare a variable passing marks. I will say pm equal to s dot get passing marks. So that's how we can access the passing marks. So this is how we can protect our class fields from outside world. Okay, so let's provide some valid ID 101. Let's provide some name Peter. And now let's try to access these fields using the getter methods and print those using console.writeLine. So I have used the getter methods get student ID and get name. Let's go ahead and run the program. You can see we are able to access the data using one getter methods student ID 101, student name Peter, and passing marks equal to 40. So guys, this is the benefit of using getters and setter methods. We can define our class fields as private, and we can expose our class fields using getter and setter methods. And we can add our validations and rules in our getters and setter methods. So let's say whenever we want to get the name of a student, we should always return the name of the student in uppercase. We can add this logic in our getter method. So in my get name method, I can declare a string name in uppercase, and I can call this dot name dot to upper. So this will change my name to uppercase, and now I can return this string. Okay. Now let's try to run the program again. You will notice we are getting the student name in uppercase now. That's it for this video guys. In this video, we have seen how we can use getter and setter methods. In the next video, we will create properties and understand what are the type of properties available in C#. Hello and welcome to part 28 of this video series. In this video, we will understand properties. As part of this video, we will understand what is encapsulation
and how we can create properties and how we can achieve encapsulation by using properties, and we will understand what are the different type of properties available in C Sharp. So let's try to understand what is encapsulation. The meaning of encapsulation is to make sure that sensitive data is hidden from user. To achieve that, we must declare field variable as private, and we need to provide public getters or setter methods or properties to access and update the values of private field. If you remember in the last video, we have declared getters and setter methods, and we were using those methods to access and update the values of private fields. Let's open up Visual Studio and understand this with the help of an example. If you remember from the last video, we had this class student and we have created three class fields which were private, and we have created public getters and setter methods to access and modify the fields. And guys, notice here, whenever we declare anything as private, that field will be accessible within that class. If we try to access that field outside that class, we won't be able to access that. If you notice here within this class, let's say if I try to access my class field, this dot student ID, I'm able to access it. All right. But if I try to access this student ID field outside, like in my demo class, if I say s dot student ID, you will notice we are not getting the options of student ID. Only we have set student ID and get student ID options. Okay, so if anything is private, that will only be accessible within that class, and if anything is public, that will be accessible outside the class also. Okay, now let's understand how we can reduce this line of code by using properties. So now let's go ahead and remove all this code and create properties for this. Okay, to create a property, what we have to do, we have to type prop and we have to press tab. If you press the tab button, it will create a property of type integer, and the default name will be my property that you can change very easily. Let's keep integer type for our first property and change the property name to ID. Let's create second property, string name, integer, passing marks. Okay, so properties will look like something like that. By using this one line of code, we have created getters and setters, and at the back end, C# will create a class field for our this property. Okay, now let's try to use these properties in our demo class. Let's remove all this. And now if you use the S object, I mean the student object, and press dot here, you will see you have access to all the properties. You have access to passing marks, ID, name. So what we can do here, we can assign the value here, ID equal to 101. Right? You can assign name equal to Peter. But let's try to add some negative value, I mean some invalid data to our properties. Let me try to add 101. If you notice here, we are able to assign that value. And if I run the program, it will run without any issues because we have created the properties, but we have not added any validations. So let's go back to the student class and add the validation within our properties. And guys, just one more thing. These type of properties are known as auto properties. When we use these type of properties, C# compiler will automatically inject class field for us, and that class field will be used when we are setting or getting the value. Now let's see how we can add the validations when we are setting the value. Let's say someone is setting 99. Let's add some validation to avoid that. We will create our private class field, integer ID. And now what we can do, we can expand these getters and setter by removing the semicolon from here and put the curly braces.
if we have removed the semicolon from getter, we have to remove it from the setter also. Because if you read the error, set must declare a body because it is not marked abstract, extern or partial. So let's provide a body for our set also. Now we have body for our get and set. And if you notice, the getter is getting the error because we are not returning an integer value from our getter. So let's return id from here because this property is for id field. Okay, and now while setting, we can check the value. If value is less than 0, then print or throw a new exception. id cannot be less than 0. Okay, else we can set our id with whatever value is coming from here. Okay, if you notice here, we are using this value keyword. So in C#, the value keyword will have the value whatever is passed to that property. So whenever we are setting the value 99, the 99 value will come to this keyword or the variable. Value is an auto-generated variable created by the C#. If we put a breakpoint here and run the program, you will notice the value inside the value variable is minus 99. And if we continue this program, it will give us the error or the exception. id cannot be less than 0. So guys, this is how we can add validations in our properties. Similarly, within the get also, we can perform some operation if you want. Like if I want to change id to, what I can do, I can declare a variable integer new id equal to underscore id into underscore id. So I'm squaring the id and I can return this particular new id from my property. Now let's try to access the property id with cw.s.id. And if I run the program, let's change it to some value now because else we will throw the exception. Let's change it to 16. And if I run the program now, you will see we are getting the square of 16, 256. So guys, instead of using getters and setter methods, we can use the properties that will allow us auto-created getters and setters that we can modify according to our use. And if you notice here, we are using s.id to set the value and we are using s.id to get the value. So getters and setters makes it very simple to encapsulate the fields and allow us to use the values or update the values by using properties. Okay, on this slide, we have some information about properties. Let's understand this. In C#, properties are a fundamental concept for data encapsulation and access control. That we have seen, we have hidden our field ID using the private keyword, and we have used properties to allow the user to access the fields. Properties provide a controlled way to interact with underlying data of class. Controlled way in the sense like we had those get and set methods within the properties. Within those getters and setters, we were able to provide some additional logic without much effort. Let's understand the benefits of properties. Next one is the encapsulation. Properties hide the internal implementation details of the data storage. You can control access by defining appropriate access modifiers. Like we can declare our field private, public, or maybe protected. We will understand protected in our future videos. Data validation. As you have seen, we were able to validate our ID field, like if that was coming less than 0, we were throwing the exception. So those kind of validations are very easy to perform with help of properties. That's what this point says. You can add logic within the set accessor to validate incoming data before assigning it to the underlying field. This ensures data integrity. Third point is custom logic. Accessors can perform additional tasks beyond simply getting or setting the value. For example, you might update a related property when the value changes. If you notice in the Visual Studio, when we were returning the ID, we were not returning the actual ID,
which was there at line number 7, we were squaring that ID and then we are returning a new ID to the user. So we have the complete control of the data within this class. Okay, now let's understand the type of properties that are available. Read write properties. If you notice here, the property that we have created is a read and write property because we have provided the read implementation, like we have the getter and we have the setter also. So we can get the value also. I mean, we can read the value also and we can write the value also using this property. So that is our read and write property. Okay. And let's say for the passing marks, if I remove the set keyword from here, this will make it only a read-only property. So we can define the passing marks here. Let's say 35. Like that, like we can initialize the value like this. And within our program, we can access it using s dot passing marks. If I run the program, we will get 35. But if you try to modify the passing marks, if I try to say s dot passing marks equal to 10, you will notice we are getting the error here. If you read the error message, property cannot be assigned to because it is a read only. Okay, so we have seen read write properties. We have just seen the read only property. Let's see the write only properties. Write only properties are very rare. Let's understand this with an example. Okay, let's create a property integer age, and this time instead of removing the get keyword, I can assign private keyword to it. So I have declared my getter as private. If I try to access the age property s dot age equal to 20, this will not give me an error because it is a write only property. So we can write values to age property, and if we try to access the value, let's try to print the age variable s dot age. You will notice we are getting the error here. The property cannot be used in this context because the get accessor is inaccessible. Because we have created the getter as private, we are not allowed to use it in different class. Okay, let's understand the automatic property. If you notice the name property here, we have created get and set. This is called as automatic properties because for this property we have not declared any class field, and class field is automatically generated by the C# compiler. That's why these properties will be considered as automatic properties or auto property. Next type of property is static property. Let's see this one in Visual Studio. Let me create a private static field, school name, because school name will be common for all the students. So we can declare the school name field as static. Let me declare it is of string type. Okay. Now we can create a static property to access this field from outside this class because currently school name field is private. So nobody from the outside world will be able to access it. So let's provide a property of string type, and I will call it school name. Let's change the class field name as underscore school name. Now I can create these properties as static using the static keyword here. Now within the getter, I can assign some value to my property. So I can say get equal to return underscore school name. And with set, what I can do, I can say this dot, because this is static property, we won't be able to access it by using this keyword underscore school name equal to whatever value we are passing to this property. So this is our getter and this is our setter. So let's try to use it in our demo class. I can say student
dot school name equal to ABC school. If you notice, we are able to access the school name with the class name because it is in static field. Let's try to print the school name using console.writeLine method. Student dot school name. If I run the program, I will get the school name as expected. Next one is indexer property. Okay, to understand the indexer property, let's create a private array in our class. I will say private string and I will call it team names. Let me declare the size of this array as 5. Okay. And now let's create an indexer property for our team. I can say property prop of string type. And what I can do, I can use this keyword and I can pass integer I. And I can create my getters and setters within it. So let me create my getter and setter like this. From the getter, let's return a string variable because the type of this property is string. So what we need to return, I will return whatever is there in the team name at the I index. Correct? And while setting it, what I need to do at the team name I place, I need to set whatever value is coming. Okay. Very simple property. I am returning whatever is available at ith place and whatever value is coming, I am setting it or storing it in the array at ith place. Okay. Now let's see how we can access this field. Let me open this class in the vertical window. Let's see how we can access the indexer property. We can just use the S object and provide the square brackets here, and let's say at 0th place I want to store team 1. Similarly, let's add 5 teams. So this is how we can access the indexer property. Using the index, we can assign values to our array. And now what I can do, I can access this value using a for loop. And to access the property, what I can do, I can use S object, and again I can use the indexer property, and I can pass the position of the index which I want to retrieve. Let's remove these two console lines, and if I run the program now, you will see we are getting team 1 2 3 4 5 as expected. So what is happening here, guys? When we are saying S of 0 position equal to team 1, this setter will be invoked and we will store value that will be nothing but team 1 to the team name array, which is declared line number 43, and I will be 0 here. So at 0th position we have stored team 1. Similarly, 2, 3, 4 and 5. All these teams will be stored within the team name array. And to access the array, we can again use the indexer property using S and then the square brackets. Within this square bracket, we can provide the index which you want to access. If you notice here, there is no name for this property. We are able to directly access it using the square brackets on our student object. That's why, guys, we can only have only one indexer property in a class. And sometimes we don't call it indexer properties. We will just call it as indexers. So now we have seen the indexer property also. Now let's understand the init properties or initialize properties. This property is very latest one that was introduced in C Sharp version 9.0. So let's open up the Visual Studio and understand this. So now let's create an init property. And now instead of using the set keyword, I will use the init keyword. Now let's see what will happen when we try to access this property. Okay, let me remove this code. Let me say e dot email equal to abc at the rate xyz z.com. Okay, so we have stored abc at the rate z.com in our email field. If you notice here, we are getting the error. We are not able to access it because it is init only property. If you read the error message here, it says init only property can only be assigned in an object initializer. So when we are creating the object, at that time only we can access this property and assign the value to it. Let me show you how. So we have created this object at this line number 10. So at line number 10, what I can say, I can put my curly brackets here and I can access my email property here. And I can say abc at the rate z.com. And guys, we have to change the type in our student class because we have declared email as integer. Let's change it to string. And if you notice here, the error is gone and we are able to assign email to our email property, and we can access it using property again as dot email. And if I print and if I run the program now, we are getting our email as expected. So guys, init properties can only be initialized once and they need to be initialized within the object declaration. And again, if I try to change the email again, once it is assigned, I will get the error. Init property can only be assigned in an object initializer. So this is our object initializer. And that's it for this video, guys. In the next video, we will learn about structures or structs in C Sharp. Hello and welcome to the part 29 of this video series. In this video, we will understand structures. So let's open up the Visual Studio and understand this with help of an example. I have opened up my Visual Studio. So let's create a structure. Public struct. And let's name it customer. Just like class, we can define properties or fields inside a structure. Let me create a field, public integer id. And just like a class, we can declare properties also within our structure. I will create the type of property of integer because I want to encapsulate my id field, and that's why I will create my property of integer type because id is also integer type. So let me call it id. Let's create getters and setters within our property. So the same way we declare properties in class, same way we can declare it in structure also. And same way we can declare some methods also in our structure. Let's go ahead and use this structure in our program. So within our demo class, I will create an object of customer structure. So just like a class, we can create objects of a structure also. So let's call it customer is equal to new customer. So now I can assign id customer.id equal to 101, and I can also invoke the methods which are available in structure. So let me call it using print id. So I have created an object of my structure and I have used the property id
and assigned value 101 to it, and then I use the customer object to invoke print id method. Let's run this program. You will notice we are getting the id 101 on console window. Okay, so let's create some other properties and encapsulate those also. Let me create a field, and by the way, I have to declare this field as private. Okay, let's create some more class fields. Private, string name, private, string email, private, integer age. Okay, so now we have created 3 more class fields. Now let's create properties for these also. In Visual Studio, you can right click on your class fields and select the option quick actions and refactoring, and then you can choose the option encapsulate fields. If you notice here, it has created 3 properties for us: name, email and age, and it has also created getters and setter methods that are using the lambda syntax to create it. We will understand the lambda syntax in future videos, but now we have 3 properties for our 3 private class fields. So let's use these properties. I will say customer dot name equal to test. Okay, let's access these properties and print it on console window. Let me remove this line and let's use console.writeLine. Now let's run the program. We are getting all the values which we have assigned to our customer structure object. So just like a class, a structure can have fields, properties and methods. And there are some differences between a structure and a class also that we will understand in the next video. But now let's understand the concept of object initializer. If you notice here, we have used these 4 lines to assign the values, but we can replace these lines with an object initializer syntax. In the last video, we have briefly seen the object initializer syntax, but now in this video, let's understand how it is used. So just like after creating the object, I can put my curly braces here, and within this curly braces, I can access my properties. If you type id here, or you can see all the 4 properties are available within my object initializer. This block of curly brackets is called as object initializer. So whatever I was doing here, I can do same thing within my object initializer also. And guys, in the object initializer, we have to use commas instead of semicolon. Okay, now I can remove these lines, and if I run the program again, I will get the same output. So this is the other ways to initialize the properties of an object. Let's go back to slides now. Okay, so in this video we have seen a demo using structures. We have seen how we can generate properties using the Visual Studio, and we have seen the object initializer syntax. Okay, and just like a classes, structure can have private fields, public properties, constructors and methods also. Object initializer syntax was introduced in C# version 3.0, and it can be used to initialize either a class or a structure. Please note there are many differences between classes and a structure, which we will be looking at in a later video session. So we have seen the private fields, public properties and methods in a structure. So now let's see how we can use constructor in a structure. Let's go back to Visual Studio. To create a constructor, we have to use public keyword, and then we have to specify the constructor name, and constructor name will always be same as class name. So I will use the customer. So within the customer constructor, I have to initialize all my class fields. Let's take those fields as a parameter, and within my constructor I can set my class field this dot So I have initialized all my class fields with the parameter which I am receiving, and now I can go back and create my object using my constructor. So I can say customer2 equal to new customer, and this time I can pass my parameters within my object. So I can pass 101 for my ID. Let's pass 102. Let's try to access these fields now using the properties. Let's run the program. You will notice we are able to access the fields which we have assigned while declaring the object. That's it for this video, guys. In the next video we will learn all the difference between a structure and a class. Hello and welcome to the part 30 of this video series. In this video we will learn the difference between a struct and a class. In this video session we will see how a struct is different from a class, and we will also understand what is a value type and what is a reference type, and we will also understand the difference between stack and a heap, and at the end we will understand what is the use of sealed keyword in C#. So let's get started. Okay, structure. In the last video we have seen structures, how we can create structure and use it in a program. If you remember from the past video, we have used the struct keyword to create a structure. Just like classes, we can have fields, properties, constructors, and methods in a structure. But there are many differences between a class and a structure, which we will explore in this video. Okay, so a structure is a value type, whereas a class is a reference type. So all the differences that are applicable to a value type and a reference types is also applicable to classes and a structure. We will go in detail what is reference type and what is reference type, but for now let's check the second point. It says structures are stored on stack, whereas classes are stored on the heap. So guys, let's first try to understand what is a heap and what is a stack. Okay, if you notice on this slide, I have example how data will get stored on a heap and how it will get stored on a stack. On the left hand side, you can see we have created two integers a and b, and they will get stored in this stack because these are value type. Again, the value types will get stored on a stack. The reference types will get stored on a heap. Okay, so we have two variables here, a and b, and if you notice, first a will get stored on the stack and then b will get stored on the stack. So whatever will come first, that will go first in the stack, and whatever comes later, that will come after that. So stack, we can say it's a kind of array in that we will store the elements as and when they will come. But in case of heap, it is not like that case. In case of heap, the memory is not organized sequentially. It can be stored anywhere, wherever we have the free memory. Okay, if you see the example here, we have created a string hello, and then we created a string ss equal to s. So what will happen? S variable will get stored on a stack. What S variable will hold? S variable will not hold the hello string, but it will store the memory location where we have the hello string in the heap. Okay, so S will have the value 5000. For this example, at 5000 location, so 5000 is nothing but a memory location. So at this location, we have this hello world string. So at this location, we have the hello string. And when we will say ss equal to s, so double s will also have the memory location 5000 in it. And that will also point to the same string on the heap. And this picture is taken from this particular blog. You can visit this website and understand the difference between a stack and a heap in very detail. So you can check out this blog from Pankaj Patel. And here the differences between this stack and a heap is explained very well and very technically. So if you want to check out this blog, I will add the URL in the description. Okay, let's go back to slides now. Okay, now we know how data gets stored on a heap and a stack. Let's now try to understand how a value type is different from a reference type. Value types hold their value in memory where they are declared, but reference types hold a reference to an object in the memory. If you remember from this slide, when we created this integer a and b, those will directly get stored. I mean, the values of those variable directly get stored on the stack, whereas for the reference type, only the memory location will be stored on the stack, but the actual data, the real data, will get stored on the heap in case of reference type. Value types are destroyed immediately after the scope is lost, whereas for the reference types, only the reference variable is destroyed after the scope is lost. The object is later destroyed by the garbage collector. We will talk about garbage collector in the future videos, but let's now go to Visual Studio and try to understand what is scope and how it will be different for value type and reference type. I have opened up my Visual Studio. So now let's create a variable integer I equal to 10. Now let's add a for loop. First now let's change the variable name because we already have I at line number 10. Let me call it A. A less than 5, A plus plus. Okay. Now let's create another variable J and let's call it 15. Okay. So if you notice here, the I variable is declared at line number 10. So the scope of this I variable will be from line number 8 to line number 17 because this is the block in which I was declared. But whereas J variable was declared inside the for loop. So the scope of J variable is limited from line number 12 to line number 15. If I try to access my J variable outside the for loop, you will notice we will get an error. If I try to set variable j to 10, you will notice we are getting the error. The name j does not exist in the current context because j is not there in this scope. Okay, let's say I have a different method, public void method a, and if I try to access my I variable here, I will get the same error again. Because I variable is local to this main method, the scope of I starts here where it is declared and it will get end at line number 17. So we won't be able to access I variable in any other method. But whereas if I have a variable at class level, let me call it int x equal to 100, this will be available in method main. Okay, for now let's create the variable statics so that we can access it in our static main method. So you can notice I can easily access my x variable and change the value of it. And if this is a static method, let me create it static again. And if I try to access my variable inside it, I will be able to access it because x is declared in the demo class. So at the class level, it will be available. So the point that we were trying to make, values types are destroyed immediately after the scope is lost, whereas for the reference types, only the reference variable is destroyed after the scope is lost. The object is later destroyed by the garbage collector. If you notice here, once we have executed main method, or once the execution comes out of the main method, the I variable will get destroyed. Okay, it will be done automatically by the .NET framework. Similarly, once the scope of J variable get ends, then the J variable will also get destroyed. So once we come out of the for loop, the J variable will be destroyed. But whereas in case of objects or the reference types, it will not happen like that. Let's say we have a class, public class customer. And if I create an object of my class,
customer equal to new customer, what will happen? The scope of this customer variable is in the main method. If I try to access the customer outside the main method, I won't be able to access it, right? Because you don't have customer in this context. Okay, once the scope of customer variable gets over, then the variable will get destroyed immediately, but the object that we have created, that will be destroyed by the garbage collector. It will not get destroyed immediately. If you see here, the object will get stored on the heap. So whatever data we have on this stack, that will be immediately destroyed once the scope is over. But in case of heap, it will be destroyed by the garbage collector. And we don't know, we can't tell when the garbage collector will be running. It will be automatically scheduled by the .NET framework. Okay, now let's try to understand the next difference. When you copy a structure into another structure, a new copy of that structure gets created. And the modification on the structure will not affect the values contained by the structure. Let's see this in Visual Studio. Okay, let's create a structure, public struct customer. Let's create two properties for it, name and address. Let's create an object for our structure, customer C1 equal to new customer. Let's assign some name to our customer. Let's call it Peter. C1 dot address, let's call it New York N1. Okay, let me create a second customer and instead of creating a new object of the structure, what I will do, I will point it to the C1 customer. So what I'm doing, I'm copying C1 object to C2. Now if I try to modify my object C2.name equal to, let me call it Parker. Okay, now let's try to print C1 and C2. So we are printing C1.name and C2.name. Let me run this program. You will notice we have the different values at C1 and C2. Even though we have copied C1 to C2, the modification that happened on C2 object are not reflecting on C1 object because customer is a structure. Now let's change this struct to a class. So I will remove the struct keyword and add the class keyword here. And if I run my program now, let's see what will happen. If you notice here, this time in C1 and C2, I'm getting the Parker. This is because now the customer C1 is a reference type. So let's go back to slide and understand this again. When you copy a structure into another structure, a new copy of structure gets created and modification on one structure will not affect values contained by the other structure. So when we said customer C2 equal to C1, that time a new copy was created. That's why the original object was not affected by the modification. Whereas in case of class, when you copy a class into another class, we only get a copy of the reference variable. Both the reference variable point to the same object on the heap. So the operation on one variable will affect the values contained by the other reference variable. If you remember this slide, when we created two string objects S and SS, that time when we copied value S to SS, both the variable were pointing to the same object on the heap. We did not create any new object or any new copy in that case.
Here are some other differences between a structure and a class. Structure cannot have destructors, but classes can have destructors because destructors are used to clean up the memory from the heap and structures don't get stored on the heap. So that's why we cannot create destructors in a struct. Let's go back to Visual Studio and see this. Okay, let me again change it to struct. So customer is a structure now. And if I try to create a destructor here, let's see what will happen. We will get the error message and let's read the error message. Only class types can contain destructors. Because customer is a structure type, so we are not allowed to create any destructor inside it. Okay, point number 8 is structures cannot have explicit parameterless constructor, whereas a class can. And this point is valid until C# version 6.0. After this version, we can create a parameterless constructor in structure also. So this point is not valid for newer version of C#. Whereas if I try to create a parameterless constructor within my structure, I have to initialize all the class fields which are available within the structure. Else it will say the name property is not assigned to some value and address is also not assigned to some value. So within this constructor, we have to assign some value to our property. Once we do this, we will notice the error is gone and we will be able to build this without any issues. So guys, from the version 6.0, we can create parameterless constructor in class and in structure also. But in case of structure, we have to initialize the class properties which are declared within the structure. Point number 9 is structure cannot inherit from another class, whereas a class can. Both structure and classes can inherit from an interface. So let's go back to Visual Studio and understand this. So let's create a structure, struct A and struct B. And if I try to inherit structure A here, I will get the error. Type A in interface list is not an interface. So a structure can only inherit from an interface, not from any structure or any other class. Let's say I have a class, public class X. And if I try to inherit the class X, I will get the same error again. X is not an interface. Now let's create an interface, public interface I. And if I try to inherit the interface, you will notice we are not getting any error. And if I try to build the application again, you will notice build is succeeded. But as we have already seen, a class can inherit from another class and they can inherit from an interface also. So just to demonstrate it again, if I have a class Y, it can inherit from class X, no issues, and it can inherit from interface I also. And again, a class cannot inherit a structure. If I try to inherit a structure, we will get the error Y cannot derived from seal type A. So guys, structures are called as seal type. We will understand the sealed keyword in a bit, but sealed means we cannot inherit that class or structure. Once we have declared anything as sealed, that cannot be inherited by anything else in C#. For an example, if I create my class X as seal type and I try to inherit it now, we will get the error. Y cannot derive from seal type X. So this is the purpose of sealed keyword, to make anything not inheritable. On point number 10, we can see some of the examples of structures that are used in .NET Framework. For example, integer is a structure and double is also a structure. Let's go back to Visual Studio and see this. If I create an variable integer I. And if I select this integer, press my control button and go to the definition of it, you will notice the int type is a structure. A class or a structure cannot inherit from another structure, and structures are seal type that we have just seen. And second point is a very important interview question that you might be asked. How do you prevent a class from being inherited, or what is the significance of sealed keyword? That we have seen in this video. If we create any class with the sealed keyword, that class cannot be inherited. So this is the significance of sealed keyword. Okay, that's it for this video guys. In the next video, we will learn about interface in C Sharp. Hello and welcome to the part 31 of this video series. In this video, we will learn about interface. As part of this video session, you will learn the basics about interface, and we will also understand the changes that are introduced in C Sharp version 8.0. So let's open up the Visual Studio and get started. To create an interface, we have to use the keyword interface. What I have to do, I have to type public interface and let me call it I customer. Okay, so similar to a class, we can create interface also. And instead of using the class keyword, I am using interface keyword. And within my interface, I can create or I can define the contract of it. So let's say for a customer, we will have a method void print customer name. And we will have a method print customer bill. Okay, for now, let's keep these two methods in our interface. If you notice, I have only provided the declaration or the signature of the method. I have not provided the implementation. So now let's see how the interface will be used. Let's say we are creating a customer class, public class customer. And now what we can do, we can inherit the iCustomer interface. So let's put the colon here and say iCustomer. So now our class is implementing iCustomer interface. But if you notice, we are getting an error message here. Customer does not implement interface member iCustomer.print customer name and print customer bill. Because we have added these two declaration or the contract in our interface, then it is mandatory for the class to provide the definition of those members. If we don't provide the definition, compiler will give us the compilation error. So what we can do, we can go here and click on this button and we can click implement interface. Once you click on that, you will notice Visual Studio will add the definition of both the methods, print customer bill and print customer name. Now what we can do, we can provide our implementation in this class. So let's remove these lines and add some properties to our class. Okay, so I have two properties, name and bill amount. Now let's write the code to print the bill amount for the customer. Okay, so I have added the code to print the bill amount and the customer name. Now let's go ahead and use the customer class and create object of it. So I will say customer C1 equal to new customer. Let's assign some name to our customer. Customer name equal to Mark. And let's say bill amount for our customer is 1000. Okay. Now I can use my methods print customer bill and print customer name to print the name and the bill amount. Let's invoke c1 dot print customer name, c1 dot print customer bill. Let's run the program. You will notice we are getting the customer name is Mark and bill amount is 1000. So guys, this is how you can create an interface and use it in your class. Let's go back to slides. So this is the official definition of interface. It says an interface defines a contract. Any class, record, or structure that implements that contract must provide an implementation of the members defined in the interface. If you see in the Visual Studio, we have declared these two methods within our interface. And that's why for our customer class, it is mandatory to create these two methods. If we don't create these two methods in our class, that will give us the compilation error. Let's say in future, someone tries to create a new class, public class. Let's say gold customer, and they try to implement the iCustomer interface. You will notice they will get this error saying this class does not implement print customer name and print customer bill. So if any class is implementing iCustomer interface, they have to provide the definition of all the members which are available in the interface. Okay, interfaces act as a contract between different components of a system, allowing developers to break down their code into modular components and easily maintain and update them. Here are some points about interface. Before Shisha version 8.0 was introduced, we create interfaces using interface keyword. Just like classes, interfaces also contain properties, methods, delegates, or events, but they will only have the declaration, they cannot have implementation. This point is not valid after introduction of version 8.0. We will understand this in a while. The second point is it is a compile time error to provide the implementation for any interface member. Interface members are public by default and they don't allow any explicit access modifiers. Let's understand this in Visual Studio. Okay, so if I try to provide any modifier here, let me try to create it protected. You will notice we are not getting any error because in this application we are using C# version 10. That's why we are able to use access modifiers. If you remember when we created this project, we have used the version 6.0 of .NET. If I right click on my project and go to properties, I can see we are using the target framework 6.0. So based on this version only, the C# version will be defined. You can refer to this table to find out which C# version will be the default version for you. Because we are using the version 6.0, the default C# language version for this one is version 10. So let's create an application using a classic .NET framework so that we can use C# version 7. Let's open up a new window for our Visual Studio. Click on create a new project. And this time, instead of creating a .NET Core application, I will create a .NET Framework application. I will select this particular template that says console app .NET Framework. I will select this one and click on next. And I will keep the version 4.5 and I will create it. Okay, so now let's try to create an interface here. Public interface iCustomer. Okay, and now add some members to our interface. Void print name. Okay,
So currently we have not given any access modifier to our print name method. So let's try to give a access modifier to it. If I put public here, you will notice we have started getting an error message here. Let's read it out. The access modifier public is not valid for this item in version 7.3. Please use language version 8.0 or greater. So if you want to give access modifier to our interface member, we have to use a C# version 8.0 or greater than that. But because in this application, the C# version is 7.3, that's why we are not allowed to put any access modifier in our interface. Similarly, I cannot provide private. This will give me the same error again, and I won't be able to give protected also. I will again get the same error. Okay, so that's what was mentioned on the point number 3. Interface members are public by default and they don't allow any explicit access modifiers. Interfaces cannot contain fields. We have this interface iCustomer. Let's try to create field here. String name. You will notice we are getting the error message. Interfaces cannot contain instance fields. So guys, we are not allowed to create fields inside an interface. Next point is, if a class or a structure inherits from an interface, it must provide implementation for all the interface members. Otherwise, we will get a compilation error. That we have already seen. A class or a structure can inherit from more than one interface at the same time, but whereas a class cannot inherit from more than one class at the same time. So in Visual Studio, let me try to create one more interface. Public interface I new customer. What I can do, I can implement this interface also. I new customer, and it is allowed because a class can inherit more than one customer. If I have a member in my new interface, let's say print new name, okay, so I'm getting an error message here because I have implemented I new customer interface, but I have not provided the definition of print new name. So let's go ahead and provide the implementation for it. Okay, I have added the implementation for print new name, and now if you notice, the error is gone and we are able to successfully build the application. Build one succeeded. Okay, and to prove that we cannot inherit more than one class, let's create one more class here. Public class A, public class B, and public class C. So C class can inherit class A, that's not a problem. But if I try to inherit one more class, we will get the error message. Class C cannot have multiple base classes A and B. So a class can only have one base class. Whereas we can implement as many interfaces we want in C#. That's why we can say we can achieve multiple inheritance by using interfaces. 7 point says interface can inherit from other interfaces. A class that inherits this interface must provide implementation for all the interface members in the entire interface chain. Okay. So let's say I have this iCustomer, and let me create one more interface, public interface iCustomer 2, and I will add a member print customers to name. Okay,
So what I can do, I can make my iCustomer interface to inherit iCustomer2. Let's see what will happen when we do it. Okay, we are not getting any error message here. So we can implement this interface without any issues. But if you notice, the customer class is now giving us the error because we are implementing iCustomer, which is implementing iCustomer2. Now it is mandatory to implement the members which are available in iCustomer2 also, because indirectly we are inheriting iCustomer2 in customer class. If you read the message here, customer does not implement interface member print customer2 name. So now it is mandatory for customer class to provide the implementation. So let's provide the implementation. Once the implementation is provided, you will notice the error is gone and we are again able to build our application without any issues. Next point is we cannot create an instance of an interface, but an interface reference variable can point to a derived class object. What does it mean? Let's understand this in Visual Studio. So the point that we are trying to make here, we cannot create instance of an interface. If I try to say iCustomer C2 equal to new iCustomer, this is not allowed because we cannot create instance of an interface. And it makes sense also. What if someone tries to call C2 dot print customer name? At this line, which print method will be invoked? Because we don't have any implementation of print customer name in iCustomer interface. That's why we are not allowed to create objects of interfaces. So let me remove it. But what we can do, we can store an object of customer class to a reference variable of iCustomer type. Currently, we have created C2 of iCustomer type and we are able to store iCustomer object within it. It is possible because of polymorphism. Because customer class is inheriting iCustomer, that's why we are able to store new customer object in an iCustomer reference variable. Okay, now let's understand the features that are introduced in C# version 8.0 related to interface. First one is default interface methods. What we can do in our new interfaces, we can provide a default implementation for the method. Let's go back to Visual Studio and understand this. Let's first go to our application that is built in version 4.5. And so that is the application that is using version 4.5 of .NET that we can verify by going to the properties of my project. I can see the target framework is 4.5. Okay. So in this interface, if I try to provide the definition of a method, I will get the error message. It will say feature default interface implementation is not available in C# version 7.3. Please use version language 8.0 or greater. Target runtime does not support default interface implementation. So guys, providing implementation in an interface is only possible from version 8.0. So let's go back to our original application that is using version 10. In this interface, if I try to create an implementation, let's say I will provide the implementation of print customer name within the interface. I can provide it like that. I can say CW default customer name. Okay. Now I have added the definition or the implementation of print customer name method in iCustomer interface. Let's remove these interfaces for now. Now what I can do, because we have the default implementation in iCustomer interface, I can safely remove the implementation from my customer class. If I remove this method, You will notice we are not getting any error message. Let's remove this code also for now. And if we try to build the application, you will notice one build succeeded. So now if we try to invoke print customer name method, that will be invoked from the interface. Let's try to create an object of customer class, and let's try to invoke customer dot print customer name. You can see we are getting the error message. It says customer does not contain definition of print customer name because the customer name method is available in interface. That's why we cannot access it directly using the customer type reference. For that, we have to create an iCustomer reference, and now we can invoke the method that is available in interface. You can see we are getting default customer name. It is coming from the default method implementation that we have provided in our interface. Okay, second new feature that was introduced for interface in version 8.0 is access modifiers. If you remember, in our application that is using version 4.5 of .NET, we are not allowed to provide any type of access modifier. If I say public here, you will notice you will get the error message. But if you go to our new application, in this interface, I am allowed to provide any access modifier. I can provide public, I can provide private, or I can provide protected also. So all three access modifiers are possible to provide in interface after version 8.0. Next thing is static members. We can now provide static members in our interface. Again, if I go to my old application that is using version 4.5 of .NET, and I try to create a static method, static void print name 2, you will notice you will get the error message. You can read the error message. The modify static is not valid for this item in version 7.3. Please use language version 8.0. So let's go back to our new application and try to create a static member here. Static void print full name. Right? We can provide it here, but you will notice we are getting the error message here. Let's read it. Print full name must declare a body because it is marked as abstract, extern, or partial. Because we have marked our print full name as static, we have to provide the body of this method. Once the body is added, you will notice the error message is gone. And let's provide some definition. Okay. Now to invoke this particular method, what we can do, we can directly use iCustomer and we can call print full name. And we can get the message print full name from static method. So this is how you can create static methods in an interface and invoke it using the interface name itself. Just like static methods, we can have static properties also within our interface. You will notice I have created a new property with the name my property and I have marked it as static. And you can see we are not receiving any compilation errors. So guys, it is allowed to create static properties in an interface. So just like a static property, we can add a static field also. Static string underscore name. You will notice we are not getting any compilation error
but we are not allowed to create any non-static field in an interface. If I try to create string underscore age, we will get the error message. Interface cannot contain instance field. That's it for this video, guys. In the next video, we will learn about interface implementation. Hello and welcome to part 32 of this video series. In this video, we will understand about interface implementation. As part of this video, we will do a short recap of interface implementation that we have seen in last video, and we will also understand what is explicit implementation of interface. So let's open up the Visual Studio and get started. I have opened up my Visual Studio. Let's create an interface. So I have created an interface iEmployee. And guys, this is a very common convention to start an interface name with a capital I. If you don't give this capital I, that is also fine. Compiler will not give us any error. If I try to build it, you will see build succeeds. But again, it is common standard or best practice to provide capital I in front of interface name, so that whenever we use interface in anywhere in our code, we can easily tell this is an interface and not a class. So let's add a method signature in our interface. So I have added a member in my interface. That is a method, and it will not return anything. That's why I have specified the type void, and this will take one parameter string name. So let's try to implement this interface in a class public. So currently I have created a class and I have implemented iEmployee interface. And if you notice, we are getting a compilation error that says employee does not implement interface member print name. So let's implement the method also. To implement a method, you can click on this button and select implement interface. Once you click on that, C# will automatically implement the method. So let's remove this line of code and print the employee name inside it. Okay, now the error is gone. And this all we have already seen in last video. But guys, remember, whenever we are implementing an interface, we have to follow the signature which is available in the interface. In this case, the print name method is expecting a string name parameter. That's why in our class also we have to define the print name method with string name parameter. What will happen if I try to implement a method with some different signature? Public void print name, and this time instead of taking just name, I will take string name and string last name. And if I comment out this earlier method, you will notice we will again get the compilation error. It will again say employee does not implement the interface member print name. So guys, it is important to follow the signature that is provided in the interface. If you don't provide the same signature which is available in the interface, we will get the compilation error. And again, we have to match the return type also. Suppose in this method, I have matched the parameter, like in the interface, we have the string name, and in class also I have string name, but let me change the return type from void to string. If you notice, we are again getting the compilation error. Employee does not implement the print name method. And if you read the complete message, it will also say because it does not have the matching return type of void. So we have to match the return type also when we are implementing an interface method. Okay, let's remove it and uncomment this line of code. Okay, now you will notice the error message is gone and we are able to build the project successfully. So this was the recap of interface implementation. Now let's understand what is explicit implementation. Let's suppose I have two interfaces. One is iEmployee, and let me create public interface I person, and it has the same method as iEmployee. So now let's say our employee class is implementing iEmployee as well as iPerson. Now if you notice, our class is implementing two interfaces, and these two interface has two methods, print name at line number 20 and print name at line number 25. But in our class, we are only implementing one method. And still, if you try to build the application, you will see there are no compilation errors and build is succeeded. You can see the message here, no issues found. To implement both the methods from the iEmployee and iPerson interfaces, we have to use explicit implementation. Let's see how we can achieve it. So let me remove this piece of code from here for now. Now I will get the error message saying we are not implementing the interface. So let's try to implement using the explicit implementation. I will right click on it and this time I will select implement all members explicitly. So this will inject the method for me and let me implement the iPerson also. Okay, if you notice now we have two methods and both are implemented explicitly. Now we are implementing both the methods from interfaces. This one is from iEmployee interface and this one is from iPerson interface. And if you notice the syntax here, we are using the interface name dot method name and then the parameters. Same way we are using it here. So I have provided the implementation and I am just printing a simple console line using the console.writeLine method. So let's go ahead and invoke these methods in our main method. So let's first create an object of employee class, employee e equal to new employee. And if I try to invoke the methods e dot print name, I will pass the name as Peter. You will notice we are getting the compilation error. That is because we have created an employee type reference and we are trying to invoke the print name method on that. But actually in employee class, we don't have any print name method that belongs to employee class. We have the print name method which are from iEmployee interface and iPerson interface. So if I have to invoke these two methods, I have to create the object using the iEmployee or iPerson reference. So let me create first with the iEmployee reference. And again, I can store an object of employee class in an iEmployee type reference because of polymorphism. Now if I try to invoke my method print name, you will see we are not getting any compilation error. Let's create an object for our iPerson interface also. And I can invoke e2.print name. And I have to pass some name here, pass mark here. And if we run the program, we can see we are able to invoke both the methods name from iEmployee and name from iPerson interface. So guys, this is how you can achieve the explicit implementation of interface. In case you are having two interfaces and the method present in the interfaces having the same signature and the same return type. This is one way of invoking the print name method. Let me show you a second method. In that we can use the typecasting and invoke it. Okay, I have commented out the above code. Let's create an object of employee class. And now let's typecast this employee name to iEmployee interface. So I will use the employee reference and provide iEmployee here to typecast it. And once it is typecasted, then I can invoke print name method and I can pass some name. Dummy name 1. Similarly, I can typecast it to iPerson interface and I can pass the name as dummy name 2. And if I run the program, you will notice we are successfully able to invoke the methods from interface iEmployee and iPerson. Let's go back to slides. So this is one of the most important interview question that you might be asked for the interfaces. Let's read out the question. A class inherits from two interfaces and both the interfaces have same method name. How should the class implement the methods for the both the interfaces? This is the same example that we have seen in this demo where we have seen the two interfaces I employee and I person, and both of these interfaces were having the same method, that is print name, and we have to use the explicit implementation of interface to invoke the methods or to implement the methods from both the interface. Please note, when the class explicitly implements an interface, the interface member can no longer be accessed via class reference variable, but only via the interface reference variable. Let me show you again. So when we are creating the employee object using the employee reference, we cannot invoke the print name method directly. You will notice we are not getting the option of print name method here. But if I create the object using the reference of I employee or I person, I will be able to invoke it. Let me uncomment this code. If I create the object and store the object reference in an I employee type reference, then I can easily invoke print name method. That's what this point says. The interface member can no longer be accessed via the class reference variable, but only via the interface reference variable. And one more thing, access modifiers are not allowed on explicitly implemented interface members. Let's understand this in Visual Studio. Okay, so I have implemented the interfaces here, and if you notice, I have not given any access modifiers, meaning I have not provided public, private, or protected keyword here. Let me try to put an access modifier. Let me say public. You will notice we are getting the error message here. Let's read the error message. It says the public modifier is not valid for this item. So guys, we cannot provide access modifiers when we are implementing the interfaces explicitly. That's it for this video guys. In the next video, we will learn about abstract classes. Hello and welcome to part 33 of this video series. In this video, we will learn about abstract class. Data abstraction is a process of hiding certain details and showing only essential information to the user. What does it mean? What do we mean by hiding certain details and showing only essential details to the user? Data abstraction defined as the process of identifying only the required characteristics of an object and ignoring the irrelevant details. Let's understand this with a real life example. Consider an ATM machine. When the user visits an ATM machine, the user only knows that in ATM machine, first we have to enter our ATM card, then we need to enter our PIN code, and then we need to enter the amount that we want to withdraw, and at the last we have to collect the money. Here the user does not know about the inner mechanism of the ATM or the implementation of withdrawing money, like how the ATM will connect to the bank server, how it will make the withdrawal, and how it will update the balance once the withdrawal is done. The user just simply knows how to operate the ATM machine. This is called abstraction. We are hiding the complexity, or we are hiding the certain details from the user and showing only the essential information that the user needs. In C Sharp, we can use abstract keyword to create classes and methods. Let's first see the abstract class. It is a restricted class that cannot be used to create objects. To access it, it must be inherited from another class. And an abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the derived class. Let's go to Visual Studio and understand the concept of abstract class and abstract methods. I have opened up my Visual Studio. Now let's try to create an abstract class. To create an abstract class, we need to use the abstract keyword public abstract class, and let's call it employee base. Okay, so we have created our first abstract class. So there are some features of abstract class. Let's first try to understand what are those features. First of all, you cannot create an object of abstract class. If I try to create an object,
employee base equal to new employee base, we will get the compilation error. And if you read the error message, it will say cannot create an instance of the abstract type employee base. So we are not allowed to create objects of abstract class because abstract class is only meant for inheritance. It cannot be directly used in our program. Let's try to create an class and inherit our abstract class in that. Now what I can do, instead of creating the employee base object, I can create my part-time employee object, and this is allowed because part-time employee is inheriting employee base class. So we can say employee base equal to employee. So basically we are creating an variable of employee base type and storing an part-time employee object in that. And guys, again, it is allowed because of polymorphism. Okay, so this is the first characteristic of abstract class. We cannot create objects of it. Okay, class cannot be initiated. Second one, an abstract class can only be used as base class. That we have seen, we have used the abstract class as our parent class in our part-time employee class. An abstract class cannot be sealed. If you remember from last video, we have seen the keyword sealed. If a class is marked as sealed, that cannot be inherited. Let's try to mark this class as sealed. If you notice, we are getting the error already. It will say an abstract type cannot be sealed or static because our class is meant for inheritance. We cannot mark our class as sealed, so it is not allowed. An abstract class may contain abstract members like methods, properties, indexers, events, but not mandatory. In abstract class, we can have abstract members, but we can also have non-abstract members also. So in this class, in my abstract employee base class, I can create my abstract method, print name. Okay, so it is allowed. But if you notice, we are getting an error message here. We have inherited employee base class, which is having an abstract method, print name. And abstract method is nothing but a declaration. It is not a complete method. It is responsibility of the child classes to provide the implementation of abstract methods. If you read the message here, it says part-time employee does not implement inherited abstract member print name method. So just like an interface, we have to provide the definition of print name method also. So let's create a method public void. So I have added a method print name, but if you notice, we are still getting the error because we have to use the override keyword. So this is the one difference between interface and abstract class. Whenever we are implementing methods from an interface, we don't provide the override keyword, but in case of abstract class, we have to provide the override keyword. So this is how I can create an abstract method and implement that method in child class. And our abstract class can also have methods that are not abstract. Let me try to create a normal method. If you notice, it is allowed. It is not giving us any compilation error. And we can have our non-abstract members also in a class. But what will happen if I try to create an abstract method in a class that is not abstract? It is not allowed. If I try to create public abstract void method 1, you will notice we are getting their message. It will say cannot declare a body because it is marked abstract. And also method 1 is abstract, but it is contained in a non-abstract type, so it is not allowed. We can only have abstract members in an abstract class. Fifth point is an abstract class can have both abstract and regular members. That also we have seen. A non-abstract class derived from an abstract class must provide implementation of all the inherited abstract member. That also we have seen in this video. If you again notice here, we have this print name method as abstract, and C# compiler will force us to implement that method in our base class if we are inheriting employee base class. Okay, now let's try to understand in detail what will happen when we are inheriting an abstract class. So, if a class inherits an abstract class, there are two options. Option 1, we have to provide the implementation for all the abstract members inherited from the base abstract class. Okay, so this is the first option. If you notice in Visual Studio, we had this one abstract method and we have to provide the implementation of that one abstract method in our child class. So this was option 1. Second option, if the class does not wish to provide implementation for all the abstract members inherited from the abstract class, then the class has to be marked as abstract. What does it mean? If I don't provide the implementation of printName method, what is the other option I have? I can mark this particular class as abstract. Okay. So one abstract class can inherit other abstract class. So this is the option 2. Now let's try to understand in detail what is an abstract method. An abstract method is a method without a body. If you remember from past videos, if a method is marked as virtual, that can be overridden by the child classes. That is what happening here. The method abstract print name is a virtual method and we are not using the virtual keyword here, but at the backend, C# will mark it as virtual. That's why we are allowed to inherit the abstract class, and when we are implementing this method, we have to use the override keyword. This is the print name method, and when I am implementing it, I have to provide the override keyword because print name method is by default a virtual method. The implementation of an abstract method is done by the derived class that we have already seen. When the derived class inherits the abstract method from the abstract class, it must override the abstract method. This requirement is enforced at compile time, and it is also called as dynamic polymorphism that we have already seen in this video. C# compiler will enforce us to implement the abstract methods in the child class. And guys, if you notice here, the abstract classes and interfaces will look pretty much similar, but there are a lot of differences between an abstract class and an interface that we will understand in the next video. Welcome to the part 34 of this video series. In this video, we will learn about difference between abstract class and an interface. If you remember in the last video, we have learned about abstract classes. Let's continue our discussion from there and understand how we can use abstract classes in our program. If you remember from the past video, we have created an abstract class with name employee base, and I have created an abstract method print name within it. For now, let's remove all the code that is available here and let's keep only the print name method here. Okay, so I have used employee base as my base class in my part-time employee class, and let's provide some definition to this method. So I have implemented the print name method. Now let's go to our main method and try to invoke print name method. I have created an object of part-time employee and I've used the employee base type variable, and I can say employee dot print name. And if we run the program, we are getting the message as expected. Now let's create one non-abstract method in our employee base class. Okay, so I have added a non-abstract method in my employee base class, and let's try to invoke this particular method in our main method. So I can simply say employee dot print age. And we're getting the message is from abstract class.
So this is how you can invoke abstract or non-abstract method. So we have just seen how we can use abstract class. And now let's first try to understand what are the similarities between an abstract class and a interface. So both interfaces and abstract classes are used as base to create other classes. If you see in Visual Studio, we have created employee base class and we have used this class to create part-time employee class. So using this class, basically the employee base class will provide a kind of blueprint or a structure for our class so that we can easily implement the methods which we should be implementing in part-time employee. So both interfaces and abstract classes can be used to create other classes. And we cannot initiate abstract classes and interfaces also. If we try to create an object of interface or abstract class, that will give us compilation error. Both contain set of methods that are defined and must be declared in the implementation. So just like we did in interface, we had to implement the methods which are available in the interface. In abstract class also, we have to implement all the abstract methods that are available in the abstract class. Now let's see some of the differences between abstract class and interface. Abstract class contains both declaration and implementation parts. So it is possible in an abstract class to have non-abstract method and abstract method also. So that's why we can have declaration and implementation in abstract classes. In interface, we can only have declaration of methods, properties, events, and indexer. But again, as part of C Sharp 8, we can also have default implementation that can be used in interface. With the abstract class, we cannot achieve multiple inheritance because we can inherit only one class at a time in C Sharp. But in case of interface, we can achieve the multiple inheritance. In C Sharp, we can inherit multiple interfaces at a time. An abstract class can contain constructors, whereas we cannot have any constructor in an interface. Abstract class can contain static members. In interface, we cannot have it, but in C Sharp version 8, it is allowed to create static members in interface. Abstract class can contain different type of access modifiers like public, private, protected. But in case of interface, if you are using a version which is less than version 8, in that version you cannot use public access modifier because everything in interface is public by default. But again, in newer version of C Sharp, it is allowed to have any access modifier in interface also. Abstract class is used to implement the core identity of a class, whereas interface is used to implement peripheral abilities of class. What we mean by it? When we create an abstract class, it means we are creating an identity of a class, meaning when we declare an employee based class, we can have the functionality that will be common for all type of employees. But in case of interface, we can add the behavior that can be used by any type of class. If many implementation are of same kind and use common behavior, then it is better to use abstract class. If many implementation can share methods, then it is better to use interface. If you have multiple set of classes, like in our example, we had part-time employee, full-time employee, and there will be some common behavior that will be common across these employees. That common behavior can be moved to an abstract class as a non-abstract method. So this is a perfect use case for an abstract class. And please notice the difference between an abstract class and interface is one of the most important question that is asked in interviews. Okay, let's try to understand in detail when to use abstract class and when to use interface. As a general rule, you should use an abstract class when creating a base class that needs to be inherited by other classes in a class hierarchy. If you need to define a behavior that can be implemented by multiple unrelated classes, you should use an interface. So basically, if you have multiple related classes, again, in our example, we had permanent employee, part-time employee, contractual employee. That time you can use
abstract class because all those classes are related and there will be lot of common behavior that we can move to our base class, that is employee base class. But suppose you have classes something like circle, rectangle and triangle, and let's see an example of area method. The area calculation of circle will have different implementation. For rectangle, we have different implementation, and triangle, we will have different implementation. So for this kind of scenario, we can go with an interface. That's it for this video, guys. In the next video, we will understand the problem with multiple inheritance in C Sharp. Hello and welcome to part 35 of this video series. In this video, we will learn about multiple inheritance and we will see why it is not possible in C Sharp. So let's try to understand the multiple inheritance problem with an example. Let's say we have four classes, class A, B, C and D, and class B and C are inheriting from class A. So whatever is available in class A will be available to class B. So whatever is available in class A will be available to class C also, because both are inheriting class A. So that is fine. We can inherit one class in C Sharp without an issue. But the issue will come when we create a class D and try to inherit from both B and C classes. Now let's see what will happen if we have a virtual method in class A. Okay, and that virtual method is overridden by class B and C. Now, because class D is inheriting from B and C, that virtual method will be available from both the classes. Now, if we try to invoke that method using an object of class D, there will be an ambiguity. Means compiler will not know from which class we should be invoking the method. This ambiguity is called as diamond problem. Because of the shape, we call this as diamond problem. Now let's go to Visual Studio and understand this with help of an example. Okay, I have opened up my Visual Studio. Now let's try to create those four classes. Okay, so I have created these four classes A, B, C and D. Now if you look at the slides, class A was inherited by class B and C. Now let's do the same in Visual Studio also. I will inherit class A and I will again inherit class A. So class B and C are inheriting from class A. That's fine because in C Sharp we can inherit a class without any issues. Issue will come if we try to inherit multiple classes. If I say B, comma C, means I am trying to inherit both B and C, we will get the error message. If you open up the error message, you will get class D cannot have multiple base classes B and C. So in C Sharp, one class can have only one base class. Now let's see what will happen if we have a method, virtual method, and this virtual method is overridden by class B and C. So I have used the override keyword to override the method which is available in class A. So now what will happen if I try to create an object of T class and try to invoke the print method? Let's try to do it. D equal to new object. Okay. Now if I say D dot print, now we will have the ambiguity because D class is inheriting from B and C and print method is available in both class C and class B. So C Sharp compiler will not know from where we should be invoking the print method. This ambiguity is known as multiple inheritance problem or diamond problem. That's it for this video, guys. In this video, we have seen why it is not possible to have multiple inheritance using classes. But in the next video, we will understand how we can implement multiple inheritance using interfaces in C Sharp. Hello and welcome to part 36 of this video series. In the last video, we have seen why multiple inheritance is not possible using classes. And in this video, we will learn how we can implement multiple inheritance using interfaces. So let's understand this with the help of an example. Let's first create an interface. I have created an interface iPerson and that is having a print method print age. Okay, let's create one more interface. And this will have a method signature print salary. Okay. Now let's create a class person and now let's implement iPerson interface. And now let's implement the method print age from iPerson interface. Now let's create one more class. Let me call it part-time employee, or let's just call it employee for now. I will implement the iEmployee interface in this case. And let me implement print salary method in this case because iEmployee interface has print salary in it. So I have two interfaces, iPerson and iEmployee. I have created two classes, person and employee, and person class is implementing iPerson interface and employee class is implementing iEmployee interface. Now let's say we have a class. Okay, if you look at this class, a part-time employee is a person and a part-time employee is an employee also. So what we can do, let's try to implement employee and person class because we want the behavior from both the classes person and employee. So we are trying to inherit both the classes employee and person, but it is not allowed in C#. We can inherit only one class at a time. So to overcome this problem, what we can do, instead of inheriting the classes, we can inherit the interfaces. So let me change it to iEmployee and iPerson. And now what I can do, I can implement the interfaces which are available in the iEmployee, and then I can implement whatever is available in iPerson. So I have two methods, print age and print salary. Now I don't have to provide the implementation of these two methods because these implementations are already available in person and employee class. So what I can just do, I can create objects of those classes. Person P equal to new person and employee E equal to new employee. And I can simply invoke the methods which are available in these classes. So I will call print age in my print age method. And similarly, I can call print salary in my print salary method. So this is how I can implement two interfaces. So effectively what we have done, we have introduced the behavior of person and employee within our part-time employee without inheriting the classes directly. So this is how you can implement multiple inheritance using interfaces. Now let's try to create an object of part-time employee and try to invoke these methods and see if these are working as expected. So coming back to my main method, I will create an object of part-time employee. PTE equal to new part-time employee and I can invoke print salary and I can also invoke print age. And if you try to build the application now, you will notice build succeeds and we are able to invoke both of these methods. Let's run the application. We are getting salary and age as expected. So guys, this is how you can implement multiple inheritance in C# using interfaces. That's it for this video guys. In the next video, we will learn about delegates. Hello and welcome to part 37 of this video series. In this video, we will learn about delegates. Delegates is one of the most complicated concepts in C#, but don't worry, in this video series, we will learn about delegates in very details. We will start with basics of delegates in this video, and in the next video, we will learn how we can use delegates in some real-time examples. So let's start this video and understand the basic concepts around delegates. I have opened up my Visual Studio, and now let's start with how we can create a delegate. To create a delegate, we need to use the delegate keyword. So we'll start with the access modifier, public. We will use the delegate keyword, delegate. Now we need to specify the return type of the delegate. And now give this delegate a name. For the demo purpose, I am giving it hello message. And this will take one parameter of string type. That's it. So this is how you can create a delegate. If you notice here, a delegate looks like a method signature because this will have a return type, and in this we can mention the parameters that the delegate will expect. Let's go back to slides now. The definition of delegates is that delegate is a type safe function pointer because it holds a reference to a function. So basically delegate will point to a method. We will understand this in a bit. The signature of the delegate must match the signature of the function the delegate points to. So whatever function that delegates will point, the signature should be same in delegate and the function. Otherwise, we will get the compilation error. I will show you in the Visual Studio in some time. This is the reason delegates are called as type safe function pointer. So let's go back to Visual Studio. Now let's create a method that will have the similar signature as our delegate. Public. String n, and this will just print the message which we are getting like that, hello. So this method will take the parameter string n and it will print the string hello n. And if you notice here, the syntax or the signature of the method which I have given here is same as what we have for the delegate. I have void as return type, and then I have the function name, and here I have the delegate name, and after that I have specified the parameter, and in both cases I have a string type parameter. Okay, now let's try to understand how we can use this hello message delegate to invoke the hello method. To use the delegate, first we have to initialize the delegate. So I will say hello message hm equal to new hello message. And within the parameter, if you notice, it is expecting a method. So we need to provide a method whose return type is void and it is taking one string type parameter. And we have that method as hello. So I will provide the hello message in this. Okay. So now our delegate is ready to execute. Now to execute the delegate, we have to simply say delegate name and then just pass the parameter that you want to pass to the delegate. So currently I am passing the world string to my method, and I am not directly invoking the hello method. I am going via the delegate. So basically what will happen when I run the program, the delegate will get initialized and it will see, and then it will invoke the method which is passed to it. So now let's run the program and see what will happen. You will notice we are getting the message hello world. So guys, this is how you can create the delegate and make the delegate to point to a function, and then you can invoke that function using this syntax. Now let's say my method is expecting two parameters, string n and string m. So now I have two parameters, string n and m. And if you notice here, we are already getting the compilation error. Let's read the message. It says no overload for hello matches the delegate hello message. So basically we have to match the signature of method with the signature of delegate. Else we want to be able to invoke the method. Let's go back to slides now. So we have seen why the delegates are called type safe. A delegate is similar to a class. You can create an instance of it, and when you do so, you pass in the function name as the parameter. We have seen in the Visual Studio, we have passed down the hello method in our delegate. And it is to this function the delegate will point to. So whatever function we are adding to the delegate constructor, basically that function the delegate will point. And one more thing to notice here, we have to match the return type also. Not only the parameters, we have to make sure the return type of method and delegates are same. So for now, let's remove this parameter. Now the compilation error is gone, but now let's change the return type from void to string. Okay. So I have changed the return type of my hello method. Now, if you notice, we are again getting the compilation error. Let's read the error message. String demo hello, meaning the hello method has the wrong return type. So guys, we have to match the return type as well as the parameter of delegate and the method. So this is the syntax that we need to use when initializing the delegate. First, we have to use the delegate name. After that, we have to give the instance name, and then we need to use the new keyword, and then we again need to use the delegate name, and within the parentheses we need to pass down the method that the delegate will point. If you go back to Visual Studio and let's change the return type back to void so that we don't get the compilation error, you will notice this is the syntax which we just discussed. Delegate name, then the reference variable name or the instance name, then the new keyword, then again the delegate name, and within the parentheses we have passed down the method name hello. So guys, that's it for this video. In the next video we will learn about how we can use delegates in some real-time examples. Hello and welcome to part 38 of this video series. In this video we will see how we can use delegates. In the last video we have seen what are delegates and why we call delegates as type safe, and we have learned how to create delegates and how to initialize delegates and invoke methods using delegates. In this video we will continue our discussion on delegates and we will see how delegates can help us in C# programming. So let's open up the Visual Studio and understand this with help of an example. Okay, I have opened up my Visual Studio. Now to understand the delegates, let's create a class. So I have created a class employee that has four properties: ID, name, salary, and experience. Now we want to create a method that will loop through list of employees and check their experience. And if the employee is eligible for promotion, we will print the employee is promoted. Okay, so let's create it. Okay, so I have added a method promote employee and I am looping through the list of employees and I am checking if the employee's experience is greater than or equal to 10, then I am printing the employee name is now promoted. Okay, let's go ahead and try to use this class in our code. I have created a list of employee and I have created four employee objects E1, E2, E3 and E4, and I have assigned name, salary and experience to these employees, and I have added these four employees in my employee list using the .add method. Now let's go ahead and invoke the promote employee method so that we can promote the eligible employees. Because promote employee is a static method, so we can use the class name and directly invoke promote employee and pass down our list of employees object. Okay, now let's run the application. If you notice, we are getting Mark is now promoted and John is now promoted, because if you see, Mark has experience of 10 years and John has experience of 18 years. That's why this condition will become true and we will print this message employee is now promoted. But the issue with this code is we are tight coupling the logic to promote the employee. Let's suppose we have a different company that has different logic to promote the employee. Maybe they will check their salary and experience also, and then only they will promote the employee. So it's not a good idea to hardcode the logic in the employee class to promote the employee. To make this code more flexible, what we can do, we can make use of delegates. Let's see how we can use delegates and remove this hard-coded logic of experience greater than or equal to 10 using delegates. First, let's now create a delegate, public delegate, and this will return a boolean. Let me call it is eligible. It will take an employee object. Okay, so this is my delegate that will return a boolean. Okay, now let's create a method that will return a boolean and takes the employee object, and within that method we will implement the logic to check if the employee is eligible or not. Okay, I have created this method is promotable, and as our delegate it is having the return type boolean and it is expecting an employee object as the parameter. And inside this method I am checking if the employee is having experience greater than 15, then it will return true, else it will return false. Now let's see how we can make use of is promotable method. So at this line, what we want to do, we want to remove this hard-coded logic and invoke the delegate and check the condition based on the delegate result. So at this line, I will be invoking my delegate. So let's first inject the delegate in the method parameter. So I will say is eligible. So I have taken the delegate as the method parameter, and now I can simply invoke is eligible delegate here, and I can pass down the employee object. Okay, so what will happen? This delegate will get executed and it will take the employee object and it will return either true or false. Based on that result, we will print the line employee is promoted. Okay, so now we have removed the hard-coded logic from our employee class and we have moved it to our is promotable method. Okay, but if you see, we are getting the error at line number 24 because to promote employee method, we are only passing the employee, but now we have to pass the delegate also. So what we can do now, we can just simply pass our is promotable method, because the signature of is promotable is exactly same as is eligible delegates. That's why we are able to send this particular method in this promote employee. Now let's try to run this application and see what is the result we are getting. If you see the result here, only John is promoted, because if you see the employee list here, John was having the experience 18 years. That's why this condition will become true only for John. And that's why this time only one employee was promoted. So guys, this is how you can remove the hard-coded logic from your application or your class and move it to the class which is actually invoking it. This way our code will become more maintainable and more decoupled. This is one way to use the delegates by creating the method and passing it down, but we can also use the lambda expression. Using lambda expression, we can directly create the method within the brackets. Let's see how we can remove is promotable method and use the lambda expression instead of that. To use the lambda expression, we need to use the parenthesis and then use the lambda sign, that is nothing but equal to and this angular bracket. And after that, we can put our angular brackets. And now we can simply declare the parameters which the method is expecting. Let me call it EMP for employee. And Let me for now just return true. Okay, so what I'm doing, I am using or I am creating a method directly at this line. Now what I can do, I can put this logic from here to within these curly brackets, and I have to change my E to EMP. And now what we can do, we can simply remove this is promotable method because that is no longer required. And if we run the application again, you will notice we are getting the same output. John is now promoted, but this time instead of creating a new method, we are directly using the lambda expression to create the method and passing it down to the promote employee directly. So guys, this is how you can use the lambda expression. And guys, don't worry, we will learn about the lambda expression in detail in our future videos. That's it for this video guys. In the next video, we will continue our learning about usage of delegates in C#. We will see some more examples and try to understand what are the real-time usage of delegates. Thank you for watching. Hello and welcome to part 39 of this video series. In this video, we will learn about delegate usage. In the last video, we have started our discussion on delegate usage and we have created a simple program where we have used the delegate. In this video, we will continue our discussion from there and we will create some more examples and see how delegates can help us in different kind of scenarios. So let's open up the Visual Studio and start the demo. I have opened up my Visual Studio and now let's try to create an application that will take an input from user and print that message on console. To print the message on console, let's create a class. So I have created a class message handler. This will have two methods. First, that will accept a string from the user, and second one that will print that message on the console. So let's create these two methods. Okay, so I have created my class message handler and that has two methods, send string and print to console. Print to console is doing nothing but printing the message on the console window. And send string is actually invoking the print to console method. Now let's use console.writeLine and get the input from the user. Let's first give a prompt to user to provide the message. Let's say please provide your message. After that, create a string variable message and use console.readLine to accept the string from user. Once we have the string, let's use our message handler class and invoke send string. Now let's run the program and see if it is working as expected. If you notice, it is giving me the message, please provide your message. Let me enter my message here, hello world. And if you notice, it has printed that message on the console. So our program is working as expected. We are able to print the message on console. But now let's say we have a requirement. Maybe we don't want to print the message on console, but we want to print that message on a file. Or maybe we want to send an email to the user once we receive the message. Or maybe we want to do something else with that message. To achieve that, we cannot keep on adding print to console method in our message handler class. What we can do, we can create a delegate and pass down that delegate to message handler class, and once that delegate is passed to the send string method, then the send string method can easily invoke whatever delegate is passed to it. So now let's create a method that will actually print the message on file and one method that will print the message on the console window. I have added the method write to file. Let's provide an input parameter to it, that is string. And now let's try to print this string on a file. To print a message on a file, we need to use FileStream class. FileStream class is available in system.io namespace. So now let's create a variable of file stream and create an object. And within this constructor, we have to pass down three parameters. First one, the file name which we want to create. Let me call it message.txt. Second parameter will be once the file is created, in which mode we want to create the file. Let's say we want to use file.append. So what append will do, it will append the message at the end of the file. And at the end, we have to specify the access with which we want to open this file in our program. Because we want to write a line on the file, that's why we have to use file access dot write here. Once we have our file stream, we need to use stream writer to actually go ahead and write on this message.txt file. Now we have our file stream and stream writer ready. Now let's understand how we can write the message on the file. First, we have to use stream writer and invoke the writeLine method and pass down the string which we want to print on the file. Once that is done, we can flush down our stream writer to tell the program now we are done writing on the file. So we can close the stream writer. Once it is flushed, we can invoke streamwriter.close to finally close the stream writer. And at the end, we can use fs.close to close the file. We have returned the message using stream writer. Then we have flushed down the stream writer to release any pending resources. And once that is done, we have closed the stream writer. And finally, we have closed the file in which we have written the message. Okay. Now let's create a method that will print the message on console window. That will be very simple. Public static void. Okay, I have added this method write to screen. This will actually go ahead and print the message on console. And guys, if you notice here, the signature of write to file and write to screen is similar. Both are expecting a string type parameter and both are having the return type as void. So now what we can do, we can create a delegate and pass down that delegate to send string method, and the send string method will actually invoke the method write to screen or write to file depending on the user requirement. Okay, so let's create a delegate, and we have already seen how to create delegate in our previous videos. Public, we have to use the delegate keyword. Let's make it void because our methods are returning void, and let's name it print string and specify the parameter string s. Okay, now we have our delegate ready. Now what we need to do, we need to add this delegate as a parameter in our send string method. Let's do it. Okay, so I have taken the delegate print string, and now let's just use this delegate and invoke the method which is coming to this method. We can use our delegate and pass down the message, and we can just remove this method from here because we don't need this method now. Now we have only one method in our message handler, that is send string, and depending on the delegate it will invoke the method. Currently we are not asking the user where they want to print the message, whether they want to print the message on a file or they want to print the message on the console window. So let's write that code to ask the user where they want to print the message. To ask the user, I have added these two lines. First, I am asking the user where you want to send the message, and I am giving the user two options, one for file and two for console. Let's store the user's input in a variable. Okay, so I am storing the user's input in my input variable, And now we are ready to create the reference variable for our delegate and pass it down to our sendString method. Print string ps equal to null. For now, let's initialize it to null. And if the input that is coming from the user is equal to 1, then in the delegate, what we can do, we can initialize the delegate with our write to file method, because user has chosen 1 and 1 belongs to file. That's why we have initialized the delegate with write to file method. If the user is not providing input as 1, then what we can do, we can simply initialize the delegate with our console method. Okay, I have changed the method here to write to screen. And finally, I can pass down this delegate to my send string ps comma message. Let's run this program. You can see it is asking me to provide a message. Let me provide hello C#. Once I have provided the message, it is asking where I want to print this message. I want to print it on a file or I want to print it on a console window. Let's for now choose the option 2 and hit on enter. You will see it has printed our message on the console and saying your message is hello C#. Okay. Now let's run the application again and provide some message again, hello world. And this time let's choose the first option, file option. So as per our code, it should go ahead and print this message on a file. Okay, the program is completed. So let's check if it has created the file or not. For that, open the solution window here and right click on it and choose open folder in file explorer. Once you are in this folder, you have to choose the bin folder, and within bin open the debug folder and then open the .NET 6.0. This folder might have different name depending on the version of .NET that you are using. Open this folder and within this you will find the message.txt file. If you remember, in our code we have provided message.txt as the file name that we want to use in the file stream object. Let's open up this file and you will notice it has our message hello world as expected. And guys, this is how you can use delegates to invoke the methods depending on the user's requirement. Benefit of using this approach is we don't have to modify our message handler class if we want to use some different kind of methods. This way we will make our message handler class decoupled from the actual implementation of how we are sending the message or how we are printing that message to a file or we are sending it over an email. This way our code will become more flexible and more dynamic in nature. And that's it for this video guys. In the next video we will continue our discussion and try to create one more example where we will use delegates to implement callbacks. Hello and welcome to part 40 of this video series. In this video we will continue our discussion on delegates and we will see how we can implement callbacks using delegate. First, let's try to understand what is a callback. A callback is a term that refers to a coding design pattern. In this design pattern, executable code is passed as an argument to other code and it is expected to call back at some time. Let's understand this with a real life example. Let's say you are downloading something from internet. The download operation will take some time, and what you want to do once the download is completed, you want to notify your user saying the download is now completed, or maybe you want to perform some other operation. Maybe you want to open the folder location where the file was downloaded. In these kind of scenarios, we can use callbacks. In callbacks, we can pass some piece of code and that will be executed once some event is triggered. In our case, it will be file download completed event. For this demo, let's create a class. I'm calling it callback demo. This will have a static method. I will name it start new download. So what this method will do, this will emulate a download scenario. First we will give the message download started, and then we will wait for 3 seconds to simulate some wait time, because when we download some file from internet, it will usually take some time to complete. But now let's say we have a method. So I have added this method that is download completed. So what we want to do, once the download is completed, we want to invoke this particular method to notify the user at this time download was completed. For this, what we can do, we can use delegates. So let's create a delegate. I will name it download completed callback. And this will take a string type parameter. Okay, I have matched the signature of my download complete method with my delegate so that I can pass down this method in my delegate. Now let's initialize our delegate. So what I have done here, I have initialized my delegate with the download completed method. Now what I can do, I can pass down my delegate callback as a parameter to start new download method. First, let's create a parameter here. Now let's invoke the method start new download. Pass down the delegate here. Now once the wait is completed, meaning once the download is completed, we can simply invoke the delegate which we have received as part of this method. And in this, I can provide the message I have completed the download. So what will happen? We will invoke start new download method. The execution will go to line number 27 and we will start executing from here. And once the download is completed, we will invoke this particular delegate. And because this delegate is referring to this particular method, so this method will be invoked and we will print the time and the result which we received from callback demo class. Let's run this program and check if the code is working as expected. If you notice here, we have received the message download started, and after 3 seconds, we have received this message, date, time, and the message I have completed the download. So guys, this is how you can implement callbacks using delegates. We can pass down the delegate to the method that is doing some long processing, and once that process is completed or that event is triggered, we can invoke the delegate to execute the callback method, which we have done here. In our case, the callback method was download completed. So we have successfully executed download completed method once the download was completed. That's it for this video guys. In the next video, we will learn about multicast delegates in C#. Hello and welcome to part 41 of this video series. In this video, we will learn about multicast delegates. A multicast delegate is a delegate that references to more than one function. What we have seen till now, we had one delegate and that was pointing to a one method, method one. But what we can do in C#, we can make our delegate to point to multiple methods also. Maybe it can point to method 2 and at the same time it can point to method 3. So there is no limitation actually. One delegate can point to n number of methods. What will happen when we execute the delegate? So once we execute the delegate, whichever method we have assigned first, that will be executed first. And when you invoke a multicast delegate, all the functions or methods that the delegate is pointing to are invoked.
So if our delegate is pointing to three methods, when we execute the delegate, all those three methods will be executed. To create a multicast delegate, there are two approaches. We can use plus operator, or we can use plus equal to operator to register a method with the delegate, or we can use a negative sign or a negative equal to sign to unregister a method from the delegate. So let's open up the Visual Studio and understand this with help of an example. If you remember from the past video, we have created this example where we have created one delegate, download completed callback delegate, and this delegate was pointing to download completed method. And once that delegate was executed, we were executing the download completed method and we were printing this line on the console. But let's say once the download is completed, we want to give the user the message that download is completed, but also we want to tell them like this is the path where the file was downloaded. So in that case, what we can do, we can make our delegate to point to two different methods. Okay, so let's create a method that will tell us the file path where the file is downloaded. Okay, so I have created this method that will simply print file was downloaded at this particular location. So once the download is completed, we want to pass the delegate that will point to two methods. One is download completed and second one is show file path. So to assign one more method to our existing delegate callback, what we can do, we can use this callback delegate equal to callback. So this is one way to register a new method to our delegate. If we run the program now, we got the message download started, and after the download is completed, we are giving the message I have completed the download, and after that we are showing file was downloaded at this particular location. So as this is one way to register methods with delegate, or we can use a simpler syntax. In that we can use plus equal to operator and we can directly give the method name. If we run the program now, this will also give us the same result. And to unregister a method from a delegate, we can use the minus symbol. Let me show you how. So using minus sign, I can remove the method invocation from delegate. If I run the program now, this time show file path will not get executed. You can see we didn't see the show file download method getting executed. And similarly, we can use minus equal to operator to achieve the same thing. See, we are getting the same result, but this time we are using the minus equal to operator. A multicast delegate invokes the method in the invocation list in the same order in which they are added. Let's understand this with help of a demo. Okay, I have created three methods and one delegate, and the signature of delegate is matching with the signature of the method. Now let's initialize the delegate. So what I've done, I have initialized the hello delegate and I have made my delegate to reference to method 1. Let's point to method 2 and 3 also. I can say delegate plus equal to method 2. Similarly, I can say delegate equal to method 3. So now we have added method 1, 2 and 3 all in our invocation list. And now when we execute the delegate by passing some message, let's change the message here. If you notice, we are getting method 1, 2 and 3. So the order in which we have added this method in the delegate, in the same order, the methods will be executed. If I change the order, let's say if I add method 3 above my method 2 and run the program now, this time we will get method 1 first, then method 3 and then method 2. And there is one other way to register the methods with the delegate. What we can do, we can create three delegate references. Let's say delegate 1, 2 and 3.
and all these are referring to method 1, 2 and 3. And now what I can do, I can create one more delegate, hello del4, and I can say del1 plus delegate 2 plus delegate 3. And at the end, let's invoke the delegate 4. Now what is happening here? We are creating three different delegates and we are creating fourth delegate that is actually having the reference of all these three methods. So now when we execute the delegate, we should get the same result again. If you notice, we are getting method 1, 2 and 3 as expected. Okay, if a delegate has a return type other than void, and if the delegate is a multicast delegate, only the value of the last invoked method will be returned. Along the same lines, if the delegate has an out parameter, the value of the output parameter will be the value assigned by the last method. So what it means is, if our delegate is returning some values, we will only be able to capture the values which is returned by the last method. Let's go to Visual Studio and understand this with an example. Okay, let's change the return type from void to integer and remove the parameter for now. Now let's change the signature of our delegate also. I will remove the input parameter because now our methods are not expecting any parameters. Now let's create the delegate reference and add our method 2 and 3 also with plus equal to operator. So what I'm doing, I'm creating a reference variable of a delegate and I am making this delegate to reference to method 1, 2 and 3 and I'm executing that delegate, and whatever the result is coming from the delegate, I am storing it in result variable, and at the end I am printing that result whatever we have received. If you will notice in this case, because at the last we are executing the method 3, so it will return 3 from here and we should get 3 on the console window. Let's run the program. You will notice we are getting the 3 as the output because we can only fetch the return value that is returned by the last method. Similarly, if we have out parameters, so I have changed the method return type to void and I have added out parameter to our all three methods, and I'm setting this value of out variable to 10, 20 and 30 in method 1, 2 and 3 respectively. Let's change the definition of our delegate also. That will have the return type as void and this will also have the out parameter integer. Now, when executing the delegate, I need to pass one out variable. Let's declare that variable first. Int out parameter equal to -1. So first we are initializing the out parameter to -1. Let's pass down this to our delegate. And at the end, let's print the out parameter. So if you will notice here, the out parameter will get set to 30 because at the end we are executing the method 3. So if I run the application, you will notice we are getting the 30. So we have just seen, if the delegate has return type other than void, then only the value of the last invoked method will be returned. And similarly, if the delegate has an out parameter, then the value of the output parameter will be the value assigned by the last method. Here are some of the important points about multicast delegate. In multicast delegate, every method is called using a FIFO pattern, means first in, first out. Whatever method we have assigned first, that will get executed first. Methods are added to delegates using plus or plus equal to operator. And methods can be eliminated from the delegates using minus or minus equal to operator. That's it for this video, guys. In the next video, we will learn about exception handling. Hello and welcome to part 42 of this video series. In this video, we will learn exception handling. When executing C# code, different errors can occur. Coding errors made by programmer, error due to wrong input or other unforeseeable things. when an error occurs, C# will normally stop and generate an error message. The technical term for this is C# will throw an exception. There can be two types of errors. One is compile time error that we will see at the build time when you try to build the application, and if there are any errors, C# compiler will not build the application and it will throw the error at that time. And there could be runtime errors which we cannot see at the build time, but when we run the application at that time, errors will come up. Let's go to Visual Studio and understand this with some example. Okay, I have opened up my Visual Studio. Now first understand what are compile time errors. Compile time errors are basically that compiler can catch and tell us while writing the code itself. Suppose I am declaring an integer a, and if I try to store integer a to some string in it, compiler will give us the error. So these type of errors are called compile time errors. There can be multiple reasons for compile time error. One is if you are providing the incorrect data type. Second example can be if we have a method. So I have a method m, and let's say while invoking this method, I am not providing the proper inputs. I am providing some invalid inputs. I have provided string as my input, but if you see, the method is not expecting any string. This time you will get the compile time error. You can read here, no overload for method m takes one argument. So these type of errors are known as compile time error. Now let's see what are runtime error. Let's suppose you are asking a user to input some number. Let's say, please provide your age. Okay. So the assumption is user will provide some valid number that we can cast to a number variable. Let's say integer n equal to console.readline. And we all know when we use the console.readline, it will give us the string. So we need to pass the string to a number. For that, we can use int.parse method. This will take the string which is provided by the user and it will convert it to the integer type. Now let's try to print the age which we have received with the message age is, and we can use our n variable. Now let's run the program. You can see we are getting the message, please provide your age. Let's say user is providing age as 18. You can see program is running successfully and we are getting age is 18 without any issues. But let's say user don't provide any valid input here. What if user provides ABC here, which is not a proper integer? So of course, when we try to parse this string to a number, the parse operation will fail and we will get the exception. If I press enter here, you will notice we are getting the exception here. Input string was not in a correct format. So these type of errors are known as runtime errors or exceptions. Let's go back to slides again. Okay. In C# to handle these kind of errors, what we can do, we can use try-catch blocks. Using try-catch block, we can avoid our application to crash. If you notice here, in this example, our application has crashed and it has stopped running at line number 12 because we faced the error at line number 12. Let's try to run the application in run mode also. If I press Ctrl F5, now our application is in run mode. It is not in debug mode. Now if I send ABC string here, you will notice we are getting the error message on the console. Unhandled exception, system.format exception. So this is the type of exception which we are receiving, and it has the error message input string was not a correct format. All right. And it is giving some information about the exception, where the exception has occurred. If you read here, it is saying line number 12 in demo.cs class. If you see line number 12, at this line only, we are trying to pass that string to an integer. So using this information will actually help the developers to debug the code and resolve the issues. Okay, let's suppose we had some other piece of code here. We are printing the message. Thanks for using this application. Now run the program and let's give some invalid input now. Okay, let's first try to give some valid input. Let's say 22. I am providing a valid number, and if I hit enter, this time I am getting age is 22, and I'm also getting the message, thanks for using the application. Now let's say if I don't give the valid input, I am giving XYZ. Okay, you can see we are getting the error message again. The program has crashed and we are not executing the line number 16 because the program has crashed at line number 12. So whatever is there after that uh, line will not get executed. This is because we have not handled the exception properly. So in order to execute the program and to handle the exception which we are getting at the runtime, what we can do, we can use try and catch block. Let me show you how we can use try and catch block in this case. We know we might get exception at this line. So what we can do, we can encapsulate this piece of code within our try block. Let's declare this variable outside the try block. Okay. And if you notice, we are getting an error message here. It says expected catch or finally. So whenever we are writing try block, it is mandatory to provide either a catch block or a finally block. Let's for now we'll provide a catch block and we will understand what is the purpose of adding a catch block. So what we are doing, if at all we are getting any exception in this try block, that exception will be caught here using the catch block, and within this block we can handle that error message. Maybe we can show the error message to the user. Let's try to provide it here. CW e dot, we have the access to message property here, so we can print that error message. Along with that, we can also tell invalid input, please try again. So we can give a user-friendly error message so that user will know that they have not provided a proper input, so that they can run the application again and provide the input. And I have to initialize my local variable. Let's initialize it to 0 for now. Let's put a if block here so that we don't print out the age if it is 0. If n is not equal to 0. Okay. Now try to run the program now. Okay. Now if we give some invalid input, let's say X, and if we hit the enter, you will notice we are getting the error message. Input string was not in correct format. So this is the exception message that we are receiving from the line number 19. And after that, we are getting a user-friendly message, invalid input, please try again. And at the end, we are executing the code. Thanks for using this application. So this time, if you notice, the application has not crashed, and we have executed the application till the end line, like line number 25 was also executed. So guys, this is how you can use try and catch block to avoid our application to crash and provide some meaningful error message to the user so that user will know what they have did wrong. Okay, I have added the finally block here. So what will happen if we don't get any exception? First, we will go to the try block, and from the try block, if there are no errors, we will not go into the catch block. We will directly go in the finally block. Okay, and after that, whatever code is there after the final block, that will get executed. And suppose if we receive any exception or an error message while running the application, that time first we will go to the try block, and then we will go to the catch block, and then we will go to the final block. So irrespective of if we receive the error or not, we will always go to the final block and execute the piece of code there. The final block can be very useful to release up the resources. Suppose you are opening up a database connection in your try block and you receive some database error. That time you can use your finally block to close the database connection so that we don't hold up to the database resources. And if I run the program now and I give some invalid age ABC, you will notice we are getting the message I am in the final block. So final block will always get executed. Now let's understand the purpose of throw keyword. Throw keyword can be used to throw custom exception. Whatever exception we have seen here, that was thrown by the .NET. So at the runtime, .NET will get the error and it will throw that error message there. But developers can write the code to throw the error message in some custom scenarios also. Let's say if the age is not above 18, we want to throw some exception. So what we want to do, if the age here is less than 18, what we want to do, we want to throw a new application exception, and I can give the error message here, age cannot be below 18. So instead of .NET throwing the exception, I am writing my code at line number 19 to throw the exception if age is not greater than or equal to 18. So I have used the throw keyword here and I am throwing a new application exception. Similarly, I can catch this exception in my catch block. Okay. So what I can do, I can change this exception to application exception. Okay. And this time I can change my message here, or let's remove the message from here. And let's add one more catch block. And this time I can give the exception. So what will happen in this case, if we receive any application exception, we will go to this catch block, and if we receive any other exception other than application exception, in that case we will hit our this particular catch block. Okay, let's run the application, and if I provide the age as 17, this time you can see we are getting the error message age cannot be below 18, and then we are going to the finally block, and after that we are printing the age and we are giving the message thank you for using this application. And let's suppose now if I give any invalid input ABC, and if you see we are getting the different error message because this time we went to this particular catch block and we are printing input string was not in correct format, and then we're executing the final block, and after that we are printing the message thank you for using this application. We will discuss the multiple catch block in details in our next video. For now, let's see what are the common standard exception that we have in our .NET. First one is the out of memory exception. As the name says, when the application is running and the memory in our system is not enough, that time this exception will be thrown, out of memory exception. Second one is null reference exception. Basically, when we will try to access any object that is not initialized, that time we will receive the null reference exception. Invalid cast exception. If we are trying to cast some data to a different data type and that data is not valid, that time we will receive the invalid cast exception.
Array type mismatch exception. If we're trying to store something in array that is not of correct data type, that time we will receive the array type mismatch exception. Index out of range exception. If you are trying to access an index of an array that is not available, that time we will receive the index out of range exception. For example, if we have an array of size 5 and we are trying to access an index 10, so the 10th index will not be available and we will throw index out of range exception. Arithmetic exception. Arithmetic exception will occur when we are trying to do some arithmetic operation and some error occurs at that time. Divide by zero exception. As the name suggests, if we are trying to divide a number by zero, that time this particular exception will be thrown. Overflow exception will occur if you are trying to store a number that is not supported by the variable in which you are trying to store it. For example, you have a very big integer number that you are trying to store in int variable, but there is a range that a int variable can store. If you go beyond or below that time you will get the overflow exception. That's it for this video, guys. In the next video, we will learn about multiple catch blocks and how we can create custom exceptions. Thank you for watching. Hello and welcome to part 43 of this video series. In this video, we will continue our discussion on exception handling. I have created this short program which will actually divide two numbers. First, we are asking the user enter the first number, then whatever the user is inserting, that input we are converting it to an integer and storing in fn variable means first number. Similarly, we are taking the second number and storing it in sn variable, and after that we are creating a variable result and we are dividing first number and second number, and whatever the result we get, we are printing it out of the console. So let's run this program and see what is happening. It is asking me the first number. Let's give 27. Second number 3, and we are getting the result 9 as expected. But let's suppose the user is not giving proper input. For example, for the first number, they are providing some very large number which cannot be converted to an integer because an integer variable has a specific range. If you want to know about the range of integer and other variables, you can go through this video series and find inbuilt data types of C# where I have explained what is the range of integer. So here if we give this big number, C# will not be able to convert this number to an integer and it will throw the exception here. Let's press the enter button. Now you can see we are throwing the exception, overflow exception. Value was either too large or too small for int32. There could be one other case. Let's say the number provided by user is correct first time, but second time the user is giving 0. As we all know, we cannot divide any number with 0. This time we will throw attempted to divide by 0 error. This is divide by 0 exception. As we have seen in the last video, to avoid this exception, we can use try catch block. So let's go ahead and wrap this program in try catch block. So first, let me add a try block and put all this code inside this. And after that, I can have a catch block. And let's say I will give exception here, ex. If you look at the exception message, it has access to multiple properties. First one is the message property. Using this property, we can get the error message. Second one is the stack trace. Stack trace will give us the more information about the error. Along with that, it will tell us at which line number and in which file the error has occurred. So let's say I will choose a stack trace and print it out. Let's give 10 and 0. This time you can see the stack trace here is demo.main. It means we are in demo namespace, then the demo class, then in the main method at line number 32 we have received this particular error. So if you see the line number 22, At line number 22, we are trying to divide the number. That's why we have received divide by zero exception. Okay, let's say I change this exception type to divide by zero exception. Okay, so this time I'm using a more specific class instead of using a generic exception class. I am explicitly mentioning the class name divide by zero exception. Let's see what will happen if I run the program. Now if I enter 0 10 and second number as 0, you will notice we are able to handle the exception properly and application is not crashing. So that's fine. If we are getting the divide by zero exception, we are able to catch it here. But let's suppose we are getting some different kind of exception. Let's say I give a big number and try to convert it to an integer type. That time we are getting the exception. This time we are not going to the catch block and handling the exception. The application has crashed and we are getting exception unhandled and we are getting value was too large or too small for int 32, because in the catch block we have specified divide by zero exception, but actually we have received overflow exception. So that's why this will not go inside the catch block and the application will crash. So guys, it is important to mention the particular exception that can be thrown from the try block. And if you notice here, divide by zero exception, if I go to the source code of it by right clicking on it and go to definition, you will notice the class divide by zero exception is inherited by arithmetic exception. So let's check the source code of this also by going to the definition. And if you see, the arithmetic exception is inherited from system exception. So let's check the source code of this class also. You will notice this class is inherited from exception class. In C Sharp, every exception class is inherited from exception class. At the root level, we have the exception class. If we go to the definition of exception class, you can see whatever code is written in the exception class. Let's close it and come back to our class. So in order to handle the overflow exception also, we can add one more catch block. Let's copy paste it, and this time let's mention it overflow exception. And let's print out the message instead of the stack trace. And if I run the application and provide some big number, this time we have handled the exception properly and application is not crashed. We have printed the message also, value was either too large or too small for an integer. So this is how you can club multiple catch blocks with one try block. And if you don't want to specify any exception type, if you are not sure which kind of exception you will receive, you have two options. Either you can use the most generic class, that is exception class at the end, like this. This way, if our application throws any kind of exception, and we know every exception is inherited from exception class, so that particular exception will come to this class. The exception will check if it is of divide by zero. If no, then it will check if the exception is of overflow type. If no, then it will fall to the exception class. And guys, if you don't want to use the exception object in the catch block, what you can do, you can simply remove this exception object from here and just directly print out the catch block. If you notice, you are getting the compilation error here. You don't have the access to the EX object. Now you can remove it and just put some generic message. Some error has occurred. Okay, so in case you don't want to specify the exception class and you don't want to use the exception object, you can ignore that and just print out a generic message if you want. So let's remove this and see if we are coming to this block or not. If I provide a big number here, you can see we are getting this some error has occurred message. Okay, let's remove this particular catch block. Let's go back to slides now. On this slide, you can see some of the important points about the exception that we have seen in this video. An exception is actually a class that derives from system.exception class. If you remember, we have seen how all the exception class are inherited from a parent class exception. The system.exception class has several useful properties that provides valuable information about the exception. That can be message that will give us the error message, the stack trace that will provide the error message along with that will give us the line number where the exception has occurred. Specific exception will be caught before the base general exception. If you remember from the video, if we have a generic exception like this, and if we are getting a divide by zero exception, so that will be caught first and we will not execute any other catch block. That's what this point says. Specific exception will be caught before the base general exception. So specific exception block should always be on top of the base exception block. Otherwise, you will encounter a compilation error. In Visual Studio, if you try to move this particular block above the specific exception blocks, you will get the compilation error. If I try to build the application, you can see the error message. A previous catch block was already catches all the exception of this for a super type. Because all the exception will fall to this particular block. Now whatever code is mentioned in the specific exception blocks, that will never be executed. So it is not allowed to provide the generalized type of exception on the top. We can put it at the bottom. Okay. And it is a good practice to always release resources in finally block, because finally block is guaranteed to execute irrespective of whether there is an exception or not. And guys, remember, finally block will execute even if we get exception in the catch block. Let me show you how it will work. Let's say in the divide by zero exception, what happens? You are throwing a new exception here. Throw new system exception. So what is happening here? If we are receiving a divide by zero exception, what we are doing, we are printing that error message, and after that we are throwing a system exception to prove that if we get an exception in the catch block, even at that time we will execute the finally block. Okay, let's run this program in run mode. So I will press Ctrl F5. Let's provide the first number as 25 and second number as 0. You can see we are getting the exception attempted to divide by 0, but if you notice, we are still getting I am in the final block. So guys, whether we get the exception in catch block or not, we will always execute finally block. So it is a good practice to release all our resources in finally block. That's it for this video guys. In the next video, we will learn about inner exceptions. Hello and welcome to part 44 of this video series. In this video, we will learn about inner exceptions. Inner exception is basically a property that is available in exception object. We can use this property to provide the information about the exception that has caused it. Let's understand this with the help of an example. I have opened up my Visual Studio. If you remember from the last video, we are taking two inputs from the user, basically the first number and second number, and we are trying to divide it. And in the catch block, I have mentioned divide by zero exception. So if my program is throwing divide by zero exception, it will come to the catch block. In the catch block, what we are doing, we are throwing a system exception. Let's see what will happen when we run the program. I will press Ctrl F5. Now my application is running. Let's provide the first number as 25 and second number as 0. So obviously now we will receive the divide by 0 exception. I press enter and you can see we are getting the exception here. And let's read the message here. Unhandled exception.
system.systemException. Error occurred in catch block. If you notice, we are not receiving the original exception. Originally, it was divide by zero exception, but because we have thrown an exception from catch block also, the original exception is overridden by this exception. And if you see, it is giving us the line number 30 because at line number 30 we have thrown this exception, but originally the original exception was thrown from line number 22 because at this line we are trying to divide it. So for these type of scenarios where exception has occurred in the catch block and we have lost the information about the original exception, here we can make use of inner exception property and provide the original exception information to the user. Let's see how that can be done, and it is very easy. In the constructor of the new exception, what we can do, we can use a second parameter that is nothing but the inner exception. Let's provide the inner exception here, and we know inner exception details are there in this particular object, so we have provided ex object as the second parameter. Now when we throw the exception, we will see the details of system exception as well as the divide by zero exception also. Let's run the program again. I will press Ctrl F5. My application is running. Let's provide the first number as 30, second number 0. We will get the divide by zero exception. And if you notice this time, so first we are getting the system exception. Error occurred in the catch block. This is the message we have provided. And you can also see we are seeing our divide by zero exception also attempted to divide by zero. And we can see the line number also, line number 22. At this line, this exception has occurred. And it has clearly mentioned the end of inner exception strategies. So these three lines are coming from the inner exception. Let's do one thing. Let's try to handle this exception also. To do that, we can wrap this whole code, I mean the try block and the catch block, in one more try block. Let's do this. So I will write it try here. And I will move all this code from here to my try block. So now we have nested try block. Let's put a catch block here, and this time let's give exception ex. And let's just put a breakpoint here and run the application in debug mode. Now the application is running. Let's provide some input 21 and again divide it by 0. Now we are hitting the breakpoint here, and let's see what we have received in ex object. So ex is an exception, and if you see, this is attempt to divide by 0. You can read the inner exception property. In the inner exception, we have attempted to divide by 0. Correct? And if you see the ex object having the message error occurred in the catch block. So this way we can have the information about both the exception, the parent exception and the child exception, which has occurred in the catch block. On this slide, we have some points about the inner exception. To retain the original exception, pass it as a parameter to the constructor of the current exception. If you notice here, in the Visual Studio, we have passed down the original exception as the parameter to the current exception, that is nothing but system exception. Okay. Always check if inner exception is not null before accessing any property of the inner exception object. Else, you will get the null reference exception. Let's understand this in Visual Studio. Let's say I want to print the message of the original exception. I will say console write line ex dot inner exception dot message. Okay. Let's run the program and provide the input 40, 0. you can see we are able to print the original exception, that is attempted to divide by 0. Let's say for some reason we are throwing, okay, so what we are doing, we are simply throwing an argument exception from line number 24. Let's see what will happen in this case. Let's provide number 60 and 12. If you notice here, we are receiving null reference exception. Object reference not set to an instance of an object. This happened because at line number 30, if you notice, what we are doing, we are trying to read the inner exception. But in this case, there won't be any inner exception because we have not reached to this particular catch block. At this particular catch block only, we are adding the inner exception to our exception object. That's why at this line, we will not be having any inner exception property. If I put a breakpoint here and run the application again and provide some input, and we have reached to line number 39. Let's check the EX object here. If you check the EX object here, inner exception property is null here. That's why we have received the null reference exception. So again, it is very important to check if we have the inner exception, then only access that property. Else we will get the null reference exception. Okay, to fix it, what we can do? We can check if EX dot inner exception is not equal to null. Right? If I run the program again, you will notice we are not getting the null pointer exception now. And to get the type of the inner exception, we can use the get type method. Let me show you how. Let's remove this exception from here. Now here, if I want to check what type of inner exception I have, I can simply use EX dot get type. Okay, so this I can use, and instead of using if, I can get name of that exception, and I can store it in a string. Right, and I can print that exception on the console. Let's run the program. Control F5. Let's enter some valid inputs, or let's provide some invalid inputs so that we will get the divide by 0 exception. I will give the second number as 0, and you can see we are printing system exception. And if you notice, this is the child exception. And if you want the type of the inner exception, you can just change here ex.getType to ex.inner exception, and then we can invoke get type on that. Let's run the program again. Y20 0 as second number, and we are receiving divide by 0 exception as our exception type. So this is how you can use get type method to get the type of the exception that we are receiving. And that's it for this video, guys. In the next video, we will learn about custom exceptions. Hello and welcome to part 45 of this video series. In this video, we will learn about custom exceptions. .NET provides various kind of exceptions. On this screen, you can see all the type of exceptions that are possible in C#. You can see divide by 0 exception, duplicate with object exception, field access exception, and overflow exception. So every exception is noted here, and you will see there is a long list of exception that is possible in C#. But there can be some scenarios which might not be covered using these exceptions. Let's discuss some of those scenarios. Let's say you are creating an application, and in that application you want to check the user has logged in or not. If the user has logged in already and user is trying to open a new browser window and trying to log in there, that time we have to check and throw the exception. For this scenario, we don't have any inbuilt exception.
So in this case, we have to design our custom exception, or we can say we have to create a user defined exception. Second example can be, let's say in our application, we want to limit the user only with age above 12. So we don't want anyone who is having age below 12 accessing our application. This kind of exception can be thrown using custom exceptions. So let's open up the Visual Studio and let's try to create some custom exceptions and understand it. Okay, I have opened up my Visual Studio and in my main method, I have written some code. First, I'm asking the user to provide their age, and once the user has entered the age, I'm converting that to an integer and storing it in age variable. Now the requirement is I need to throw an exception if the age is less than 12. For this, we have to create an custom exception. Creating a custom exception is very simple because exception is after all a class. We just have to create a class. Let's call it is not valid exception, and we have to inherit exception class in this. Now this will create a custom exception. And the best practice is whenever you are creating a custom exception, we have to end it with the exception word so that in our program we can see all those classes which are actually used for creating custom exception. Okay, so we have created our custom exception. Let's see how we can use this in our code. I will check if age is less than 12. Then what I can do, I can throw new age not valid exception. Fine. Else we can print console.writeLine your age is whatever the age we are getting. Let me put a dollar sign in front of it. And let's run the program by pressing Ctrl F5. Our program is running and it is asking us to provide the age. Let's enter 11. So 11 is of course less than 12. This time we will throw the age not valid exception. If I press enter here, you can see we are getting one unhandled exception, age not valid exception, and we can see the line number also. At line number 17 this exception was thrown. Correct? But if you remember in the last videos, we were able to pass down our custom message if you want. So let's try to pass some custom message in this constructor. Age must be greater than or equal to 12. But if you notice here, we are getting the error message. If you read the error message, it says is not valid exception class does not contain a constructor that takes one parameter. Because we are passing a parameter to our constructor, so we need to create a constructor that can accept a string parameter. So let's go ahead and create it. Public is not valid exception, and within it let's pass a parameter message, and along with that we need to use the base keyword, and we should be invoking the base class constructor, which is nothing but the constructor of exception class. Right? If I run the program now and provide some age, this time you can see we are getting our custom message here, age must be greater than or equal to 12. Right? And if you remember from the last video, we were able to pass down the details about the inner exception also. To do that, what we can do, we can create one more constructor. Let me copy and paste it here, and the second parameter this time I will make it as exception, and I will name it as inner exception. And this time in the base keyword I will pass inner exception also. And guys, when we are calling this base keyword, what we are doing, we are actually going to the base class, exception class, and invoking the constructor of the base class. Okay, so now this time let me comment it out and try to pass some inner exception also. I can say new exception, and I can give a message inner exception. Okay, let's run the program again. Age 7. This time you can see we are getting our age not valid exception. Along with that, you can see we have the inner exception also. So we have made our custom exception to have a message. We can provide our custom message. Along with that, we can provide a message and we can provide the details about the inner exception also. Now, but if you try to do something like that, throw new is not valid exception and you are not passing any argument, because we have provided a parameterized constructor. Now we don't have access to the parameterless constructor. That's why we need to have a constructor that will take no parameter also. Let's create it public is not valid exception, and this time we will call the base constructor without any parameter, and that's it. You will notice the error is gone, and if I build the application will build successfully. So let's summarize what we have learned till now. If none of the already existing .NET exception adequately describe the problem, we can go for custom exceptions. And here are the steps that we have performed in this video. We have created a class and we have inherited system.exception class. We need to provide a public constructor that takes a string parameter if you want to provide some custom message to our custom exception. And if you want to provide inner exception, then we need to create one more constructor that can accept inner exception as the second argument. If you remember here, we had these three constructor. One was not accepting any parameter, meaning it was parameterless constructor. Second one is taking one custom message and passing that down to the base class, which is nothing but the exception class. You can see system.exception class. And third constructor is the one where we can pass message along with that inner exception detail. And guys, if you notice in Visual Studio, when you create an object of the exception class, you can see here there are three overloads available. You can see one of three. First one, which is not taking any parameter. And if I click on this small arrow button, it will show me the second option, and it is taking one argument, that is string message. And if I click on it again, this will show me the third option, that is nothing but the constructor that is taking custom message. Along with that, we can pass on the inner exception details also. So that's it for this video, guys. In the next video, we will learn what are the bad practices that we should avoid while using exceptions. Hello and welcome to part 46. In this video, we will learn how developers can abuse exception handling and how we can prevent it. Let's open up the Visual Studio and understand this with an example. Okay, I have opened up my Visual Studio and I have written a small program. In this program, I am asking the user to enter the first number and then the second number, and we are dividing those two numbers A and B and printing out the result in variable C. So let's run this program and see what will happen. Okay, our program is running and it is asking us to provide the first number. Let's give 20 and I will give the second number as 0. And now, as we all know, we cannot divide any number by 0. We will receive the divide by 0 exception. I will press enter here and you can see we are getting the message divide by 0 exception. So now, to handle this, what developer can do? A developer can write something like this. They will put the try block to handle the exception, and they can write the catch block, and in the catch block they can write divide by 0 exception, and they can provide the message
cannot divide by 0. Please try again. Okay. And if you notice here, this is the new syntax that we have seen. We are not giving any parameter like this, which we are giving before. If you don't want to use this parameter for this object, we can just simply say divide by 0 exception. In this case, if divide by 0 exceptions occurs in the try block, we will come to this catch block. Let's run the program again by pressing Ctrl F5. Program is running again. I will give my first number 10, second number 0. This time we are not getting the exception. Instead, we are giving a user-friendly message. Cannot divide by 0. Please try again. Okay, so we have handled the divide by 0 exception. Let's say the user is giving some big number. First number I will give this long. And if you remember, we are trying to pass this number to integer type. So this parsing operation will fail and we will receive the overflow exception. If I press enter here, you can see we are getting the overflow exception. Okay, so what developer will do? Developer will add one more catch block and they can give overflow exception here. Let's change this message here. Number too large or too small. Please provide a number between int dot max value and int dot minimum value. So this is the user-friendly message that we will give if we receive any overflow exception. Let's run the program. And if I try to give a very big number, this time we are receiving a user-friendly message, number too large or too small, please provide a number between this value and this value. Okay. So what programmer is doing, they are using try-catch blocks to handle these errors, divide by 0 errors and overflow exception. But ideally, this is not how we should use exception. These kind of errors should be checked by the developer and then only we should provide the message to the user. We should not overuse try and catch blocks because we will be keep on adding these exceptions in the catch block and our code will become very long and it will be very difficult to understand. So adding more number of catch blocks in our code will reduce the readability of our code. To avoid this using multiple catch blocks, what we can do, we can use try parse method here. So let's try to understand what is try parse method. So let's remove this line and store the user input in a string variable. Let's call it a underscore str with a underscore string and we will write console.write line. Okay, so whatever input is coming from the user, we are storing it in a underscore str. Okay, so now let's use try parse int dot try parse. So if you notice the try parse method, what is happening here, it is expecting two parameters. One is string and one is integer type result. So what will happen if we are able to pass the string to an integer successfully, then this method will set that integer in the result variable, means the second variable, whatever you pass here, and it will return true there. So if the conversion or the parsing is successful, we will receive the true from this method, else we will receive the false. So let's use it. Provide string here and let's declare a variable integer a and pass it as the second parameter out a. Okay, and let's declare a boolean. Okay, so whatever the result is coming from try parse, we are storing it in first number conversion successful. This variable we are storing it, and now we can just check this variable. If first number conversion is successful, then we can go ahead and ask for the second number, right? Else we can provide the message invalid number Please try again. And we can add this message also to tell the user this is the valid range of integer that we can provide. Now in this block, after asking the second number, what we can do, we can do the same thing what we did here. Let's declare one more variable, integer a and integer b, and let's copy this line and move it in our if block also. Okay, let's change this variable to second number and change it to b, and let's change it to d string. And we don't have d string variable, let's declare it and use console.readline to get that string. Okay, so same thing we have done for the second number also. We are asking the user the second number and trying to convert it using the try pass method, and we are storing the result of that conversion in second number conversion successful variable. Let's check this conversion result and give the appropriate error message to the user. Second number conversion successful. Then what we want to do, we want to divide these two numbers. So let's copy these two lines. What we did here, let's remove it from there and move it to our if block, because now we know the conversion was successful and we can divide the numbers. Along with this conversion, we also need to check if the second number is not 0. So we have to check if b is not equal to 0. Okay. So if b is a valid number and b is not 0, that time we can divide the number and print the result. Okay. Else if we can check if b is equal to 0, that time we can provide the message cannot divide the number by 0. Else we know conversion was not successful, so we can provide the same message which we have provided here, and we can remove this line of code. And now we don't need any catch block here. We can remove this catch block, but yes, we can keep one generic exception catch block here to handle any other kind of exception if that occurred. Let's change the message here. Let's say something went wrong, and also we can print the message whatever we are getting like this. Okay, so this is how we can avoid using multiple catch blocks and make our code more readable, and this time the developer is not overusing try catch blocks. Okay, let's run the program and see if we're getting the proper output or not. I will press Ctrl F5. I will try to give a very big number, and you can see we are getting a user-friendly message: invalid number is too large or too small. Please provide the number between this range. Okay, let's try to run the program again. This time I will give a valid number 5333. Second number I will give a 0. This time again we are getting a valid message: cannot divide by 0. Please try again. Okay, let's run the program again. I will give a valid number, and second number I will give a very long number. Again we are getting a wrong message. Let's see why we are receiving this incorrect message. Okay, we are getting that incorrect error message because we are only checking the one condition, b is equal to 0. HD, we have to check if the conversion was successful or not. We have to print this message only if the conversion was successful. That's why let's add this one more condition to our else if block and run the program again. This time if I give the first number valid one and second number very big number, this time we are getting invalid number. Please try again, and number should be between this range. So this is the correct message for this scenario. And at the last, let's provide some valid numbers 56, 7, and we are receiving result 8. So our program is working as expected and we are not abusing error handling. And that's it for this video guys. In the next video, we will learn about enums. Hello and welcome to part 47. In this video, we will learn enums. Enum is a short for enumeration. Enum is a very powerful feature in C# that allows us to define a set of named constants. Let's understand what are named constants with the help of an example. I have opened up my Visual Studio. To understand enums, let's create a class. Okay, here I have created a very simple class. It has three properties: name, gender, and age. Now let's create some objects of customer class. Okay, I have created 5 objects of customer class C1, C2, C3, C4, and C5. And I have given name, age, and gender to all the objects. And if you notice here, the gender property can have values male and female. But if you notice, for all the objects, we have to write male and female. If we have 1,000 objects, for all those 1,000 objects, the possibility of gender is only male and female. It would be better if we can change this male and female to some kind of key. Let's say we can change the gender to integer, and for male we can say 1. I will say 1 for male and 2 for female. Now instead of writing male and female again and again, what we can do, we can just pass 1 for male and 2 for female. So by doing this, what we have done, we have made our code more maintainable. Now instead of storing that string male and female every time, we are just storing 1 and 2, that is of integer type. Overall, we are saving some memory in our program. Now that is fine, but still the user can provide some invalid value. If we provide some value 3 here, that will also work, because there is no validation that is checking gender should be in 1 and 2 only. For this, what C# has done, C# has introduced enums. So let's create an enum and understand how we can solve this problem using enums. To create an enum, you have to use the enum keyword. So let's say public enum gender. Okay, so this is how you will create an enum, and what values you want to store in the enum, that will go inside it. So I want to store male and female. All right, so our enum is ready. I can use my enum to store values male and female. And if you notice here, once you create an enum, it will by default give some integer value to the values which are added inside it. If I hover over on the male, it will say male equal to 0. So it means 0 value belongs to male and female equal to 1. For female, we will use 1. But now let's try to change this gender from integer type to enum type. Let's call it gender. And now, instead of using 1 and 2, what we can do, we can use our enum. We can say gender dot male, gender dot, and if you see the IntelliSense sense, we have all the options male and female, and here user cannot make typo mistakes, and user is not allowed to give any other different values which are not available in the gender enum. So by doing this, we are making sure user is providing only the valid values for the gender property. Okay, so I have replaced my integers with enums, and if you look at this code is more readable and more maintainable. In future, let's say someone has decided to add one more gender to our application. Let's say we want to add one unknown also. And it is very easy. Next time, if someone wants to use the unknown gender for the object, what they have to do? They have to just use the enum and use the dot here. And if you see, now we have three options: male, female, and unknown. So we can select the unknown and easily we can start using the third value also. So this way, enums will make our code more readable and more maintainable. So on the slides, you can see enum is short for enumeration, and enum is a very powerful feature. Using that, we can define named constants. If you go back to Visual Studio and see the gender enum, these male, female, and unknown are nothing but named constants, because we have named them male and female and unknown, but at the back end they are using the integer male equal to 0, female equal to 1, and unknown equal to 2. So by default it will start from 0 and it will keep on incrementing the value by 1 for each value. Okay, enums are strongly typed constants, because here if we try to give some other value, maybe let's say if I try to give some string here, male, we will get the compilation error, because our property gender accepts only gender type. So we cannot give any string type here. That's why enums are called as strongly typed. If your program uses set of integral numbers, consider replacing them with enums. Otherwise, the program becomes less readable and less maintainable. In our example, when we were using integers or string instead of using enums, the code was not maintainable and it was more error prone. It was easy to make mistakes when we are not using enums. That's it for this video, guys. In the next video, we will learn more about enums, and in the next video, we will learn how we can convert these values to integer and back to enum values. Hello and welcome to part 48. In this video, we will continue our discussion on enums. In the last video, we have created one enum and we have used in our class. And if you remember, we have used this gender property and we have defined this gender properties as enum type, and we were able to use that enum while creating the objects. Now let's understand some of the other features of enum. Let me remove this code. And for now, let's just focus on this enum class. Enums are value type. So basically whatever the difference are applicable for value and reference types is applicable for the enum also. And as we discussed in the last video, enums will hold a integer value at the backend. And if you want to change it to a short value, what you can do, you can define short here. Now this will be a short type. To prove that, let's first now remove this, and now it is an integer value. Now let's see how we can convert from an enum to an integer value. Let's suppose I have an enum g1 equal to gender dot male. Okay, we all know if I hover over on male, I can see 0 here. But how I can fetch that integer value in an integer type variable? So let's create a variable int, let me call it value, and to get the integer value, what I have to do, I have to do the typecasting. I need to cast this g1 to integer type. That's it. Now if I print this value and if I run the program, you can see I am getting the 0 here. Similarly, I can get the value of female and unknown also. Okay, and if I want to get the values of all these constants which are there in my enum, what I can do, I can make use of getValues method. Okay, to store those values, let's declare an array of integer type. Let me call it values, and let's use enums. Enum is a static class in which we have one getValues method. Let's use that, and let's provide the gender enum here. Okay, once that is done, what we can do, we can typecast this value whichever is returned from the getValues to an integer array. Okay, so this way we can fetch all the integer values from the enum, and let's print these values now.
if I run the program now, you will notice we are getting an runtime error. That is because the gender is of short type and we are trying to store those values in an integer array. So let's change this type to integer and run the program again. And we are getting 0, 1 and 2. So guys, if you want to change the type of value which is stored at the back end, you can change it right here in the enum. Using the colon, you can specify the type which you want to store. Okay, so this is the method to get the values of enum. And if you want to get the names of enums that are stored, you can use the get names method. If I run the program, you can see male, female, and unknown are getting printed. So guys, using get names and get values, we can get either values or names from the enum. Now let's understand how we can convert an integer value to an enum type. Let's suppose you have an integer m equal to 0. Now you want to change this m to an enum type. To do that, what you can do, you can declare a gender g equal to, you can typecast it like this. You can give the gender here and pass m here. That's it. This is how you can convert the integer m to an gender enum. And now I can use this gender enum anywhere where I want it. So guys, this is how you can convert integers to enum and enums to integers. Okay, and by default, you notice the value starts from 0. But if you want to change that, what you can do, you can give your own value by using the equal to operator. And here I have given equal to 10. So next value will be 11 and further down it will be 12. So if I again use my get values method, and if I run my program, you will notice we will get 10, 11 and 12. And also if you want to give your customized values to your enum, you can do that as well. For female, let's say I want to give 25 and for unknown, I want to give 99. This is also possible. If I run the program now, I will get those specific values for my enum. Okay, so now let's understand some of the other important functions that we can use. That is get name, is defined and parse. Suppose you have an integer value, let's say f equal to 25, and you want to convert it back to female. What you can do, you can use get name method. That is very simple. Just use string to store that. Let me call it fem equal to enum dot get name, and I can just pass the type of the enum, that is gender, comma the value, that is f. Okay, and again I need to provide the type using the type of function. Okay, and now let's print out the string value which we have fetched. If I run the program now, you will see we are getting the female string here. So using get name, you can convert your integer value of enum to a string type. Next function is defined. Is defined basically tells us if that value is present in the enum or not. Let's demonstrate that. If I say is defined, and let me change it to Boolean because this will return true or false. Let me store it in the result and let me print the result at the end. And let me change value from f to, let's pass 34. And if you notice, we don't have 34 in our gender enum. And if I try to run the program, I will receive a false error because 34 is not present or not defined within the enum. But if I give some values, let's say 99, 99 is a value that belongs to unknown. So in this case, is defined will give us true. If I run the program, you can notice true is getting printed. So this is how you can use is defined function. And the last function that I wanted to discuss in this video, that is parse function. Parse is basically used to parse a string to its corresponding enum value. Okay, so let me use parse method here and let me give some string value of 1. And I will store this value because this will return an integer value. So I will print that here. And for this, we need to give the typecast also because the return type of parse method is an object. So if I run the program and print the result, I will get the exception. That is happening because I have misspelled my string here. If you noticed, the spelling of unknown is not correct. So let's correct it and run the program again. You can see 99 is getting printed. And guys, let's see some of the inbuilt enums that are defined by the C#. If you go to the system namespace, and you can see here the file access is an enum, and within the file access we have defined some of the accesses that we can provide to the user: write, write, and read. So basically the point that I want to make here is enums are used everywhere in C# language, and it is a good way to make our code more readable and more maintainable. That's it for this video, guys. In the next video, we will learn the difference between a type and a type member. Hello and welcome to part 49. In this video, we will learn about types and type members. Okay, let's first try to understand what is a type in C#. In C#, if you have seen classes, structured enums, interfaces, and delegates, these are nothing but types. Basically, type defines a blueprint for objects. They act like templates that specify the properties and behaviors an object will have. So if you remember from the last videos, in classes we can have properties and we can have methods. And those property and methods basically will tell what will be the behavior of that class. The properties and the class members will tell what data that class will hold, and the methods will tell what will be the behavior that class will possess. When you declare a variable or specify type, you are essentially creating a space in memory that can hold an object based on that blueprint. So whenever we are creating an object of a class or a type, that time the blueprint that the class is having, that will be used and the object will be created using that blueprint. Okay, so now let's move on and try to understand what are type members. Once you have a type defined, the elements that make it up are called type members. These members provide the functionality and the characteristics of the object created from that type. There are various type of members including fields, properties, constructors, methods, and events. Till now, we have understood about fields, properties, constructor, and methods. We will learn about events in our future videos. For types, meaning for classes, enums, structures, and all other types, only we can provide public and internal access modifier. But for a type member, we can provide public, internal, private, protected internal. But for a type member, we can provide any access modifier. There is no restriction. So let's go back to Visual Studio and understand this with a simple example. I have opened up my Visual Studio. So let's try to create a type. Type is nothing but a class. So I have created a class named type demo. So this is nothing but a type. So as we know, type can have only two access modifier, public and internal. If I try to give internal here, that's fine, we can give internal. But if I try to give any other access modifier apart from public and internal, we will get the compilation error. If I give private here, first of all, you will notice IntelliSense is not giving us the suggestion to use the private keyword. And if we use the private here, you will notice we are getting this red line. It means we have a compilation error. And if you read the error message, it says elements defined in a namespace cannot be explicitly declared as private, protected, protected internal, or private protected. So basically what this error says, we can only have public and internal access modifier for our types.
Okay, let me change it back to public. Let's create a type member, and we know what is a type member. Type member can be a property. So I have created a property of integer type with the name number, and this property can have any access modifier which we have in C#. I can change it to private, and if I change it to internal, that will also work. I change it to protected, this will also work. Basically, all the access modifier can be used on a type member. And that's it for this video, guys. In the next video, we will learn about access modifiers. Hello and welcome to part 50. In this video, we will learn about access modifiers. In C#, access modifiers are keywords that defines the accessibility of a class, structure, interfaces, or their members. The members can be field, methods, properties, and extra. So basically, if you want to hide a class or unhide a class to some other class or a structure or interface, you can use access modifiers. So access modifiers can be used with type and type members. If you don't know about what are type and type members, I will suggest you to watch the part 49 of this video series. In that video, we have discussed about type and type members. So let's open up the Visual Studio and create a simple program and understand how we can utilize access modifier in real world. I have opened up my Visual Studio. Let's create a class. So I have created an employee class. This class has three properties: ID, name, and salary. And it has two methods. First one is get salary after tax. And within this method, we are calling one more method, that is get tax rate. So basically, we are trying to calculate the salary after tax of an employee. And to calculate the salary, we are using this get tax method to actually get the tax rate. And this method is returning 10. It means we are using 10% as our tax rate. So let's create an object of employee class and try to use this class in our program. Okay, so I have created an employee object that is having ID as 1, name as Peter, and salary as 10,000. So let's try to invoke get salary after tax method and calculate the salary for this employee. Let's create a variable salary to store the salary, and let's call employee dot get salary after tax. Okay, and at the end, let's just print out salary after tax equal to whatever the salary we are getting. Let's run the program. And you can see we are getting salary after tax is 9,000. Salary was 10,000, but after deducting the tax, we are getting 9,000. So our program is working as expected. Okay. But if you take a closer look in our employee class, we have the method get tax rate. And if you notice, it is using a public access modifier. This public is nothing but an access modifier. So what someone can do, if it is public, this is available in our demo class also. If someone tries to access it, employee dot get tax rate, they can easily access it. So I have invoked the get tax rate method and I am printing it out on line number 17. If I run the program, you will notice we are getting the tax rate also. But as a user, I don't want to see this method in my demo class. Our demo class don't worry about how the salary after tax is calculated. This class is only interested in what salary we are getting after tax. How it is done is the responsibility of employee class. What I'm trying to say here is the get tax method should not be visible to other classes. This is something that should be internal to employee class. So in order to solve these kind of problems, to enforce encapsulation, basically hiding the unwanted members of a class, we can use access modifiers. So if I want to hide this method from the outside world, what I can do, I can make this as private. If a member is private, it won't be accessible outside that class. If you notice, we are already getting a red line here. And if you read the error message, it says get tax rate method is inaccessible due to its protection level. So by applying the private access modifier, we have hidden our get tax rate method from outside world. So now only employee class can access get tax method. If you notice, we are able to use it at line number 30, but we won't be able to use it anywhere else in our program. So this is the purpose of access modifier. And we have seen how we can use private access modifier to hide the things from outside world. Private access modifier can be used on all type members, whether it is a property, a class field, a method, or any other type member. So I can apply private access modifier to my salary if I want. I can apply it to a class field. Let's create a class field, private int I. So we can apply it to a class field also. And very important thing to notice here is private keyword can be used on classes also, but only when the class is not in a namespace level. The class should be inside other class. What I'm trying to say here is, if I put private access modifier here, I will get the error message. Compiler will say element defined in a namespace cannot be explicitly declared as private protected, protected internal, or private protected. So we cannot apply private access modifier on this class because this is directly inside a namespace, right? But if I create a class within a class, let's first change it back to public. And if I create a class within my class, let's call it inner class. Okay, so I have created this class. Let's try to change this access modifier from public to private. And if you notice, it will allow us to do it. If I try to build the application, I will be able to build the application. But if you notice, we are getting the error message because we have changed some access modifiers here. We have changed the salary property to private, and because of that, we are getting the red line here. So let's change it back to public, right? And remove this get tax rate here. We don't want this. And if I try to build the application will build successfully. So guys, private access modifier can be used on all the type members, but it can be used on types also. Means it can be used on type only when they are not directly at the namespace level. If that type is within a other type, that time it can be used, just like we have used it here. So now let's understand the public access modifier. Public means, as the name suggests, it will be public for all. If something is declared as public, it will be accessible within that class. Also, it will be accessible outside that class also. So these are the two extremes. Private means private things can be accessible within that class. Within the employee class, we can access it. Outside that employee class, we won't be able to access it. So if anything is public, it can be accessible anywhere. For example, if you notice the name property is public, that's why we are able to use the name property in the demo class also. And it's not just we can use in the same file. If we have a class in different file also, let me create a file and let me call it second class file. Okay, and let me change it to public for now. So let's create a method in this class and create an object of employee class here. And if I put e dot, you can see we have the access to the name property because name property is marked as public here. But let's say if we have a property, let's call it last name, and let's change the access modifier from public to private. In this case, if I try to access the last name, it won't come. First of all, the IntelliSense will not show you that option to use the last name, but if you type it out, you will get the error message last name is inaccessible due to its protection level. Because last name is marked as private, we won't be able to access it anywhere outside the employee class. But if I try to access the last name within the employee class, I will be able to do it. So if I try to access it in my get salary after tax method, if I say last name equal to some text, I can easily do it. It will not give any compilation errors. Public access modifier can be used on type and type members also. There is no restriction on using the public access modifier. Let's go back to slides now. So there are 6 access modifier in C#. Those are public, private, protected, internal, protected internal that was introduced in C# 6 version, and private protected that was introduced in C# version 7.2. So till now we have understood public and private access modifiers. So now let's understand the protected access modifier also. If we have marked something as protected, then those fields or those members are accessible from the containing class and any class that is inheriting from it. Okay, so if I have marked anything as protected in my parent class, then only the child classes which are inheriting that parent class can access it. Let's go to Visual Studio and understand this with an example. So let's create a class A, and I have a protected field here X. Let's create a class B and create a method M here, and let's create an object of A class. And if you try to access the X here, you will get the error message. It will say X is inaccessible due to its protection level. Because X is marked as protected, it is not allowed to use X outside this class. Only the class A or the classes which are inheriting A class can access the X field. So within the A class, if I have a method, let's call it method M2. Okay, within this method, I can access my X and I can set any value here. Okay, so it is possible. But if my class is not inheriting the class A, that time we cannot access it because the protection level is protected. Okay, now let's remove it, and now let's just inherit the A class. Okay, if you notice, if I type X here, I have the access to this field. I can change it to whatever I want. Okay, and second syntax is you can use the base keyword and use dot operator here. And if you see the option that we are getting from the IntelliSense, you will see we have the option of X field also. So we can use base.x equal to, let's say, 500, right? So this is how you can use protected access level to make our fields accessible to within that class. Means within A class it will be accessible, and it will be available to other class only if that class is inheriting from A class. Let's go back to slides now. So this was protected modifier. And that's it for this video, guys. In the next video, we will learn about the other 3 access modifiers, which are internal, protected internal, and private protected. Hello and welcome to part 51. In this video, we will continue our discussion on access modifiers. In the last video, we have seen 3 access modifiers, which were public, private, and protected. In this video, we will see how internal, protected internal, and private protected will work. As we have seen in the last video, we can use access modifier to hide or unhide types and type members in C#. So let's continue our discussion and start with our first access modifier, that is internal. Internal access modifier in C# restricts access to classes, structures, and their members like field, methods, and properties to within the same assembly. Means if we have marked something as internal, that will be accessible within that assembly. It cannot be accessible outside that assembly. So basically, if you have marked any member as internal, then what will happen? That member will be accessible within that assembly. They are not accessible from the code in other assemblies. Let's go to Visual Studio and understand how the internal keyword will work in C#. First of all, let's understand what is an assembly. Assembly is the final product that we'll receive once the project is built. So if I go to build option and select build solution, it will take our code, compile it, and generate some output with that. So whatever output is generated for that code will be called as assembly. If you can see here, we have one build succeeded. If you want to see what is the output is generated from our code, we can select open folder in File Explorer. This will open up the folder. And if you go to the bin folder, bin stand for binary. If you open that and go to debug folder and go to the .NET folder, you will see demo_string.dll. This is nothing but an assembly. So all the class files, all the interfaces, and all the code which we have written in C# in that particular project is built into this .dll file. This DLL file is called as assembly. If we want to have two assembly, we have to have two different projects in our solution. So let's create a new project for this demo. I will select the add option and I will select the new project. And this time I will search for a class library project. So the class library project is showing up here. I will select that and click on next. I will give some name to my class library project. Let's say demo class library, and I will click on next. I will keep the version as .NET 6.0 and I will click on create. This will basically create a demo class library for us. Okay, so it has this class name. Let's change this class name to class library 1. Okay, and if I right click on it and click on build option, it will again build this class library and it will give us the output that is nothing but .dll file. You can see here a .dll file is created at this path. Okay, now let's understand how internal keyword will come into the picture when we are dealing with assemblies. Let's say I have a class here, public class employee, and it has some properties ID and name. And let's build the application again. Okay, we can see build succeeded. Okay, now to use this class library in our demo project, what we need to do, we need to use the assembly of this particular project. Means we have to use the demo class library .dll in this project. So for that, let's click on the dependencies and choose add project reference. Once you select that option, you will see demo class library option here. If you click on that and click on OK, the reference to that project is added in our project. Okay, now what I can do, I can open up any class file in my demo string project, and if I try to create an object of a class that is available in my demo class library, I will be able to do it. Okay, if I go ahead and type here demo class library dot, you can see we have two options, class library 1 and employee, because we were having two classes here, class library 1 and employee. So I am able to access both of those files here. Let's use the employee class here and create an object of employee class. And if you don't want to use this complete or the fully qualified namespace here, you can remove it from here and you can use a using statement for that. You can go here and click on this bulb icon and select use demo class library. So now the demo class library is injected in our class file. Okay, so now I can use my employee object and I can create or I can initialize the property whatever I want. Okay, this is fine. I am able to access the employee file or I am able to access the employee class because the employee class is created as public here. Let's say I will mark it as internal. As we have studied before, internal keyword means it will be internal to this assembly. This class will not be available outside this assembly. Okay, let's save everything and build our project one more time. If I build it here, if I go to my demo class, you can see we are getting the error message here. It says employee is inaccessible due to its protection level. Because we have marked our employee class now as internal, we are not able to access it outside that assembly. But still we have the class library 1 class as public, we will be able to access it. If I try to use it, class library 1, I can easily access it and create objects of that. Okay, so this is the difference between a public and an internal class. Internal class is internal to the assembly in which we have created it. Okay, let's go back to slides now. Let's see this table which has defined all the access levels which we have in C#. So just now we have seen internal. If you see here, internal, if something is marked as internal, that will be available within that class, okay, of same assembly. It will be available in derived class within the same assembly. It will be available in non-derived class also. If we go to the different assembly, meaning if we drive that class in a different assembly, we will not be able to access it. And in non-derived class also, we will not be able to access it because the access level for that is internal. That's why we are able to access it within that assembly. Now let's understand the fifth access modifier, that is protected internal. It was introduced in C# version 6. It will work like this. If we have defined any member as protected internal, it means it will be available within that assembly and it will be available in other assemblies also, but only if they have derived that class. If you see this table here, for protected internal, it is available within that class. It is available in derived class within the same assembly. It is available in non-derived class also, but within the same assembly. And it will be available in different assembly also, but condition is that that class has to drive that class. Okay. Now let's go to Visual Studio and understand this with an example. For now, let's change this class here to public. Okay, and let's have a field here protected internal integer age. Okay, so this class now has two properties and one class field, that is integer age, but I have marked this field as protected internal. Okay, so let's try to access it within this same class. So if I have a method here, public void m, I can access age and I can set it whatever I want. Okay, so it is available within the same class. Let's try to access it in a different class. Let's say we have a class public class C1 and this will and create a method here public void m2, and now let's create an object of employee class. employee e equal to new employee, and e dot, you can see here we have the access to underscore age field here. I can set it to whatever I want. So this proves we have access to protected internal field outside the class also, even if the class is not inheriting that. Now let's see one example where the class is inheriting it. So I will create a class public class C2, and this time I will inherit the employee class. And let's create a method here, M3, and if I type underscore here, I can see age here, and I can set age whatever I want, right? And similarly, I can use the base keyword also, and I can see I have the access to underscore age here. So this proves if something is marked as protected internal, it will be available within that class. Outside that class, even if we are not inheriting employee class, and it will be available to other classes when we are inheriting it. So this is our protected internal. But what will happen if we go to a different assembly? So let's go to our demo class. Let's remove this code and create an object of employee class. Okay. If you hover over here, you can see this employee class is coming from demo class library project. So we are accessing this file, or we are accessing this class from a different assembly. And if I say employee dot, you can see I have access to name property, I have access to ID property, but I don't have access to age field because age is marked as protected internal. It will not be available to other classes in different assembly if they are not inheriting it. That's why when I put dot here, I don't see the age field. If I try to type it underscore age here and try to assign some value here, I will get the compilation error. And if you read the error message here, it will say age is inaccessible due to its protection level. Okay, but if I create a class, let's say C4, and I will inherit the employee class, and let's create a method in it. Okay, and if I try to say base dot, you can see I have the option to use underscore age here. I can type underscore age and set it to whatever I want. So that is the difference. If I am not inheriting that class, I will not be able to access it. And if I have inherited that class, I will be able to access it. So guys, this is our protected internal access modifier. It is available everywhere except when we are in different assembly and we are not driving that class. Okay, now let's understand the last one, which is private protected. Let's go back to Visual Studio and understand this. And let's create a class field and mark it as private protected string underscore last name. Okay, so I have created a class field last name and I have marked it as private protected. So if we look at this table, it will be available within this class, right? So if I try to access it, let's create a method public void and I can say last name equal to text. So I can access it within this same class, and it will be available in the derived classes also. So let's create another class, public class employee2, and let's inherit the employee class and create a method within this. Let's call it M2, and now I can say base dot underscore last name. I can access the last name and set it to whatever I want. So I can access the last name because it is marked as private protected and I am inheriting this class. But what will happen if I don't inherit this class? Let's remove this inheritance and let's try to create an object of employee class, employee equal to new employee. And if I say e dot, I have the access to name, ID, and if you see, I don't have option to use last name. If I try to type the last name and try to change it, I will get the compilation error. Again, we will receive it is inaccessible due to its protection level. All right. So this is how private protected will work. If you see this slide here, it is available only within that class and outside that class only if that class is driving the class which has that member. And let's try to see if it will work in different assemblies or not. So if I go to a different assembly, meaning our demo class, and let's remove this code for now. And if I say employee dot, if you see, we don't have option of last name. And even if I have a class that is inheriting employee class, right? And let's create a method. You can see we don't have option of using underscore last name here. And even if we try to use the base keyword, base dot, you can see we don't have an option to use underscore last name. And if I try to type it out, you will see the compilation error, last name is not accessible due to its protection level. Because we are in different assembly, we will not be able to access it even if we have derived that class. So this is how private protected access modifier will work. So this was private protected access modifier. It was introduced in C# 7.2 and it offers a more restricted access control compared to protected or protected internal. Okay. And as we have seen, it is available within that class itself and it is available to the derived classes within the same assembly. Let's try to see what is difference between a protected and a private protected. If you notice here in this class, we have inherited the employee class, but still we are not able to access this last name property because it is marked as private protected. But let's suppose it is marked as only protected. Then what will happen? If it is marked as protected, then it will be available in the other assemblies also. If I try to access it in a different assembly, I will be able to do it. If I say base dot underscore last name here, you can see I'm able to access it. So this is the difference between protected and private protected. And that's it for this video, guys. In the next video, we will learn about attributes. Hello and welcome to part 52. In this video, we will learn about C# attributes. Attributes are used in C# to convey declarative information or metadata about various code elements that can be methods, assemblies, and classes. Okay, so basically attributes can be used to provide some information about the code that you are writing. Suppose you are writing a class and you want to provide some information to the user like what this class will do. You can use attributes to provide it. And attributes can be used in various other scenarios also. We have two types of attributes. One is custom attributes and one is inbuilt attributes. So let's go to Visual Studio and understand the attributes with some example. Let's suppose you are creating an class calculator. And in this class, you will add a method to add two numbers. Let me add a method, public static integer add. It will accept two parameters, let's say integer a and integer b. And it will just return the sum of it. Right? Very simple method. It will take two parameters, both of integer type, and
return the sum of it. So if you want to use this method, we can simply use calculator.add because this is a static method, and we can pass two parameters and get the result, or we can directly print it here like this. And if I run the application, we will get the output 9. Okay, our program is working as expected, but now let's say the requirement is now the user wants to add 3 numbers. So what we can do, we can add a method that can accept 3 parameters. Simple, right? I will add one more parameter here, integer c, and I can return that also in my return result. So I am returning a plus b plus c. And similarly, I can invoke that also by passing 3 parameters like this. Okay, nice. So now we are supporting two methods, one that can take 2 parameters and the other one that can take 3 parameters. But now let's say the user wants to add 5 numbers, or let's say user wants to add 10 numbers. You cannot keep on adding new methods in our program, right? It will not make any sense. And the better way to handle this situation is create a method that can take a list of integers. No matter how many integers the user will pass, it will take all those numbers in a list and perform the addition using that. So let's create a method. And this time, let's add the parameter as list of integers. Let's call it numbers, and let's define a sum. Initialize it with 0 and iterate through all the numbers and keep on adding sum equal to sum plus the number that we have in the list, and at the end return the sum. Okay, so now what we are doing, we are accepting a list of numbers and we are looping through all those numbers and adding them in some variable, and at the end we are returning this sum variable, right? So let's try to use this in our application. Let's create a list of integers. And now let's call our add method like this. Let's store the result in some variable, and finally print the result using console.writeLine and run the application. Our application is running and we can see 312 is getting printed, and we have successfully added all these numbers which were provided by the user in the list. Okay. Now, if you notice this class, we don't need these two methods now, because now these two scenarios can be handled by list of integers. So what we can do in this case, we can mark these methods as obsolete. So there is an inbuilt attribute. If you can see here, the IntelliSense is giving the option. We can use this obsolete attribute. You can read the message here also. Marks the program elements that are no longer in use. This class cannot be inherited, right? If I mark this method as obsolete, means if I try to use this method, let's remove this code and try to use this method. Let's pass 2 parameters. You can see here we are getting the error message, and if you read it here, it will say calculator dot add int comma int is obsolete, because now we don't want this method. We already have a method that can accept list of integers. That's why we can mark this method as obsolete, so that users will know this method is no longer supported. We have the newer version of the method, right? And if you want to provide some custom message, that is very easy. You can pass your custom message as a parameter here. This is an
obsolete method, please use add that accepts list of integers, right? And if you hover over here again, you will see we are getting the newer warning message. This is an obsolete method, please use add list of integer. Okay, so now we are telling the user please don't use this particular method because we already have list of integer methods. So this is how we can make use of attributes to ensure the user is using the latest method, and also we are also supporting the backward compatibility, because if someone is already using the add method that takes two parameter, that will keep on working, that will not break the code that they have already written. And if you build this application, you can see here, if you go to the error list tab, you can see we are getting 6 warning, and one of them is this one. This is an obsolete method. So whatever message we have provided is coming as a warning here. But let's say you want to make this as an error, meaning if someone tries to use this particular method, they should get an error message, means they should get a compilation error. For that, you can pass the second parameter, that is a boolean type. You can send it as true, and if you notice that green line is turned into red line, meaning that warning is now turned into a error message. And if you notice here, we are getting the error message. The message is same, but this time it is a compilation error. If I go ahead and try to build this application, you will notice we will get the compilation error, meaning the build is failed. You can see the message here, build one failed. And if you go to the error message, you can see the first one, we have the one error message now. Now this message is coming as error, and we are not able to build the application, or we will not be able to run this application. There are some other inbuilt attributes, or we can call as there are some other predefined attributes in C#. We can use these attributes to provide some metadata to the code that we are writing. So if you notice here, first one is the serialization attribute. By marking these attributes, a class is able to persist its current state into stream. We have the second one, non-serialization, that is the totally opposite of the first one. We have the third one as obsolete, that we have already seen in this example. And the fourth one is DLL import. This allows .NET Core to make call an unmanaged C or C# library, right? We have the web method. Using this, we can declare a method as an XML web service. And we have the final one, CLS compliant, that enforce the annotated items to conform to the semantics of CLS. And in C#, you can also create your own attributes. Those will be called as custom attributes. Custom attributes can be used with reflection to get information about types, methods, properties, and fields at runtime. These can be useful in a variety of situations, such as generating documentation or building a plugin system. So let's go to Visual Studio and try to create a custom attribute. Creating a custom attribute is very simple. You just have to create a class. Let's call it log attribute. And we have to inherit the inbuilt attribute class. That's it. Once it is done, our attribute is ready to use. Now you can go ahead, mark your methods or classes by log attribute. If I try to provide it here, you can see we can provide this log attribute to our demo class. And if you hover over here, you can see it says log attributes. And when you're creating a custom attribute, make sure you are ending it with the attribute word, and you have to inherit the attribute class. If you don't do it, like if I change this log attribute here to log attribute 2 maybe, you will notice we are getting the error message here because now C sharp is not considering this as an attribute because it is not ending with the attribute word. So to create a custom attribute, it is mandatory to append attribute at the end of the attribute name. Okay, so just like a class, an attribute can also have some properties. So because this is a log attributes, let's try to add a log message property, and we can use a constructor so that user can provide the log message when they are using this attribute message, and whatever message is passed using this constructor, that I am basically assigning to my property message. Okay, now our log attribute is ready, but if you notice we are getting the error message here. Let's remove it from here for now and create a class, public class. Let's call it user service, right? And let's create a method here, public void update user, and it will have some logic to update the user. Okay. So for now I'm just writing a comment, but in the real world we will have the logic to update the user. So now what we want to do, we want to log the message saying the user update is received, right? We can pass the message like user update received, correct? So we have passed this log message to our update user method, and we can use reflection to read the message of this attribute in our program. To do that, we have to use reflection. We have to use this particular namespace system.reflection. This will allow us to read the metadata of our code and read this attribute. First, we have to create an object of our user service class. So let's do it. User service. Okay, so I created an object of user service class. And now to get this particular method, what we need to do, we need to use this object user service and call get type method. So this will basically give us the type of user service, and on this we can invoke get method, and I can pass the method name like this, update user, and this basically will return an object of method info. So let's store it in our method info object. Let's call it mi or minfo. Okay. Once it is done, let's check if this method is having the log attribute or not, else we might receive a null exception. To check if this method is having the log attribute or not, what we can do, we can use this method info. On this we can call is defined method, and in this we can pass type of log attribute. So what we are doing, we are checking if this method info has definition of log attribute, and if you notice here our update user is having the log attribute, so this condition will be true. And once this condition is true, what we want to do, we want to read this attribute. To read the attribute, what we can do, we can use our method info object, and on this we can invoke get custom attribute method, and within this method again we have to pass the type, meaning which type of attribute we are trying to read. Once that is done, let's store it in a attribute object, and let's call it attribute. We can do the type casting also here. So whatever attribute we are receiving, we are converting that attribute to a log attribute, correct? And now, once we have this attribute object, we know it is of type log attribute. Then what we can do, we can just simply call log attribute dot message. If you notice here, we are getting an error message here. That is because once it is typecasted or converted to log attribute, we have to store it in a log attribute reference. Once that is done, you will notice the error message is gone and we can print the attribute message which is available on this method. Let's run the program and see if it is working. You can notice we have printed the message on method, and we are able to read user update received because this is what we have passed when we have decorated our method with log attribute. That's it for this video, guys. In the next video we will learn about reflection. In this video we have learned how we can read attributes using reflection, but in next video we will do a deep dive into all the concepts related to reflection. Hello and welcome to part 53. In this video, we will learn about reflection. Reflection in C# is a very powerful feature that allows us to inspect and manipulate code at runtime. Meaning, using reflection, we can read the metadata of an assembly at runtime. Visual Studio will use reflection to show us the suggestions when we type code in Visual Studio. If you look at this picture, when we type name and put a dot right after that, we can see all the methods which are available as part of that name object. So whatever we can apply on that name object is mentioned here. These are nothing but the methods which are available in string class. Reflection in C# provides us the ability to examine types, their members, and invoke methods dynamically. Now let's understand what are the uses of reflection. As we have already discussed, when we drag and drop a button on a Vim form, meaning on a Windows Form application or an ASP.NET application, the properties windows uses reflection to show all the properties of the button class. So reflection is extensively used by IDEs and UI designers. Second use case can be late binding. We will understand what is late binding and early binding in the later part of this video series. But for now, we can understand late binding can be achieved using reflection, and we can use reflection to dynamically create an instance of a type, and we can also manipulate the properties of that object using reflection. So reflection enables us to use code that is not available at compile time. As we have understood, reflection is used to read the metadata of the code that we have written. So let's understand how we can see metadata of an assembly. I have given one URL here that is from the jetbrains.com website. From here you can download a tool that is called as Decompiler. If I go to this URL, it will look something like this. From here you can click on this download button and download this tool. Using this tool, we can see what is the metadata that is generated by the .NET, and we can also decompile our assemblies using this tool. So once it is downloaded, you can start it from your start menu. You can type .peek and you will see the option of that software that you have just installed. Once the .peek software is opened, it will look like this. And from here you can see on the left side all the assemblies which are available in our system. And if you want to add your own assemblies, you can click on this green button here, the first one, and this is basically the open button. You can click on it and you can navigate to the assembly, meaning the .dll file that you want to explore in this software. So let's look at our student class that we have created in this video series. In this student class, we have ID property, we have name property, passing marks, age, and we also have school name, and there are some class fields also. like underscore id is a class field, and we also have a class field that is team name, which is nothing but an array of string. Once we build this application, meaning once we click on build, it will generate the DLL for us. You can see build one succeed. And if I right click on my project and click on open folder in file explorer, it will open up the project in file explorer, and from here I can select bin folder. I will go to debug folder and then the .NET 6.0 folder. Within this you will see we have the .dll file. This is nothing but an assembly. So assembly will contain all the code that is compiled, and it will also have the metadata. To check that, you can use this assembly in our .pick tool. In this tool, I have already added my assembly demo underscore string. And if you expand it, you will see this is the metadata that is generated for us. And if you expand the metadata, you can see all the information about our assembly. We can see it has 10 fields. Some fields are auto-generated by .NET. We have underscore ID, name, passing marks, age, school, team name, email. So all the fields that we have created are showing up here. Along with that, we can see the properties also. There are 8 properties defined here. And if you expand this, we can see all the properties that we have defined in our class. Along with that, it will have information about methods. Because we don't have any methods, that's why it is not showing up here. But because we were having the properties, that will auto created some methods for us, like for getters and setters, it will inject those methods, and we can see those methods here with name get underscore id and set underscore id. So this is how you can examine your metadata of an assembly. So C# reflection is all about reading this metadata and provide this information at runtime. Let's open up the Visual Studio again and understand the reflection with some examples. If you remember from the past video about C# attributes, we have used reflection in our main method, where we have used get type, get method, and using these methods we were able to read the attributes which we have added to our method. So for now, let's remove this piece of code and try to understand the reflection. So I have created a customer class. This has two properties, name and address, and along with that it has two constructors. One is parameterless constructor and one is parameterized constructor. Along with that, it also has two methods. One is print name and second one is print address. So now, how you will create an object of a class? What you will do, you will type customer and use the new keyword to create the object, and after that you can use customer dot maybe print address to print the address, right? Let's set some address here, address equal to abc, like this. And if I run the program, you can see we are printing the address abc. So this is called as early binding, because at the compile time itself, the compiler will know where we have the customer class, right? If I remove this class or I change the name of this class to customer ABC, you will notice we will start getting the error, because it will not be able to find customer class. It will say, are you missing a using directive or an assembly reference, right? So at the compile time, we should have the custom class with us. Only then we can use it like this and create objects of it and use it in our code. But using reflection, that is not the case. Even if we don't have the customer class, we can still create objects of customer class. Let me show you how. Let's suppose at compile time, the customer class is not available, right? But what we can do with reflection? With reflection, what we can do, we can declare end reference of type. Let's call it type t equal to, we can say type dot get type, and within this we can pass the fully qualified name of our class where it will be available at runtime. So our customer class will be available within the demo namespace, and the name of the class will be customer. So the namespace or the fully qualified name will be demo.customer. And once that is done, we can use activator dot create instance t. So using this, we can create an instance of customer class. Let's call it obj obj equal to whatever the instance that is created using this activator. So this is how you can create objects without knowing about the customer class. Even if I remove this class, right? If I remove this class, still we are not getting any compilation error because currently we are using reflection to create the objects. So this is the benefit of using reflection. Even though the code is not available at the compile time, but still we can go ahead and create instances using reflection. Let's add the code back again, and let's now see how we can print the properties, meaning the name and address, using reflection. So getting the information about properties is very simple. You just have to invoke get properties method, right? This method will return all the properties that are available within this type, meaning within the customer class. So let's store all the properties which are available in some variable. So the return type of this get properties, you can see here, is properties info array. So let's create a properties info array and let's call it properties, right? And the return type of it is property info, not the properties info. So let's change the spelling here to property info. Now the compilation error is gone. Now what we can do, we can use a for each loop to iterate through all the properties which are available using get properties method. And if I run the program now, you can see I'm getting name and address. Now let's say you want to print the information about the methods that we have in this class. To do that, you can invoke t dot get methods method, right? You can call it and you can see the return type of it is method info. So you can create a method info object. Let's call it method info or methods. And once that is done, you can again use for each loop. If I run the program, you can see we are getting lot many methods: get underscore name, set underscore name, address, get address, set address, print name, print address. These are the one which we have created by ourselves, and the above four are the one which are automatically created by the .NET because we have created getters and setters. So automatically C# will create getters and setter methods for us. That's why we are saying get name, get address, and set address. And along with that, you can see at the end we are seeing four other methods that are get type, toString, equals, and get hash code. These four are coming from the object class because in C# directly or indirectly, all the classes are inheriting or are inherited from object class. The base for all the types in C# is object class. So if I create an object of customer class, customer C1 is equal to new customer, and if I say C dot, you can see we have those four methods here also: get type, toString, get hash code, and equals. because these methods are coming from object class. If you see here, these are coming from object class object.get hash code. So we are able to print the methods information also using reflection. Now let's understand how we can print out the information about constructors that are available in my customer class. So to do that, we can call t dot get constructors method, right? And again, this will have constructor info as the return type. Let's call it constructors, and again use a for each loop to print the constructors. If I run this application, you will notice something different thing. For constructors, because the name of the constructor is always same as the name of the class, that's why we are seeing .ctor here. Because the name of the constructor is nothing but the name of the class, that's why C# is printing just ctor. But we can print the parameters that customer is taking using reflection so that we can distinguish between these two lines. So to do this, what we can do, we can read the parameters properties of the constructor. So what I can do, I can call constructor dot get parameters, right? And you can check the return type of it. It is parameter info. So let's create an object of parameter info and let's call it parameters. And again, within this for each loop, we can create one more for each loop and we will iterate through all the parameters that are available like this. So first I will print the parameter name and then I will print the parameter type, right? So I can say param dot. Let's run the program. You can notice here for the first constructor we have not printed any data type because first constructor is parameterless, but for the second parameter we have printed name and address and we can see the data type also. First one is system.string because we are using the string data type here for name, and the address is also string type, that's why we are seeing the string type for this also. We can use this parameters info for our methods also, right? Let's copy this code. Let's run the program again and we can see for our print address and print name we are not getting anything because both of these methods are not expecting any parameter. But let's say for example, let's add some integer parameter, string parameter and a boolean parameter just to show we are able to print it using reflection. And if I run the program again, now we can see for print address we can see A, B and C and we can see their data type also. So using reflection we can read methods, properties and constructor information. So to summarize this video, reflection in C# is a powerful feature that allows us to inspect and manipulate code at runtime. So at runtime, we can read the metadata of an assembly. Reflection in C# provides us the ability to examine types, their members, and invoke methods dynamically. In the next video, we will understand how we can create objects dynamically and we can invoke methods and manipulate properties dynamically using reflection classes. The main use cases of reflections are loading assemblies at runtime, intercept how assembly defines a particular item such as class or enumeration. Using reflection, we can get information about a property such as what is the type of this property and we can check if it is read-only or not. And using reflection, we can get information about the attributes that are added to our class members. So that's it for this video guys. In the next video, we will understand reflection in detail. Hello and welcome to part 54. In this video, we will continue our discussion on reflection. In the last video, we have understood the basics of reflection. We have seen how reflection can be used to read the metadata of the assembly. And in the last video, we have learned how we can get details about methods, constructors, properties, class fields that are available in a class. Let's first go to Visual Studio and understand what we mean when we say early binding. I have opened up my Visual Studio and I have created a very simple class with name customer. Customer class is having only one method, that is get full name. Get full name expects two parameters, first name and last name, and it will concatenate those first name and last name and return the full name of the customer. So in a normal scenario, I mean in the 99% of the scenario, what we will do, we will create an customer object like this, right? We have created an instance of customer class and we have used the get full name method and we have passed our parameters. Let's save the result of it in a variable. Let me call it string space result. At the end, let's print the result. And we can see we have printed the full name Peter Parker. So this is what we have been doing in this video series till now. And this is called early binding because at the compile time, we will know where we have the customer class. So when we type customer, this C# compiler will know the customer class is getting referenced from here. If I mistype this name, maybe customer, let's say I mistyped it to customer with double R. Now you will notice we are getting an error here. It will say customer could not be found. Are you missing a using directive or an assembly reference? The compiler now is not able to find our customer class, and that's why we are getting the compilation error. If I try to build this application, you will notice the compilation will fail. You can see the message here, one failed. It means build was not successful. And if you go to the error list, you can see the error message here, customer could not be bound. So it is very important when you are doing early binding, we have to provide the proper syntax. And the benefit of doing it is we can avoid runtime errors. At the compile time itself, we can see what are the errors is there in our program, and this way it will help the developer to reduce the number of bugs. So for now, let's correct this class name, and along with classes, early binding will help in detecting errors when using methods. Let's say if I mistyped my get full name with maybe, let's say if I type get complete name, that time also we will get the error message. It will say customer class does not have definition of get complete name. So these kind of errors can be easily detected using early binding because the compiler will not go ahead and build our program. And if the program is not built, of course, we will not be able to run the application. Along with that, I also want to show you, even if you have the correct method name, compiler will also check the parameters that we are passing. Let's say if I don't pass a string parameter to it and pass some number here, we will again get the error message because compiler is also checking the data types here. Because the first parameter is of string type, that's why we are not allowed to provide some integer value here. Let's go back to slides now. In early binding, we will have compile time resolution. The compiler knows the exact type of the object we are working with at compile time itself. This means we can easily verify our methods, properties that are available for the object. Early binding will provide you fast performance because everything is checked at the compile time. Early binding generally leads to faster execution. Better error detection. As we have seen, in early binding, compile time checks will help us to catch errors early on. This way we can prevent runtime exceptions. Okay, now that we have understood the early binding, let's move on and understand what is late binding. Reflection uses late binding to provide us the information about metadata of an assembly. Let's understand how. When we are doing the late binding, it doesn't matter if we have the customer class with us or not. Let's say I have type T equal to type dot get type. And within this get type method, I can provide my customer class namespace or the customer class fully qualified name like this. So even if I comment out here and if I try to build the application will build successfully. And even if I misspelled the customer class, let's say customer like this, and try to build the application, that time also the build will succeed. And now we are not able to detect the errors because this is late binding. At the compile time, we will not check for errors. At the runtime only, when the code will actually run, we will go ahead and try to get this type. If I put a breakpoint here and run the program, you will notice type will be null because we are not able to find this customer class, right? So in case of late binding, the types will be resolved at runtime, right? The specific type of object is determined at runtime. This can be useful when working with unknown objects or implementing features like plugins. Usually, when we use late binding, the performance will be slower. Late binding involves additional checks at runtime. So instead of checking the errors at compile time, we will be doing it at the runtime. This will make our program slow. Potential runtime errors. Since type verifications happen at runtime, there is a chance of errors like calling a non-existent method. So let's go back to Visual Studio and understand more about late binding. Here again, I have my class customer and I have created a type T. Let me again make it customer. Now, if I want to create an object of customer class, what I can do, I can use activator class and I can invoke create instance method, and within it I can pass the T. T is nothing but the type of which we want to create the object. And let's store the object instance that is created by activator in an object type variable. Okay, this is fine. But let's say I mistype my customer class now. I will say demo.customer2. And now if I try to create the instance of customer2 class, let's see what will happen. If I run the program, you will notice we are getting the argument null exception because at line number 12, when we try to execute get type method and pass down demo.customer2, the .NET framework will not be able to find this particular class and T will be null here. And we cannot call create instance method with a null type. That's why we are receiving this runtime exception, argument null exception, value cannot be null. So guys, it is very important to make sure you are providing the names correctly, else we will receive the runtime errors. So now I have the proper spelling of my customer class and the object will be created using activator dot create instance method. Once we have the object, what is the second step? Second step is to find out the get full name method. To find this method in reflection, we have the method that is known as get method. So on this T type, I can invoke get method, right? And within this, I need to pass the method name. And the name of the method is get full name, right? And the return type of this method is method info. So let's create an object of method info type. Let's call it method equal to whatever the method is returned from this statement, right? Once we have done this, now we have our object, we have our method. What is the third step? Third step, we have to arrange our parameters that we have to pass to our method. because we have two parameters here. So let's create an string array. Let's call it parameters or params equal to new string array, and let's pass the first parameter as hello and second parameter as world. Okay, so now we have our object here, we have our method here, and we have the parameters here. Let's change the name of it because params is a keyword. So now we have the object, method, and parameter. Now we need to do the final step, that is actually go ahead and invoke this method. For that, we can call method dot invoke. And invoke will take two parameters. One is the object. So we have the object obj, and second one is the parameter that we have to pass to our method, like this. And if you check the return type of it, it is an object, right? But we know our get full name will return a string data type. So let's create a string variable, string result equal to. If you notice, we are getting an error here because we cannot convert object to string directly. For that, we have to do the typecasting. So let's provide the string here to do the typecasting. So once the typecasting is done, we can go ahead and print the result which we have received using console.writeLine. Right? And let's run the program now. You can see our program is running and we have printed hello world message here. So we have successfully executed a method using reflection. But point to notice here is it is very important to provide the correct names when using the reflection. If I mistype this get full name here, and if I run the program now, you will notice we will receive the exception at runtime. We are receiving null reference exception, object reference not set to an instance of an object. Because at line number 16, when we try to get this method get full name 33, it will return the null here because we don't have any method with this name. So we have to be very careful when using reflection and when we are doing the late binding. That's it for this video, guys. In the next video, we will learn about generics. Hello and welcome to part 55. In this video, we will learn about generics. Generics in C# is a way to create code that can be used with different data types. We can create generic classes. We can also create generic methods. When we are creating generics, we normally use these angular brackets. In C#, generics is used at many places. There are a lot of useful classes that are available in C# that can be used by developers to make their code more readable. The most popular one is list. List can be used to store a collection of items. Let's go to Visual Studio and understand what is a list. Let's create a list object first. If you notice here, when I type list, the IntelliSense is giving me the option or the suggestion to put these angular brackets. Angular brackets mean I can specify the data type, meaning which type of item I want to store in my list. If I want to store integers in my list, I can specify integer here. Let's call it numbers. And now I can store numbers in my list like this. I can use the add method and add the integer like this. So list is a generic class which is inbuilt in C#. Let's go to implementation of this class and see how it was created. If I right click on this and select go to implementation, the list class will get opened up and we can see in the definition of list class, we have used these angular brackets, and within these angular brackets, we have provided the T here. T means the type. So this is how we can create generic classes. Similarly, we can see the generic methods also here. So this is one of the generic method that we have used in our program, meaning when we are calling add method, we have passed 12 here. But if you see the implementation of add method, it is a generic method, so it can take any data type, right? But because we have declared the list object with integer here, this list is now type safe. We cannot add any other data type here. Like if I say nums dot add, if I try to add a string here, we will get the compilation error. You can see here, cannot convert from string to integer. So when we're using the generic classes, it will provide the type safety also. And I have created the list here of integer type, but we can create list of any type. Like I can provide string here. So using generics, we can use the same classes, meaning we are using the list class with different data types. This is the flexibility that is provided by generics in C#. So let's go ahead and try to understand generics with some custom code. Let me create a class. Right. So I have a very simple class with the name tool. This class has one method is equal, and currently it is taking two parameters, integer a and integer b, and it is checking if these integers are equal or not. If they are equal, we are returning true. If they are not equal, we will be returning false. Let's try to invoke this method and see if it is working or not. So first of all, let's create a reference of tool class. And because the is equal method is declared as static, so we don't have to create objects of this class. We can directly invoke is equal method. Now let's pass 4 and 5. And let's store the result, whatever is coming from this method, in a bool variable. Let's call it result. And finally, let's print the result. And run the program. You will notice we are receiving the false here because we have passed 4 and 5. Okay, so our program is working. But now let's say a requirement is you want to compare strings also with this method. You want to compare floats also with this method. In normal case, this will not be possible. If I try to pass a string to our is equal to method, this will give us the compilation error because is equal method cannot deal with string data type because the parameter is marked as integer. One solution can be, instead of using integer data type, we can use object data type. And we can pass string here, ABC. And if I run the program, this will work fine. We are getting true. So this method now can work with integer also. Let's say result 2, and this time instead of passing string, let's pass integer 1 and 1 and print the result 2 now. And if I run the program, we will receive false here because we cannot compare two objects with equal to operator. For that, we need to use a dot equals method and pass the second object in this. Now if I try to run the program, you will see we are receiving the true result here. Now we are able to compare strings and numbers using only one method, is equal. So now is equal is supporting all the data types that are available in C#. But this is not the correct way to do it. Using objects should be the last option that you should be doing while writing the code, because when you are passing string to a method that is expecting an object data type, what will be happening here? The string data type will be casted to object type, and this is very expensive operation, meaning it will take a lot of time to convert or the typecast the string to object type. This is called boxing and unboxing. We will understand the concepts of boxing and unboxing in our upcoming videos. But for now, we can understand this is not the correct way to handle these kind of scenarios. Because let's say if I try to pass the second object as ABC, we will not receive any compilation error because the data type is object. Even if I pass any data type, this will not give the compilation error. If I try to run this application now, it will again run, but currently we are comparing 1 with ABC. We should not be allowing this in our program. Now the program is not type safe, right? To make our program type safe, we can use generics. So let's go ahead and try to create this is equal method, a generic method, so that we can work with multiple data types. Let's remove this code for now. Instead of mentioning the data type directly here, what we can do, we can just mention T here. T means type. This is not mandatory. We can even give some other alphabet also. And once that is done, we have to provide that alphabet in the Anglo brackets like this. Let's change it to T. Now let's see how we can invoke this generic method. Let's create a variable of Boolean type and call it result equal to tool dot is equal method. And within this, I need to specify the data type which I will be passing to my parameters. If I specify string here, meaning the generic method is equal will be used with string data type. Now I can pass only string to my parameters. You will notice here when I hover over is equal method, it will say string and it is expecting string parameters. Now our method is type safe. If I try to pass some numbers here, let's say some random number, we will receive the compilation error. It will say cannot convert integer to string type. If I pass XYZ here and let's print the result just to test if our method is working properly or not and run the application, we will receive false. And if I give the proper string here ABC and run the program, we will receive true. So our is equal method is working perfectly with string data type. But the beauty of generic methods is we can change the data type according to our requirement. Let's suppose I want to compare two integers. Now I can change the string here in the Anglo brackets to integer. Now it will expect integer parameters. Let's pass 4 and 5 and run the application. We will get the proper result. I can change this data type to anything which I want. I can change it to Boolean. Then it will expect Boolean data type as parameters. Right? So the point that I'm trying to make here is if our method is generic, it can handle any data type. Similar to methods, we can have generic classes also. Let's understand this also with an example. Let's remove this method for now. And to create a class generic, we have to use Anglo brackets again. And we have to pass T here. Once we have declared T, now we can use this T type like as any other data type. Like I can create fields using this type. So I can say T underscore data like this. And I can create a method. Let's change this data type from static to the instance field so we can understand how we can create objects of classes which are generic. So we have a get method and we have the set methods, and if you notice in our class we have not specified any data type here. Our class is independent of the data type. How we will create objects of generic class? It is very simple. When you are creating the object of the class, I can pass the data type when creating the object. I will pass string here. Let's say equal to new tool string. Right? Now the object is created and we can simply go ahead and set the data. Let's pass hello world. All right. Once data is set, we can again call our get method to get the data, and let's store the result in a string variable, and at the end print the result. Let's run the program. You will notice we are receiving hello world message. So this is how you can use your generic class in your program. Now if I want to make use of integer data type in my tool class, I can just change the data type here to integer. And because now set is expecting T data and T is now integer, we should be passing numbers here. We cannot pass string because you can see the compilation error cannot convert string to integer. So we should be passing integer here. And again, we cannot store get result in a string variable because if you see the return type of get is t and t is now integer. So we should be having an integer variable. And if we run the program, you will notice we are receiving 45 here. So guys, this is how you can use generic classes and generic methods in C#. Okay, so these are some of the other generic data types which are inbuilt in C#, which are collections, dictionary, queue, stack, and list. In the future videos, we will understand all these data types of C# in detail. To summarize, here are the benefits of using generics in C#. Versatile. If we use generic in our code, this will make our code more versatile, meaning it can be used with different data types, which makes it more reusable. When we write generic code, it is more concise than writing the non-generic code, meaning we don't have to write different methods for different data type. Generic code will improve the performance of your code because there is no need of typecasts, meaning there is no need of doing boxing and unboxing. When we write generic code, this will make our code type safe and it will ensure we are using the correct data types. So guys, this was all about generics. In the next video, we will learn about toString method. Hello and welcome to part 56. In this video, we will learn about toString method. ToString method is very common in C#. In fact, ToString method is available to all the objects because if you look at this screenshot, in object class itself, we have the ToString method. As we already know, every class in C# is directly or indirectly inheriting the object class. Because of that, ToString method will be available to every object of C#. That's why you will be able to invoke this method on any type of object. Let's go to Visual Studio and understand this. So let's try to create some integer a equal to 5. And if I say a dot, you will notice I have the option to invoke toString method here. Basically, what toString will do, it will convert specific data type to string data type. So if I invoke toString on an integer, it will convert that integer to a string. If you see the return type of this method, it is a string type. So I can store the result in a string. And if I run the program, I will see 5 as the output. So the purpose of toString method is to convert any data type to a string representation. So it is fine, like for integer, floats, boolean, we can convert them to string data type directly. But what will happen if we have a complex data type? Let's say I have a customer class. Okay, so I have created a customer class with 3 properties: first name, middle name, and last name. And if I create an object of my customer class, okay, so I have assigned 3 properties to my customer object: first name, middle name, and last name. And if I try to invoke toString method on my customer class, let's see what will happen. String s equal to customer dot toString. And if I print this string and run the program, you will notice something different. You will see we are printing the namespace of the customer class because the customer class is present inside the demo class and demo class is present inside the demo namespace. That's why we are saying demo plus customer because this is a nested class. That's why we can see plus here. If I move my class from demo class and put it outside at my namespace level, and if I run the program now, you will notice we will get demo.customer. So this is basically the fully qualified name of my class. And this is something that is not very useful for users. What user will want when we invoke toString method, we should get a complete customer name, meaning we should get first name, middle name, and last name. For these kind of scenarios, we can overwrite the implementation of toString method. We can just go ahead and write override, and if I put space here, I will get three options equals get hash code and toString. So let's override the toString method. Once we do this, it will create a method for us and we can provide our implementation here. So this time we don't want to return the customer class fully qualified name, but I want to print first name, middle name and last name. So I can provide my implementation here. I can say, so we have concatenated the first name, middle name and last name, and we are returning it from our toString method. So now if I invoke the toString method on customer object like this and run the program, you can see now we are getting the Peter Sam Parker. This is our complete name of the customer. So guys, this is how you can implement toString method and you can customize it as per your requirement. So if you look at this slide, in C#, every object has toString method that we have seen because toString method is present in object class, and in C#, every class is inheriting object class. So toString will be available to them and it is a virtual method. That's why we were able to override this method like this in our customer class. You can call it directly on any object. As we have seen, we were able to invoke toString method on integer and we are able to invoke it on complex types like customer class. Okay. And we have already seen it converts the object to its string representation. By default, it will give the fully qualified name for the complex types. But if you want to change that implementation and if you want to provide your own implementation, you can go ahead and override the toString method and provide the logic that you want to give in your class. And guys, toString method can also be used to format the data types. Let's say you have some integer and you want to format that integer in some particular format. Let's understand with an example. Let's say you have an integer, let's call it number, equal to 1 2 3 4 5, and what you want to do, you want to print it like you want to append 3 zeros and after that you want to print 4 5 6. So basically you want to make your number as 8-digit number, right? You want to append 3 zeros in front of your number. To do this, you can use toString method. Let me show you how. You can call number dot toString, and in this case we can pass a parameter that will take the format in which we want to format it. Like we want 8 digits, right? So we can say D8. D stands for digits and we want 8 digits in our number. So we can say 8, and if I run the program now, you will notice the C# has appended 3 zeros in front of 1 2 3 4 5 to make it complete 8 digits. And if our number has one more digit, like now we have 6 digits, in this case we should only be adding 2 zeros in front of it. If I run the program, you will notice as expected it has added only 2 zeros. Similar to numbers, we can also format dates using toString method. Let's create a date object. For that you can say datetime. So datetime.now will give us the current date. So first let's try to invoke toString method on this without any parameter and see what result we will get. String s equal to datetime. Let's see what result we will get. Okay, so now we are getting the date in this format. So this is the date we are getting without any formatting. But let's say we want to format our date in some particular format. Let's say you want to print the date in this format. First you want to print the day. Let's say if it is Friday or whatever date is that you want to print. And after that you want to print the date, what date we have. Then you want to print the month name. And after that you want to print the year. To achieve this, what we can do, we can pass the format like this. So within the toString, I will pass 4 times D, and if you see the suggestion here, it says day of the week, and after that we can put a comma because we want a comma in our output. So after putting comma, we can put a space and say dt. dt will give you day of the month. That's what we want. We want the date. After that, we want name of the month. To get the name of the month, you can give m 4 times. If you see here, this will give us the month full name, right? And at the end, you can give y 4 times. It means the year, right? We will get the year in 4 digits. If I run the program now, you will notice we are getting the current date Wednesday, 19th June 2024. This is the date on which I'm recording this video. And guys, on this slide, you can see all the possible formats that we can use in our toString method, like mmddyyy to get the date in this particular format. And this is the one which we have seen in this video. We were able to print the date in this particular format. And similarly, at the end, you can see there are some formats for the time also. So if you want only the time component from the date, you can use this format. So I have opened up my Visual Studio. So now let's get only the time. To get the time, we will say HH MM to get the minutes, right? And if I run the program now, you can see we are getting only the time this time because we have specified this particular format. So guys, you can use any of this format, and I will provide the link of the website from I have taken this particular screenshot. And guys, that's it for this video. In the next video, we will learn about equals method. Hello and welcome to part 57. In this video, we will learn about equals method. In the last video, we have learned about toString method. Just like toString method, equal method is also available in all the objects because it is directly available in the object class. So in Visual Studio, if I create an integer a, let's initialize it with 10. And if I say a dot, you will notice I have the option to use equals method, and I can compare the value of a with whatever value I will pass within this method. So let's pass 20 and just print the result of it. If you run the program, you will notice you will receive a false here because 10 is not equal to 20. So as the name suggests, equals method is used to compare the equality. For value types, we can use dot equals method, or we can directly use equal to operator also. So if I want to compare a number with some other number, I can use equal to operator and pass some value here. Even I can provide some variable also. Let me declare integer b equal to 10, and let me check if a equal to b. And if I run the program, you will notice we will receive the true here. So for simple types like integer, strings, floats, booleans, even enums, we can use either equal to operator or we can use dot equals method. So let's understand this with an example of enums. So let me create an enum. I have created an enum with direction name, and as we all know, we have 4 directions: north, south, east, and west. So let's see how equal to operator and dot equals method will work on enums. So let's create 2 directions. And if I say T1 equal to D2, let's see what we will get. We are receiving false because D1 and D2 are different. And if I change it to north and run the program again, I will receive the true. And same thing I can achieve using equals method. D1 dot equals, and I can pass d2. So what is happening here? I am invoking dot equals method and I am passing the object with which I want to compare my d1 object. So I want to compare my d1 enum with d2. So we can use equals method, and if I run the program now, you will notice both are giving us same result. So for simple types, you can use equal to operator, and you can use dot equals method also. Okay, so point to understand here is equals method do a shallow comparison. It means it checks if both objects refers to the same memory location. You can override this method in your custom classes to define your own logic equality. So now let's understand how equals method will behave in case of complex type like classes. So let me create a class. And I have two properties, public name and let's say email address, right? And now let's go ahead and create object of our customer class. Customer C1 equal to new customer and customer C2 equal to new customer. Okay, now let's assign some value to our properties. If you notice here, our customer C1 and C2 are having exactly same properties. Name is equal to Peter and email equal to peter@123.com. So both these properties are matching. And let's see what will happen if I try to check equality for these two objects. If I say C1 equal to C2, and let's check it with the equals method also. So if I invoke equals method on this and I pass my C2 object, and if we run the program, you will notice we are receiving false here. Because what is happening in this case, C1 is pointing to a different memory location and C2 is pointing to a different memory location. That's why when we are comparing C1 equal to C2, it is giving false. But for now, let's do one thing. Don't create a new object for C2. Let's comment these lines. And let's say customer C2 equal to C1. So what we are doing in this case, we are not creating a new object. What we are doing, we are just making sure C2 is pointing to C1 customer. Meaning now the memory location in C1 and C2 is exactly same. Both are pointing to C1 object. If we run the program now, let's see what will happen. In this case, we will receive true here because by default, equals operator will check for the memory location of the objects. C1 variable and C2 variable are both pointing to this particular object. That's why we are receiving true here. Whereas in our earlier case, when we were having a new object for C2, we were receiving false. Right? Currently it is false. But let's say in our application, what we want, if two customers are having name and email address as same, we should consider them as equal objects. Meaning when we invoke dot equals method, it should return us true if name and emails are same for those customers, which is not currently happening. Even though we have name and email same for both the objects, but because they are holding different memory location, that's why we are receiving false here. So to tackle this problem, what we can do, we can override equals method and provide our own implementation. Let me show you how. You can type override and put a space here. You will get option to override three methods. So let's go ahead and implement equals method in this case, right? So let's remove this and provide our own implementation. Let's say if object equal to null, return false. because if we are passing a null here, we should not go ahead and compare the object. We can directly return the false from here. And if object is not customer, then return false, because the parameter is of object type. And if someone is trying to pass down something of object that is not of customer type, that time we should not go ahead and compare the object. We can directly return the false here. But in case the object is not null and it is of customer type, we can go ahead and compare the properties of name and email. We can say boolean result equal to this dot name equal to obj dot name. You will notice we will not get the option to use name property here because this is of object type. So we have to typecast this object to customer type. Along with that, we should also be checking if the email are equal or not. So let's copy this logic and use it for our email address also. And at the end, let's just return this result. Right now we have successfully overridden the equals method. Now if we try to run our same program, meaning if we try to compare c1 and c2 object using dot equals method, let's see what will happen. This time you can see our equal to operator is still giving false because both the memory location in c1 and c2 are different. But when we are executing dot equals method, that time, because now we have overridden and provided our own definition here, like we are telling the C# how I want to compare my object. I want to compare it based on name and email properties. So that's what happening here. We are comparing the object using these two properties, and because these two properties are equal in both the objects, that's why we are seeing it true here. So equals method is returning true from here. All right, so guys, this is how you can override equals method and provide your own implementation and customize your classes. Next point I want to discuss is case sensitivity. By default, dot equals method is case sensitive, meaning if I try to compare two strings and if we check it using equals operator, S2, we will receive a false because by default equals method will do case sensitive comparison. You can notice here we're receiving false. But if at all you want to do a case insensitive comparison, you can pass the second parameter here that says string comparison dot ignore case. So we can ignore the case using this particular parameter, and if I run the program now, I will receive the true here because now we are not doing a case sensitive comparison. So that's it for this video, guys. In the next video, we will learn about the difference between the toString and convert.toString method. Hello and welcome to part 58. In this video, we will learn the difference between convert.toString method and toString method. So let's go to Visual Studio and understand this. As we have already seen in the last video, toString method is used to convert any data type to its string representation, meaning we can convert any data to string data type. Suppose I have an integer a, let's say 500, and I can use toString method on this like this, and I can convert my integer a to string. If you see the return type of it, it is of string type. That's why we are able to convert an integer to a string data type using toString method. Same thing can be achieved using convert.toString method. Let me show you how. I can use convert class that is available in system namespace, And from convert class, we can use toString method, and we can pass our integer here, and we can convert our integer to string using this method also. So basically both of these methods will convert any data type to string data type. But now let's understand what is the difference between these two. The difference will be visible when we work with complex data types. Let's say I have a class customer and it has a property name, right? And if I create an object of customer class, let's assign some name to our customer. And if you run the program, you will notice we will see this fully qualified name of the class. So this is the default behavior of toString, even though same behavior we will see with convert.toString method also, right? If I run it, I will again see the fully qualified name of the customer. Okay. The difference between the toString and the convert.toString method is that if the customer object is null, that time convert.toString will not throw an exception, whereas toString method will throw the exception. Let me show you. Let's say I don't initialize the customer object to anything. And if I try to invoke toString on my customer object now, we will receive the exception here because we cannot invoke toString method on null objects. So if I run the program, you can see we are getting the null reference exception. It says object reference not set to an instance of an object because C1 reference is not initialized with any object. So it is not allowed to call toString method on null objects. Whereas we can still go ahead and use convert.toString method on null objects. And let's see what will happen when we run the program. Let me put a breakpoint here. You will notice we have not received any error message here. In fact, if you check the string s here, you can see it is blank string. So basically convert.toString is not throwing the exception, and if it finds the object passed to it is null, it will convert that null value to a blank string. And if I complete this execution, nothing will get printed because it is a blank string, so we cannot see anything on the result window. So guys, this is the basic difference between the toString and convert.toString method. We cannot invoke toString method on null references, but we can go ahead and call convert.toString method using null references. And that's it for this video, guys. In the next video, we will understand one of the most important interview question, that is difference between string and string builder. Hello and welcome to part 59. In this video, we will understand the difference between string and string builder. This is one of the very frequently asked interview question, and in this video, we will understand the difference between string and string builder in detail. Basically, string in C# is immutable, whereas string builder is mutable. When we say something is immutable, it means that thing cannot be changed. Meaning, if I create a string in C# and I try to change that string to something else, in that case, old string will also remain in the memory and we will create a new object for the string. Let's suppose I have a string, user string variable. So this user string variable will get created on stack, and I am storing C# in my user string variable. So what will happen? This user string will point to the C# string on the heap. And let's say if I changed my user string to C# video, what will happen? The C# object will stays in the memory and our variable will point to a new object on the heap. Similarly, if I change my string again, then it will again create a new object of string on heap and the variable will point to it. And similarly, if we change the string again same thing will happen. We will not destroy the earlier object, we will create new objects instead of that. This can cause
performance issues, because now you see here we have one, two, three objects. Now we have three objects which are not referred by any variable. It will only be cleared from the memory when the garbage collector will come. So when you are dealing with something where you have to do heavy manipulation on string, you have to choose string builder instead of string. So let's open up the Visual Studio and understand how we can use string builder. So when you create a string, so what basically is happening, a variable A is getting created on stack and C# object string is getting created on the heap, and a variable is pointing to this particular object string. Okay, and if I change my string to something else, if I say, right, so what will happen in this case, the earlier object of string C# will stays in the memory and a new object will be created with the value C# video, and our a variable will point to that particular object. And let's suppose if our program is doing 1000 manipulation, in that case there will be 1000 objects which will be stays in the memory. To avoid this, we can use string builder. To create a string builder, you need to use string builder class. This class is available in system.text namespace. So let's create a string builder. So now what we can do with string builder, we can call append method and we can append our string which you want. Okay, and if you want to manipulate your string further, you can simply invoke append method again. I can say video, and let's append one more time tutorial. Okay, now effectively I have modified my string 3 times, but in this case we will not create 3 different objects. Only one object of string builder will be created and all the manipulation will be done on this particular object. And at the end, if you are done manipulating your string, you can get the final result using the toString method. So on SP object, you can invoke toString and get the final string. Let's print this string using console.writeLine and run the program. As expected, we are getting the complete string C# video tutorial. So guys, this is how you can use string builder and avoid creating multiple objects in memory. You can understand the same thing on this slide also. When we use string builder is mutable, so we can modify the object, and in this case we have only created one object. But in case of string, it had created 4 different objects and only one object was referred by the user string variable. On this slide, we can see all the difference between string and string builder. First difference that we have seen, string is immutable, right? We cannot change the string once it is created, and string builder is mutable. We can change the string builder object whenever we want using the .append function. A string is available in system namespace, whereas a string builder is available in system.text namespace. As we have already discussed, a string cannot be modified, but we can use insert, replace, or append on string builder object. String is slower than string builder because it creates new instances for every time. If we take this example, string a equal to 1, b equal to 2, and when we say c equal to a plus b, in this case 3 different string will be created, right? Whereas we can achieve the same thing using append method. In this case, C# will not create multiple objects for us. So to conclude, string objects are immutable, but string builder object is mutable. When we use string builder, it will not create a new modified instance of the current string object, but it will do the modification in the existing string object. So when the user needs the repetitive operations on the string, then we need to use the string builder. It provides an optimized way to deal with the repetitive and multiple string manipulations. And that's it for this video, guys. In the next video, we will learn one of the advanced topic of C#, that is partial classes.
Hello and welcome to part 60. In this video, we will learn about partial class. So I have opened up my Visual Studio. What you might have seen in this video series, we were creating classes in the same class file. Meaning we have this demo class file. You can see on the right hand side demo.cs, and within this file we were creating some classes, like I was creating public class customer. Like this we were creating classes, but this is not the right approach. In the real world we will create a separate class file for a separate class. Currently, if you see here, we have demo class and customer class within one demo.cs class file. This can cause confusion. So the best practice is we have to create classes separately. So let me choose add option here and select the class option here. And I will give the class name as customer. And this will create a class for us. Now, if you see, I have a separate class file for my customer class. Let's make it public for now. Okay. So this is how you can create class in a separate class file. But what is a partial class? What we can do with partial classes, we can split a single class into multiple physical files. Let me add one more class file. So this is a second class that I have added. Okay, now if I try to change the name to customer here, we will get the error message because as you already know, we already have the customer class in customer.cs class. So we cannot create a new customer class in different file. If I try to build this application, you will notice we will get the error message. Demo_string already contains a definition of customer class because we already have this customer class in this file. So to overcome this problem, if you want two physical files for a single class, you can use partial keyword. So if I use partial keyword here, and if I use partial keyword here also, and if I try to build my application now, you will notice one build succeeds and we are not getting any compilation errors. So this is basically the main idea of having partial classes. Using partial classes, we can have two physical files for a single class. And you might be asking me, what is the benefit of this? The benefit of using partial classes, now different developers can work on two different physical files. Their work will not conflict with other developers' work. So now that we have understood how to create partial classes, let's understand some more features about partial class. A partial class is a special feature of C#. It provides a special ability to implement the functionality of a single class into multiple files. As we have seen, we have created two physical files for a single customer class, and all these files are combined into a single class file when the application is compiled. A partial class is created by using partial keyword that we have already seen. Okay, so this is how the partial keyword will work. If I have products class, you can see I have file1.cs and file2.cs, and both are having partial keyword in it. Means we have created products class as partial class, and in the one class file I have the class fields, private string name, and I have a constructor that takes a string parameter, and so whatever parameter is coming to the products constructor, that is getting assigned to the name class field. And in the second class file, we have a method getDetails. So what will happen when we compile this application? The C# compiler will check for this partial keyword and it will merge both of these files into one class file. If you see here, this is the compiled code. You can see the products class. Now it has the class field, it has the constructor that is from the first file, and it also having getDetails method also, because it was present in file2.cs. And just to note here, it is not a rule to have only two class files. We can have more than two class files also. So if I go to Visual Studio and try to create one more class file, let me call it customer 3. Let me change it to public and use the partial keyword. This is also fine. Now we have three partial classes for customer class. Okay, now let's understand the behavior of partial class. So now I am in my first class file, that is customer.cs. If I have a method here, public void print, let me print from class file 1, right? And put this method in other classes also. So this is second class file. Let me call it print2 because we already have the print method in this file, so we cannot have the same method in second file also. If I try to create with the same name, we will get the error. Type customer already defines a member called print with the same parameters. Either we have to do the overloading, else we have to provide a different name. Let me put print2 here and let's call it from class file 2. Similarly, let's put this similar method in file 3 also. Let's call it print3 and from class 3. Okay, so now we have customer class that is divided across three files: customer.cs, customer2.cs, and customer3.cs. But when we compile this application, all three files will be merged and one single class file will be generated. Because of that only, if I try to create an object of my customer class, and if I say customer dot, you will notice I have the option to invoke print, print2, and print3. This is because C# is combining all those three files and giving us the option to use any of the method which is available there. So let's invoke print method. Print2 and print3. And let's run the program. You can see we are able to invoke all those three print methods from different class files. Okay. And if you have defined something in your partial class, let me create a property. Okay. Now this property will be available in other class files also. If I go to my second customer class, that is customer2.cs, and if I try to say this dot name, I have the access to name property, even though you cannot see the name property in this class, but because it is a partial class and the part of this class is available in customer.cs class, and in this class we have the name property. Because of this name property is available in customer2 class also. And the point to notice here is, even if I create this property as private, still I will be able to use this property in my second class file. Even though the property is defined as private, but still it is part of customer class. That's why we are able to use the private fields also in this class. And now let's go to customer 3 class and try to print the name of the customer in this class. Let me call CW, and we can again use this dot name property. And if I run my application now, you can see we are getting from class file 1 from the print method. We are getting from class file from the second print method. And in the third class, because we are printing the name of the customer, that's why we are seeing Peter here. You can see here in the print3 method, we are just printing the name of the customer. So guys, this was the introduction about partial class. In the next video, we will learn the partial class in more details. To summarize, the advantage of using partial class is that with help of partial class, multiple developers can work simultaneously in the same class but in different class files or different physical files. And guys, partial classes are used by .NET also. Let me show you where .NET is using partial classes. Let's close the Visual Studio and open the Visual Studio again. Once Visual Studio is open, choose create a new project, and this time select this desktop type application and select Windows Form application. click on next, select the default version, click on create, and you can notice here we have a forms class here, right? You can see form1 class and it is a partial class, and whatever code you see in this class is auto generated by .NET. And if you click on this form and select view code, you can see this is also form1 class and it is again a partial class, and in this class you can put your own code. So we have the form1 class here that is having the auto generated code, and we have one more form1 class, and in this class we can write our own logic. So by using partial classes, we can split our class files and maintain our code more efficiently. That's it for this video, guys. In the next video, we will continue our discussion on partial classes and understand what are the other features that are available for a partial class. Hello and welcome to part 61. In this video, we will learn more about partial class. In the last video, we have understood how we can create partial class, and we have understood some of the basic concepts around it. And we have seen how we can split our long classes into multiple physical class files to maintain our code more efficiently. In this video, we will understand the rules that we need to follow when working with partial classes. The point number one is all the parts spread across different files must use partial keyword. It means if we want to create a class as partial, then all the parts of that class should be partial. Let's go to Visual Studio and understand this. Okay, so if you're trying to create a partial class, let me create a partial class. I will select add and select the class here, and I will give employee. And let me change it to partial class. And if I try to add one more class file, so I have the class employee2.cs. Let me change it to employee, and this time I will create it as a normal class. So what we have done in this case, we have two class files. One is having employee with partial keyword. The second one is having the employee class, but it is not mentioning it as partial. This is not allowed in C#, and it will throw us the compilation error. If you read the error message here, it will say missing partial modifier on the declaration type employee. Another partial declaration of this type exists, and because employee class is already marked as partial in this employee.cs class, so every file that is having employee class, that should also be marked as partial, else we will receive the compilation error. Let me mark it as partial, and you will notice the error is gone now. A second point to notice here is all the parts spread across different files must have the same access modifiers. So I have two class files. One is employee.cs and one is employee2.cs. And if I try to change the access modifier here, let me call it internal. You will notice we are getting the compilation error. It will say partial declaration of employee have conflicting access modifier. Here the employee class is marked as public, but in other file it is marked as internal. All the class files should have the same access modifier. If I change my access modifier to internal here also, the error will go and you will be able to build your application without any issues. Right. So we must have the same access modifier for the partial classes. Third point here is if any of the parts are declared abstract, then the entire type is considered as abstract. Okay, so let's go to Visual Studio and understand this. Let me change it to public again. And now let's try to mark our class as abstract. So I have marked my class as abstract, right? And I have not marked my class as abstract here, but because this file is having the abstract keyword, this abstract keyword will automatically get applied to this class file also. meaning the whole employee class is an abstract class. We won't be able to create objects of it. And if I try to create an object of employee class, you can see we are receiving an error message here. Cannot create an instance of the abstract type because we have marked this file as abstract. The whole employee file will become abstract and it will behave as an abstract class. Next point is if any part of the clade sealed, then the entire type is considered as sealed. So let's remove the abstract keyword and let's put sealed keyword, right? And we know if a class is marked as sealed, then we cannot inherit that class. So we have added the sealed keyword only in our employee.cs class, but this sealed keyword will get automatically applied just like the abstract keyword. It will automatically applied to employee.cs class also. So if I try to inherit employee class, you will notice you will receive the compilation error saying demo cannot derive from sealed type employee. So this demo class cannot derive from employee class because it is marked as sealed class. Point number 5 is if any of the parts inherit a class, then the entire type inherits that class. Let's understand this in Visual Studio. Let me add one more class. I have added two properties, ID and name. And if I make my employee class to inherit base employee class, okay, so in my employee.cs class, I am inheriting base employee class. So in my employee.cs file, I am inheriting base employee class. And what will happen? This class will be automatically be inherited by this class file also. So in this class file, if I create a method ID, you can say ID is available to me, and you will notice I have the access to name property also. And if you hover over these properties, you will notice these are coming from the parent class, that is base employee class. And you will notice we are not inheriting the base employee class in this file, but because that is inherited in this particular class file, so that inheritance will follow through to this second file also. Okay, so this is how inheritance will work in partial classes. Okay, now the point number 6 is C# does not support multiple inheritance, that we already know. And different parts of the partial classes must not specify different base classes. Let's go to Visual Studio and let me create one more class. Okay, so now base employee 2 class is added. You notice here we have inherited base employee class here in employee.cs class. Let's try to inherit base employee 2 class in this different file. If I try to add one more class as parent class, and if I try to build this application, you will notice the build has failed because partial declaration of employee must not specify different base classes. We have specified base class as base employee here. In second file, we are inheriting from base employee 2 class, which is not allowed. In C#, one class can only inherit from one parent class. So different parts of the partial class must not specify different base classes. Point number 7 is different parts of the partial class can specify different base interfaces. And the final type implements all the interfaces listed by all the partial declaration. Okay. So what this point says, we can inherit from different interfaces, and when we will create the final object of that class, that object will have behavior from all other interfaces. Let's understand this. Let me remove base class for now. Let's create an interface. Okay, let's create one more interface by copying and pasting it again. Let me call it I2 and let's call P2 method here. Okay, so let's inherit I1 interface here. Okay, and let's inherit I2 interface in our second class file and try to build this application. You can see here build succeeds. So it basically proves we can have different interfaces in different class files. This class file is inheriting I1 interface and this class file is inheriting I2 interface. And let's suppose I remove the definition from P1 and P2. Now it is mandatory to provide the definition of P1 and P2. So let's provide the implementation and let's implement I2 in this class. So now if you try to build the application will build successfully. And now let's try to create an object of employee class. You can notice here I have the access to P2 method that is coming from the interface I2, and we have access to P1 method also that is coming from interface I1. So the final object will have behavior of both the interface, even though we have inherited those interfaces in different classes. Any member that are declared in a partial definition are available to all of the other parts of the partial class. What it means? It means if I have a member here, public integer, let's call it number. Okay, so this number field will be available in second file also. So if I go to employee class, you will notice I can access this dot number. So number is available to this class file also. So this is what this point says. Any member that are declared in a partial definition are available to all of the other parts of the partial class. So guys, these were some key points to remember when working with partial classes. In the next video, we will learn about partial methods. Hello and welcome to part 62. In this video, we will learn about partial methods. In the last couple of videos, we have understood what are partial classes. In this video, we will understand what are partial methods and what are the key points that we should remember while working with partial methods. First of all, partial methods can only be declared in a partial class. Let's consider this particular scenario. Here we have a partial class user that is available in file 1.cs and file 2.cs. And within this class, we have declared one partial method. Just like partial class, we will use partial keyword to create partial methods also. So we have created one partial methods, get user details, and point to notice here is this is only the declaration of the method. We don't have the definition in this case. The definition of this method is present in file.cs. Right? If you see here, we have the partial word get user details, and we also have the implementation of this method. When the compiler will run and compile the code, it will look for the partial methods and it will compile those methods in one single file, right? And this is how we will be able to use partial methods. So let's open up the Visual Studio and understand this with an example. Okay, I have opened up my Visual Studio, and if you notice here, I have a partial class employee. Now let's create a partial method. To create a partial method, we have to use partial keyword, and we have to specify the return type, and we have to provide some name to our partial method. Let me say print employee name. Okay, so what I have done here is I have created or I have declared a partial method print employee name, but I have not provided the definition of it. Okay, so let's provide the definition of this method. We can provide the definition of this method within this file, or we can go ahead and provide the definition in different file also. So what I can do, I can go to employee.cs class, and within this file, I can provide the implementation of my partial method. So I have provided the definition of print employee name. And within this method, we are not doing anything. We are just printing employee name Peter using the console.writeLine method. So now let's see how we can invoke this partial method. And guys, one thing to remember, partial methods are private by default. So we cannot invoke partial methods outside the employee class. We have to create a public method. So I have created a public method print, and within this print method, I can invoke my partial method. Print employee name, right? And let's go ahead and create an object of employee class and invoke the public method print and run the program. You can see we are printing employee name Peter. So this is how we can create partial methods. First, we have to declare the partial method, and then we have to provide the definition of it. And because partial methods are private by default, so we have to create a public method, and within that public method, we can invoke our partial method. So guys, this is how partial methods will work in C#. So here are some key points that we should remember. Point number one is a partial class or a structure can contain partial methods. We can only create partial method within a partial class or a partial structure. We won't be able to create partial method in a normal class. So if I go to Visual Studio and let me create a normal class, let me say private class name. Let me try to create a partial method within this class. You can notice here we are getting a red line here. It says a partial method must be declared within a partial type, right? So we can only create partial method within a partial class or a partial structure. Second point is a partial method is created using partial keyword that we have already seen. A partial method declaration consists of two parts. First one is the signature, and the second one is the implementation. Right? So if you go to Visual Studio, you can see here, this is our signature of the method, and we have provided the implementation